Tata Institute of Fundamental Research, Bombay, and now later he became the director at Physical Research Laboratory in Ahmedabad. And still he is continuing his interest in asteroids and meteorites. For us, he is a Bhishmacharya of meteorites. So we pray to you, sir, to bless us all for this occasion, sir. Thank you so much. And again, we have a program schedule. We are sorry we are late in starting this program. We wanted to start it by 10, but yeah, you know what Bombay problems are. Yeah, yeah. We would like to welcome Professor Bandari with a flower bouquet from the director of the Nehru Science Center.
Thank you, sir. Thank you very much.
And we are fortunate to have Mrs. Bandari also here with us. So thank you, madam. We look forward to have you more. आप और अगली बार भी आ जाइए. So we are happy to have both of them for this occasion, and let me assure you, we would like to continue this program every year on June 30th, and we would definitely like all of you young people who are around to support this cause, because this program is not only for us, it is for you all. And today's program, we have lined up a lot of speakers. So you have freedom to ask them any questions, because this program is today available on Zoom as well as YouTube. So on YouTube also. Oh, this is from us, sir.
Thank you so much.
From us to Professor Rasogi. Our host, sir.
I know.
So, with this, I would also like to tell you more about him. Professor Bandari has written books. One of the book which is here is on Chandrayaan. Chandrayaan, and the topic which we have chosen is you are all required for all this kind of a work. Please remember, this is the book which he has already published, and it's there in the library of Nehru Science Center. We would definitely like you to look at this book, buy this book, and it is going to be useful component for you for simple reason. Chandrayaan 4 is going to bring back the moon samples back to Earth. So then we need people like you to analyze this work. We don't want it to be only analyzed abroad. Why? When we are there, we have a competent people around. Why not? So it is not only this book, he has written book on asteroids also. We are trying to republish that book in Marathi, and it is already there in English, and I think we will circulate to you the name of the book and also where it is available. These books are available, but so with that words, I would say Professor Bandari has been working on this. He has also worked on moon rocks. When the moon first mission came back with moon rocks, he was the person who was actually handling the moon rocks. So, with we have a very distinguished speaker today, or rather our guest, and also my mentor. I pray to him that you keep blessing us for such events and also otherwise. So, with these few words, sir, I request you the mic to Dr. Rasogi, sir, to welcome Professor.
It's an honor for me to welcome Dr. Bandari because I can reconnect. I was just telling in 2009 when I was national coordinator, and the topic was Chandrayaan, potential concerns, because there were a lot of things going on, whether India should invest so much money in that project when we have so many other things to do. So that was the topic, and all students they were invited from each state, one student. That's called National Science Seminar. We have been doing it for years. I think it's 82 onwards, regularly on new topic. So Dr. Bandari was the main person because it was related with Chandrayaan, and his book was circulated. He addressed them also. He wrote an article, wonderful article for that souvenir, which we published on that occasion. After that, also, he has been, in fact, regularly connected with Nehru Science Center, some of the programs. I remember during Corona also, we organized one program where he joined online. So it's always a privilege to have on board of any of the program. Asteroid programs we had earlier also 2022. I remember at that time also he appeared out there. So it's an honor. I will not take much time because we are already behind the schedule. With a very warm welcome from all of us to Professor Bandari. I'll request him to start his deliberation address and guide these. I know this topic is very, very important, and I think it is going to be very, very important. The way things are coming near Earth or near Earth objects. So, a lot of things we have to learn, and these young people who are sitting here, perhaps they can provide some wonderful solution without having much damage on Earth so that it remain continues as inhabitable. So, over to you, Professor Bandari. Thank you for being with us, sparing time. I know you are in a transit mode, passing through Mumbai, and it's really a wonderful feeling to have you with us, sparing time. A big thank you for that, sir.
Thank you so much. I'm so happy that director of Nehru Center and Bharatji is organizing this event on Asteroid Day. So I'm also happy to see many young people here celebrating the Asteroid Day. Actually, celebration is not the right thing for asteroid because it brings catastrophe. It's just for awareness. So I would rather use a word, we are observing the asteroid day. And why we are observing it is, there are multiple reasons. There are good reasons and bad reasons. And the best reason for celebrating it is that asteroid give us life. Our life is sustained by meteorites which come on the earth. And nature has very weird ways. Actually, more I think about it, more I am impressed how nature has found the same mechanism for creating life, for sustaining it, and for destroying it. All these three things are done by nature by bringing these rocks from space. I will talk about this a little bit, but the greatest pleasure of my life has been to hold a rock, cosmic rock in my palm. There's no greater pleasure. And a few years ago, we discovered about 20 meteorites in Rajasthan and Gujarat and Madhya Pradesh. So it is not difficult. And I'm here just to provoke you that you should try and you will find a meteorite in your lifetime surely. Because something like one meteorite falls in every 100 years within 10 kilometers everywhere. So if you keep your eyes open and ears open, you are sure to get a cosmic rock in your hand. And that gives you the greatest pleasure. There is no other happiness as far as I am concerned. And I'm sure you will also feel the same way. So, see, Asteroid Day, we are celebrating on 30th June, and you know the reason. The reason is that in 1908, I guess, something fell in Siberia. We have not found what fell it there. You are going to show some slides?
Yeah, if you
Or not necessary?
not necessary.
Not necessary. Okay. So what they found is that all the trees became horizontal. Something has come. What has come, we don't know. It can be asteroid, it can be a comet, and some people say it should be a black hole. But whatever it was, it burst in the atmosphere because nothing, they searched day in and day out for many years. Nothing was found. Only all the trees were fallen. So it brings catastrophe. But such things happen once in a century. That is the probability. It can happen now, it can happen after 10 years, we don't know. But every century there is an event, and we have to be careful. Awareness. So we are here to make you aware of this. But 65 million years ago, and everybody knows, dinosaurs died, became extinct. That event was a very big meteorite, 10 kilometers in size. So you see, what nature is doing is, it brings small bodies, let us say of the order of 10 kilometers or 5 kilometers, and it makes our planet. Those we call protoplanets. That is how our Earth was made. All our water has come from there. Without water, we cannot live. All our air has come from there. So, life created because of that. Then, throughout the history, they are bringing various minerals as we need. 550 million years ago, they brought in phosphorus, which is very essential. Before that, we didn't have mobile living beings, only स्थावर जिसको बोलते हैं ना, static. Because of phosphorus, we developed bodies which could move. That's why we are able to move. So it creates life by meteorites. It brings water and other volatiles and phosphorus and all minerals, and we can live. But at the same time, every 50 or 100 million years, it destroys the life. But dinosaur died, but not only dinosaurs. 70% of the species on the earth died. It is not a small number. It's not that few people died or something. It's not because things happen locally, कि कुछ गिरा है यहाँ, तो something has been destroyed. It creates a series of processes. What happens when something big comes? There is a heat wave. Heat wave means some, let's say 10 kilometer. It fell, actually, we have found out, it fell in Gulf of Mexico in USA. Of course, Trump says it is Gulf of America, but that's a different matter. But it is a Gulf of Mexico. There's a crater under sea, 300 kilometer size. And that also, strangely enough, happened in June. Now, it is, requires a lot of brain to find out how 65 million years ago something happened in June. So scientists have worked on it. What happened? I'll tell you the story, very interesting. When I first learned about it, I was amazed. They can't find the date, but they can't find the month. 65 million years ago. How can they find it? Because when this crater was formed, lot of mitti, lot of ejecta, lot of stones are thrown out. And several tens or hundreds of kilometers was buried. When they dig it, when they dig the whole thing, they found there were lilies blossoming there, which were frozen in the sand. Now, lilies only blossom in June. Those lilies only blossom in June. So that event must have occurred in June. So you see, it's very interesting. It's like Sherlock Holmes. You have to really study it and understand the secrets of nature. So Tunguska happened in June. This asteroid thing, what we call KT boundary, Cretaceous Tertiary boundary, happened in June. So June is a very fateful month. And a lot of disturbances going on around. I'll not talk about that. So it's very interesting as you learn. But you see, I want to tell you about the processes. First, there is a heat wave. So there is a fire on the ground. And we have really found charcoal everywhere, all over the earth, because of that forest fire. Then the ejecta is thrown out, a plume, big dust plume. The sun is covered. So sun cannot come, so there is a cold wave. Solar radiation doesn't come, so no photosynthesis, no vegetable, no trees, no plants, nobody can live. So dinosaur died because sunlight didn't come, and it takes several tens or hundreds of years for the sky to clear. So there is a heat wave, immediate. There is a cold wave, which is very long. There is ejecta, the whole sky is full of dust. And then, because of the atmospheric entry, there is nitrogen in the atmosphere, and uh, there is other elements in the meteorite. So they make HNO3, nitric acid, sulfuric acid. How much? Every square centimeter, 10 liters. So in the ocean, when it falls, the whole ocean become acidic, and everybody dies. Shells and animals, marine animals. So we call it mass extinction. So mass extinction took place. So you see, meteorites are a very fantastic things. They give you life, they sustain life, and they destroy life. It's a miracle of nature. Very efficient way of using the same thing, doing the three different jobs. But it's not that bad. After the mass extinction, new species are born, and they are much better than the old ones. So we have come because of that. So we can say, no, 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 it is bad, all civilization will be destroyed. But that is only one part of it. Bad enough, yes, we want to live forever. But new species will come, will be stronger, better, more intelligent. So this is what is happening periodically all through. The dinosaur event was the fifth event. 4 events happened before. So it is going to happen again. Whatever we may try, or our director साहब may say pollution हो रहा है, सब we should be careful and we should not use resources, but civilization is going to be destroyed and new civilization will come. That is the way of nature. So you see, it is a miracle. We must learn. I have written a book called Falling Stones and Secrets of the Universe. It's translated in 4-5 languages. And I think if you read, you will know that all these things are going on. But the point I want to make here is that it is nature is sending these stones on our doorsteps free of charge. One mission to moon to bring a sample takes billions of dollars, but it is coming free. So we must not take and put it in a cupboard. See, many people do it. If you put in the cupboard, after 1 month, if you open it, there will be nothing left. Because it is made in an atmosphere which is reducing. When it meets oxygen, it gets dissolved or broken or crushed. So I went to Pipalia Kalan where we found a meteorite. So this fellow said it must be very precious. So he didn't give us, he put it in his cupboard. So it is our way of working. After 6 months, we went there again. Aur kuch mila hai to de do. So he said, yes, I have, but you didn't come all these months. I have kept it locked. And he opened the cupboard and there was nothing. It was only powder, little powder and water. So beauty of a stone is we should study and find out where from it has come, what are the secrets, what we can learn. So we learn whatever we have learned about our solar system, about our planets, about our sun, about Earth, Mars, Moon, is from meteorites. So we know universe was formed 13 billion years ago, Earth was formed 4.5 billion years ago, life came 3.8 billion years ago, and whatever happened, this has come from study of meteorites. So I am very happy it is one area of public and scientist collaboration, participation. And if you all use a camera on your car and look at the fireballs, he is studying it, so many Mahesh is studying it and so on. Uh, and you know, we are continuously finding craters in India. India में क्या problem है कि we have lot of bad weather, you know, rain and erosion and wind, and it's very hostile environment. So craters get eroded. But we have found very famous crater, Lonar. If you have not gone there, I urge you to go there. It's not far from here, in Aurangabad. That is preserved because it is in basalt, hard rock. But if you form a crater in Rajasthan, the desert sand will come and cover it in few days. You will not find it. They have found another crater in Ramgarh that is also in a granitic terrain. A very big crater Jagdish Pati has found in Madhya Pradesh recently, only some 20-30 years ago. And I think Professor Subramanya is going to talk about Kaveri crater, and somebody is going to talk about this Kutch Lonar crater. It is called Luna crater in Gujarat. I went there actually to see. So there's another thing. If you take good imagery, which is available now, and look at any circular pattern, you will find a crater. And sure enough, outside the crater, you will find the rocks, if they are still preserved. We went to Lonar, and there's a very good guest house. I must tell you this experience. So we reached there in the night time, and this tourist place is on the top of that crater. So early morning, 5 o'clock, I got up and went there. Oh my God, 200-meter deep diameter crater. And you can feel, you know, what God has created naturally. Earlier, when we went in 1970s, we could go down. There are temples there, and there are glass, and we have dated it is 50,000 years ago. It was formed, some 46,000 years ago. But now they are filled with water because they built a dam there. So it is important to look for craters. I think Mahesh Patel is trying to find craters in Himalayas and places. There is the 5-6 craters we already counted: Luna and Kaveri and the Dhala and Lonar and Ramgarh. But there are more scope of finding it. So I urge you to look for meteorites. Very simple. You don't have to do anything. Keep your eyes open and ears open. Put a camera on your roof. You'll find a fireball. You can trace it. I think they found one in B district, right? Abhinav is going to give a talk. And you can put a audio phone. Of course, here there's a lot of noise in Bombay, so I don't think it will succeed. But it gives you if you pass something, it gives you a hissing voice, like a serpent, you know, you will hear that voice. And you can detect the direction, and it will detonate. So this is some area where I think we should all look for. And when we tried, we were actually surprised कि क्या हो रहा है ये. Are more meteorites fallen now than before? Because we found about 20 of them in 15 years, which is very unusual. But that is because India is very highly populated. Nothing you can miss. Any stone comes and falls, you can find it. In other countries, it is cold. Nights are long. They miss everything. Then many things fall in ocean. Many things fall in deserts. Many things fall in jungles. But here we are very lucky that we have people who are aware of it. Or so there's a lot of things we can do. And now we have, these people went to Antarctica. They found, the Japanese fellows went there first, and they found 9 rocks. And say, in the snow, you see, Antarctica is all snow. 9 rocks here, where from they have come on the surface? They brought them back, and they were all meteorites. Now they have found 30,000. They've collected, everybody is going. Italians are going, Americans are going, Europeans are going, Indians are also going. Find collecting, because some are coming from moon, some are coming from Mars, some are coming from Venus. We have found 30 meteorites from moon in Antarctica collection, and about equal number coming from Mars. So you see, it is very difficult. They are trying to go to Mars. It will take maybe another 10 years to go there and bring a sample. But their samples are already there. The very first one, which we identified as coming from Mars, fell in Bihar, in Shergati. Shergati, it is called. But British called it Shergati. So it is known as Shergati. And we knew all about Mars by studying that rock. How much time I have?
Yeah, I think
Okay, I'll just finish. I came here actually, I was passing through Bombay and I couldn't resist meeting you all young people. You are sure some of you may become even astronauts. That Shukla has gone there, you know. He was talking yesterday to Prime Minister. Sunita Williams had come here twice and we had the occasion to meet her. So you have a very bright future. But if you can discover a rock on your own which is coming from Mars or Venus or Moon, nothing like it, you see. But then you have to send it in a laboratory. We have to study the minerals, the chemistry, the radioactivity, and all this. And there's a treasure. The universe opens up its treasure in those rocks. So this is what I wanted to say. You all start hunting for meteorites. I'm sure you will succeed because probability of falling a meteorite near your home is very high. So thank you very much. I'm very happy that you organized this thing. Awareness, you see. The next stone which is going to come and hit the earth is in 1929. So it can happen tomorrow or today, even as we leave. We never know. We cannot predict. But a big one comes, things will be destroyed. A small one comes, we'll get new elements, new species, will improve ourselves. So you see, nature is very mysterious, and I just wanted to talk to you. If you have any questions, I'll be very happy to answer. Thank you very much. Thank you, sir, for organizing this.
It's a pleasure.
Yeah, if you have any short questions, please ask because Professor will be here with us until noon. So he'll be there to listen to all of you. So please do not fear. He is my guru, which means he is a Dharma guru. So he tells you anything about the nature. It's so he is an authority on this. Hence, I am requesting you have one or two short questions because I want to ask our next speaker is he is going to talk for 10 minutes and then we will have our rest of the speakers who are lined up. They will start giving you a talk. Okay. So we are now going to introduce my good friend Anubhav Vitekar. He is from Abhinav Vitekar. He is from Bid, Maharashtra, and he was the person who found meteorite in their village next to their house, not very near, somewhere closer to their house. And the most interesting thing is he was able to then start looking for meteorites. He is only in the class 9. The idea in asking Abhinav to give a talk today, he has observed this in class 9. So it is not difficult. So one can look for such meteorites even at the young age. And the other reason why I asked him to talk to you is he has some slides of what he has seen, and I have asked him to talk only 10 minutes because I don't want to upset our other people and they are waiting for us. So please, Abhinav, continue your.
Uh-huh.
Yes. So, first of all, good morning to everyone. I am Abhinav. Yes. Continue. I am Abhinav Vitkar, a student studying in class 9th. A student studying in class 9th in Sindafana Public School, Majalgaon. So, first of all, I would like to thank our most inspiring person, Dr. Bharat sir, who has invited me. And first of all, I would like to thank him for inviting me here. Then our speaker, Narendra Bhandari sir, who has came all over India to speak here. So I would like to thank him also. I have traveled around 500 kilometers from a very small city of Majalgaon in district Bid. Means it's almost 500 kilometers away from Mumbai. And why I came here is because to give us all that information that I have got about the meteorite which we have found in our place. So approximately 20 kilometers away from my place, there is a small village. There is very less population, a poor village that is named as Khalwat Nimgaon. And there, on two locations, we have found two meteorites. So I am going to present about that. So my topic is meteorite impact in Bid, Maharashtra, India. Now, let us begin with a good thought of Neil deGrasse Tyson, who is a famous astrophysicist. He said that dinosaurs didn't have any space program at that time, so that's why they are not present on this planet. Means he wants to say that because now we have good space programs, we have many space agencies like ISRO, NASA. They are studying on meteorites and their potential threats, so we have this space program. So if anything comes in about future, so we could fight about that also. Yes. Next slide. Yeah, next slide please. So what is an asteroid day? Now, Asteroid Day, because Narendra sir has talked a lot about it, but I'll take it in short. Asteroid Day is celebrated for awareness among normal people about potential threats about asteroids and their value, because many people don't know actual values of meteorites. They are invaluable. We can say that because these serve as a valuable case study for us of solar system, because they may be in primitive solar system also, and they give us a lot of information about how our solar system was formed and what could occur next on our planet. Why is 30th June celebrated as World Asteroid Day? Now, as Narendra sir said, that on 30 June 1908, a Tungska event occurred. At that time, this was known as largest meteorite impact on our planet, because it released such a tremendous amount of energy, which was equals to 1,000 atomic bombs, which were dropped on Hiroshima. So that much heat wave and shock wave was released from that impact. Then here it's Tungska event. It occurred in 1908, a massive explosion over Siberia, Russia. Now there is a river named as Tungska. From that only, this forest is also there. It flattened almost 20,000 square kilometers of the forest. Now in the next slide, we will be seeing about the comparison of that before the event occurred and after the event occurred. This was caused by an airburst of an asteroid or a comet. Now there is a controversy between was it an asteroid or some say that was it a comet, and it occurred due to an airburst. Means there was no impact crater found, but shockwaves were felt thousands of kilometers away. And some people say that there were a lot of people who were injured because of shattering of glasses in their houses. So here is a comparison about how it was. First, it was a good morning for it. And about 8 a.m. And this event occurred. Everything went from y-axis. Everything went into the x-axis. So we can see it flattened almost 2,000 square kilometers of the forest. Now, meteorite impact in Bid, Khalwat, Nimgaon. So this is the main topic of my presentation. So first of all, I will give a short summary of what actually occurred. some approximately at 5 p.m. on 3rd of March this year, I got a phone call from some villagers from that village. They told me that something has came through a tin roof, and it has tore the tin roof, and it has destroyed cement hearth which was present there. And they have found two stones, first at a home and a farm. So they sent me some photos and videos, and we called our nearby authorities from Chhatrapati Sambhajinagar. And on the very next day we went there. We surveyed the place. We seen for if we could found some more meteorites. And there we have found two meteorites which were collected by Tehsildar sir, and taken to that office, because people were shocked, because they didn't get any idea of what was happening there. Because our region is very poor region, it's very small region. A lot of people are very uneducated. They are means they are a lot means almost 99% of the people which are on that village in our region are farmers, and some are laborers. So they didn't know what was happening, so they called Tehsildar sir. And from that he took two samples of meteorite to his office. Yeah, meteorite impact in Bid Khalwat Nimga. At noon, between 2 p.m. to 2:20 p.m., this incident occurred. Meteorites were found in two locations. First was a home, and second was a farm. At home, few women were having their lunch nearby the location. Now, this is important because there is a kitchen shed made for purpose of cooking from that farmer. And at that, there, almost 4 to 5 feet away from that location, women were having their daily lunch there. And on that time, suddenly they heard a loud sound, and then a meteorite came through a tin roof. It completely tore the tin roof, and fall on a earth made up of cement, and it also destroyed it completely. And then they didn't get any idea what was happening, because they all got scattered everywhere, because they were thinking that someone is throwing stones or something else, and are trying to destroy their home. Then they heard a sudden voice, and meteorite pierced and entered through a tin roof. People were shocked after seeing this, because nobody had seen this incident any before, and that's why they were very shocked. So this is the location of that place. So coordinates for that place was 19 degrees 6 minute and 18 seconds north, and 76 degrees 4 minute 53 seconds east. So this is the locality there, and there are a lot of farms there. And this is the image of the exact place on map of our India. So this is about the next meteorite. People heard loud sound, and they were shocked. First they heard two loud sound. They thought something is falling, and then another one fell in a nearby farm. So few children were playing there, and at that time they heard a sound. So they went there, miss, in search of that place what had occurred. And at that time they went there, and they saw a different stone which was some black in color. And so they went there, and they saw the stone, and they called their parents, the people working in the farm, and they saw, and then they collected it from the location. And this is the image of that meteorite which was found in the farm. And that hand is also of mine, because I can now also feel that meteorite in my hand. So these are the images of two samples. That first meteorite, which has I have labeled as first meteorite, it was found at the farm. And there in second image, to your everyone's right, you can see that there are two meteorites. You can see that your two meteorites, first one as I have labeled as farm, it was found at farm, and second one is found at home. And this is a rough diagram of the meteorites. See, first meteorite 1 came through into the home, and second meteorite 2 was found at the farm, and the approximate distance between them was 400 meters. So this is the image of Tehsildar sir inspecting and collecting meteorites from two locations. Village authorities had called him, and immediately he came, and he took away two samples to his office. So this is inspection report at 3rd of March 2025, at timing approximate 2 to 2:30 p.m. Stones fallen from space. So this is the image of the news coming here. News came on 5th of March, and here that child, you can see, that's me there. So this is the important part, because we shouldn't just take the meteorite and say that we have found a meteorite. We must do some scientific analysis on that. So this is the scientific analysis which was done at MGM Science Center, Chhatrapati Sambhajinagar. The meteorite has a gray to dark brown surface, as we have seen in images. It has a granular texture. Now, as I have seen, it had some small type of grainy like structure. So that structure, so round, and when this meteorite was seen under microscope at that time, they have found some rounded spherical shaped particles, which we say as chondrules. And from this we can confirm that this meteorite was an ordinary chondrite. Then what are mineral compositions? Silvery grains may be nickel rich compounds. Nickel also looks something like silver also. Yellow to coppery grains may suggest presence of iron, sulfides, or any native metals. Then magnetic hardness or and density properties. This meteorite shows attraction to magnet due to presence of iron and nickel alloys. Then hardness was on 6.5 on Mohs scale, means this was moderately hard but not hard as quartz. Then density is about 3,500 kilometer per meter cube to 7,000 kilometer per meter cube, means this was more denser than the rocks present on our earth. Then microscopy was done, and it shows fine crystalline structures and spherical chondrules. So from this all scientific analysis, this meteorite is likely to be classified as an H group ordinary chondrite. Yeah, here it's the conclusion. What we can conclude from the given scientific analysis: it was a rare iron rich ordinary meteorite. It is confirmed that it is a ordinary chondrite, means it was a primitive asteroid, and it serves as a valuable case study for our understanding of our solar system.
Thank you.
Sir, only 2 slides are remaining, only images.
Okay.
Yeah, please play the video. Okay. Yeah, and this is the image where we are collecting the samples. Yes, thank you everyone. And there is a thought given by Bill Nye that if Earth gets hit by an asteroid, it's going to get game over. It's going to get control alt delete for our human civilization. Means we can say that our civilization could go in factory reset mode. Thank you everyone.
Thank you, Abhinav. He will be here with us until evening. So you can ask him all your questions during your lunch break and maybe in the afternoon also. So he is there with us. So, but we have to continue with our program. So the next speaker that we have is Professor Subramanya from Bangalore. He is an ex head of the Department of Geology in University of Bangalore. He has done extensive work on impact craters, and today he is going to talk to us about the impact craters. Impact means where the meteorite has hit, and he is going to talk to us about Kaveri crater. I don't know, sir mentioned, Professor Bandari sir mentioned about Kaveri crater. Yes, there is a lot of work to be done. Please understand, these crater works needs a lot of young people to work. In fact, Professor Bandari had also conducted one program in one school, if I am not mistaken. Is that right, sir?
Yes, yes.
Where they collected, I don't know how many kilos of.
About 75 kilogram, 500 pieces. This meteorite fell in 1976, and 200 children went around 18 kilometers every day for 2 months, and almost everybody found a one piece. So that was very interesting exercise.
So this is our little tribute to Professor Bandari sir for his introducing school children to doing astronomy and asteroid search. So, similarly, we expect all of you to consider this point, and we moved on to Professor Subramanya sir for the next talk, which he is going to give to us. Can we have Professor Subramanyam online?
Yes, sir. I am here.
Yeah. I'm sorry for we are late by quite some time, but we'll try to make it up very fast. Thank you, sir.
Okay. Can you hear me, please?
Yeah, yeah.
Okay. Respected Professor Narendra Bandari ji, my very good friend Dr. Bharat, and Director of Nehru Science Center, and fellow astro enthusiast. I am very happy to be here and make my presentation on. Pardon?
Excuse me, sir. There is a problem there. The host has disabled the screen sharing, so we are unable to do that. If somebody can allow that, then we can start this sharing here.
Yeah. Professor, you can continue, no?
But I can't project the slides.
Okay, okay.
Now, sir, check.
Okay. Yeah, here it is. So the title is, did an asteroid hit southern India around 600 million years ago? Yeah. Now you see, this is a part of southern India. This is a Google map, and I'm sure you will see this is the many hills all around, and it is within that is a circular area. This is the geography of area based on the Google map. See, again, this is the same area based on hill-shaded grayscale map. This is also again, yeah, this is a slope map, and in all these maps, what you can see is there is a circular depression surrounded by mountains all over. And if you are, I am sure you are all familiar with this area. This is Nilgiri mountain range. This is Biligiri Rangan Hills. This is Malay Mahavadeshwara Hills. And this is Madras Shivrai Hill, Kollimalai. And then this is Anai Malay. This is Kodaikanal. So this circular depression is surrounded by mountains on all the sides. If you look at the geophysical anomaly in this area, this is the area of gravity high, and also there is some magnetic anomaly here. The magnetized layer is 2 kilometers lower compared to the surrounding area. So based on this, we started thinking whether this circular depression was the result of a huge asteroid impact in southern India. So just a brief introduction. Earth in its early history must have been heavily bombarded by large extraterrestrial objects, at least 10 times more than what we see on the moon today, because the surface area of the Earth is 13 times and gravity is 6 times larger. However, the records available on the surface of the Earth are very meager, as most of the impact sites will have undergone modifications due to the Earth processes, denudation, and tectonism. It is now accepted that impact events, especially large ones, have had a major role in the formation and early history of the solar system. Many chemical and dynamical problems concerning the origin of moon are explained by the current theory that the moon formed as a result of a collision between Mars-sized object, excuse me, and the larger proto-Earth at about 4,500 million years ago. So two planets collided, and then what came out from that was our moon. As of now, about 190 impact craters have been recognized internationally, and among these craters, they are divided into two. One is hypervelocity impact crater, restricted to impacts where the evidence of shock metamorphism in the target materials has been detected. Again, this can be a simple crater or a complex crater. The evidences for hypervelocity crater is shatter cones, planar fractures, planar deformation features, feather features, diaplectic glass, trichoites, and then supporting evidence is pseudotachylites. The second category, that is the impact crater, will not have any signs of shock metamorphism. This is the top one is the simple crater. Next, below that is the complex crater or hypervelocity impact crater. Now, as you can see, normally there will be a central peak and then a large number of faults, spheroid faults, which in geology we call it as listric faults. So, and then if you go, this will be the final crater rim. And this will look like this after it has undergone weathering. Two large impact craters have been reported, one from South Africa, Rutherford, that's 300 kilometers, another from Sudbury, 250 kilometers, and the age is about 1850 million years. Another major impact occurred around 65 million years ago, and you have heard about this already. Professor Naresh Bandari has very clearly explained about this crater, which is found in Yucatan Peninsula, Gulf of Mexico. So this is considered to be responsible for both Deccan volcanism and mass extinction of dinosaurs and many other animals. In India, there are very few examples of impact craters: Lonar, Thala, Ramgarh, Luna, and then Simlipal, it to be confirmed, and then Shiva also yet to be confirmed. The crater being described is in the southern peninsula. The coordinates are so and so. Center of the crater is close to 77 degrees 30 minutes and 11 degrees north. The area in focus is a part of Precambrians and is to the south of what is generally known as the Dharwar Craton. The region is known as southern granulate terrain. However, the circular depression or the crater which is to the east of Palghat Gap is occupied by granitic gneisses. Now, this is again the same picture, but what I have marked in the line is one is the inner ring, and perhaps what is marked along the here is outer, perhaps the outer rim. These two arcs may represent the outer ring, and there are no outer rim here because this area has been highly fractured by radial cracks, as you can see. Radial fractures. Because of these radial fractures, perhaps the outer rim is not very prominently displayed here. And in the mesoscopic features, among the mesoscopic features which we have found are impact breccia, pseudotachylite, and shatter cone. Shatter cone is very significant evidence of a hypervelocity impact structure. Now, this is breccia. As you can see, this rock is known as the granitic gneiss, and the black patches are pseudotachylites, and the pseudotachylites are the result of melting of the granitic gneiss here. So this has undergone melting and is given rise to pseudotachylite, and the rocks have been fragmented and it has become brecciated, what we normally say as breccia or brecciates. This is again a very huge band of pseudotachylite. Again, this is a very important evidence because such huge band of pseudotachylites do not normally form. Another pseudotachylite from the same area, Yeah. Now this, all of you, I am sure you will see the conical shape. And then what you must also observe here is, see, this line is coming like this. This line is coming like this. That means they are converging. So this is a very significant evidence of a hypervelocity impact structure. This is feature, this rock structure is called as a shatter cone. And then again, I will show you another view of the same. This is the base of that shatter cone. Again, you can see that it is a cone. So these two are very, very good evidences of a impact, asteroid impact. There is another evidence here. This is again another shatter cone. But if you look at this area, you see the conical nature. And then also these lines, they converge and it goes towards the apex of the cone. So this is another sample of the shatter cone, which is again a significant evidence. Same thing. Okay, then I'll come to the microscopic feature, and most important are planar deformation feature and planar fractures. This is a quartz mineral. Now, perhaps most of you know, quartz does not have any fractures or cleavages. But in this particular case, it has developed numerous fractures, and the lines which are very closely spaced, they are known as planar deformation feature, or PDF for short. And those lines which are placed farther away, these are called the planar fracture. Now you can see that there is one in many of these PDF and a few of this PF. And these have definite crystallographic significance. I measured the crystallographic plane of these under universal stage. Pune University had conducted a workshop on universal stage in which I took part, and then I determined the crystallographic planes of these PDF. And this happens to be 1013, which is a very, very significant PDF. So most of the quartz grains develop this PDF along this plane. So, and then normally this will be the pressure under which this develops is around 10 GPa or gigapascals. This is the PF planar fracture. This is the first set. There is also a second set, as you can see here. So this is a very, very significant evidence for the impact origin of that circular depression. Again, this is another grain of quartz. Here also you will see very faint lines. These are PDFs, and within this grain is enclosed another quartz grain, and these, as you can see, they are spaced far apart, and therefore these are planar fractures. And these planar fractures, as you can see, ends at the boundary of this crystal itself. They will not enter into this. They are not entering. So again, this is another very important, significant evidence of impact. This is in the plagioclase. Normally, plagioclases develop. Normally, plagioclases have only. Pardon? Normally, plagioclases have only twins, whereas here you will see fractures. And there are 3 sets of fractures. As you can see here, this is one set, the second set, and then the third set. So this kind of fractures normally do not develop in plagioclase. This is the, under cross nickels or double polarized light. And this is again another another mineral of plagioclase. This is from the north of the crater. If you look at this area, this is clouded, and even within this clouded area, you will see 2 sets of lines, one like this, another running like this. Again, these are planar deformation feature which have developed in plagioclase, which is not, again, very normal. This is again another mineral in the quartz. As you can see, this is surrounded by another mineral known as pyroxene. You have pyroxene here, and then you have pyroxene here. Now, what is significant is this grain looks uniform. There is no break anywhere. But if you look at the cross-polarized light, you will see that part of the quartz grain has become opaque. So, and then another part is not opaque. So therefore, this normally is called as a diaplectic glass. So the quartz has become a glassy material. Without that means it has lost its crystallographic character. This is another mineral of plagioclase. Again, a lot of clouding is there, and then you will see some fractures here. These are planar fractures. And cross nickel, what is significant here is it has undulose extinction. That means some part has become extinct, some part has not become extinct under crossed polar sphere. So this is birefringent. This is more or less opaque. Again, this is a very significant evidence for impact origin. This is another mineral, plagioclase. As you can see, there is not much of a deformation which you see under plain polarized light. But if you see under the cross polarized light, you will see that there are many small grains, some of them retaining their twins. So this is called as mosaicism, again, a very significant evidence. This mineral is garnet. Garnets normally do not have cleavages, whereas in this, you will see 2 or 3 sets, one set here, another set here, another set here. So therefore, these are not cleavages. This must be planar fractures. Again, very unusual for a mineral like garnet. All these evidences point to a hypervelocity impact. The diameter of the crater, you saw the circular depression, it's about 120 kilometers. The accepted ratio between the diameter of the pre-impact land and the crater is normally 1:1.25. On this basis, the diameter of the pre-impact land can be taken approximately as 100 kilometers. So the ratio between the diameter of the asteroid and the impacted land is normally 1:20, which gives the diameter of the asteroid as 5 kilometers. That means a 5-kilometer asteroid impacted a 100-kilometer area and created a crater of 120-kilometer diameter. Now, what could be the age of impact? When did it happen? Now, there are some, again, indirect evidences. There is no direct evidence. There is a hill called as Shiva, which has a rock which is composition is cyanide, and the age of this rock is 623 plus or minus 21 million years. And within this rock are quartz and pegmatite veins. The quartz vein got PDF and PF mineral in which in the quartz mineral in which I showed PDF and PF. That is from this Shiva cyanide. So the age of that is 623. So the quartz must have undergone deformation subsequently. Therefore, the deformation or the impact must be younger than 623 million years. Okay, so that is one limit. Again, let us go to another area where the plagioclases have developed PDF. So the age of that is 560 plus or minus 12 billion years. So that means it could be the it can be 23 and 560 million years. Now, again, if you go further to further details, a huge impact normally creates large quantity of melt. it has been seen that within the crater and also within the crater and also within the apparent outer crater rim, there are innumerable granitic bodies, and ages of these granitic bodies range from 580 to 510 million years, with a mean of 545 million years. And the metamorphic age of Paleoproterozoic rocks, that is the age of the original rock, is 2.5, and it has undergone metamorphism, and the metamorphic age ranges from 576 to 512, with a mean of 548. So these age data indicates that the impact could have occurred at the Proterozoic Paleozoic boundary. So as you know, as Professor Bandari has already mentioned, so these such major events can be causes for extinction of some life forms and development of new forms. As you know, during this around 550 million years ago, there was a huge explosion in the living world, which normally we call it as Cambrian explosion. So whether this asteroid impact was responsible for the Cambrian explosion is really worthy of investigation. Okay. So if we look at the entire geology, so what the general picture you get as you move from north to south, lower temperature metamorphism, medium temperature metamorphism, high grade temperature metamorphism, and very high grade temperature metamorphism. So the grade of metamorphism increases from north to south in this form. And however, if you look at this area, this has low grade metamorphism, which is equivalent to more or less amphibolite phases. Rocks here belong to this phases. Rocks here belong to this phases, whereas the surrounding rocks are all high temperature rocks. And then if you go below that depression, circular depression, the magnetic basement is deeper. Then again, perhaps because this area has a lower grade metamorphic rock, that means it is cooler. Therefore, magnetized layer extends deeper. And again, other geophysical evidence is there is a Moho boundary. Mohorovsky boundary or Moho has gone up by 4 to 5 kilometers. So all these evidences point to major changes in the geology of southern India. But now many people are reluctant to accept that there was an asteroid impact. The very simple reason is, if you accept this, you have to rewrite the geology of southern India. So many people are very hesitant, not willing to accept. But anyway, this is a fact which has to be accepted one day or other. Okay. So with this, I come to the end of my presentation. I leave before I conclude. I will have a quiz. Food for thought. Now, as you know, in many parts of India, we have Jyotirlinga. Now, can these be meteorites which came in full glow and brilliance and landed in different parts of India? This is a question. Please think it over. That's how the idea that I had got it. It's possible or it may not be possible, but definitely, because most of the lingas that you see, they are not perfect lingas. They are of different shapes, different sizes, and some are magnetic, some are not magnetic. So it's possible that there are small chunks of meteorites or small pieces of asteroids which have landed in different parts of India. So because it came along with a bright light, the people must have called it as Jyotirlinga. Jyoti is light. So with this, I conclude my presentation, and will be very happy to answer any questions. Sure, definitely. No, see, Jyoti is light. Jyoti is bright light or brilliant light. Jyoti is that. Linga is the Shiva. Shiva in the form of a linga. So Jyotirlinga means that linga must have come along with a very bright glow. So therefore we may be calling them as Jyotirlinga. Pardon? Where? I Your voice is not audible.
Where is this Jyotirlinga mentioned? Is it does it come in mythology or anything?
No, see, we worship about 12 Jyotirlingas spread all over India. I think one is uh, oh
Somnath.
Mahabaleshwar. One
Somnath is one.
Somnatha temple is another one. So
Somnath Jain.
Omkareshwara, see, like that there are 12 or 16 which are worshipped as Jyotirlingas. They are distributed in different parts of India and they are not perfect linga shape. And then they are normally when you have a linga, there is a platform and then above that platform is a pan or pan batlu, what we call, with a area where the Abhisheka water will flow out and then you have the linga on the top. So this is normal Shiva in a normal Shiva temple, whereas most of these Jyotirlingas they are almost at the ground level or they are not of perfect linga shape. So that's why I wonder whether they could be meteorites which have fallen, which have come with a very bright light and then fallen on the different parts of India.
Sir, if it's a 120-kilometer crater, there will be a lot of ejecta which will spread
Yeah,
out of this impact. So,
yeah.
have you got any ejecta or tektites out of this impact? Because many large craters they have the tektites.
No, but that's true. But you see, tektites, this, as I told you, it's formed around 550 million years ago. So whatever the tektite that was on the top of the surface, sorry, will have been eroded. So, but only tektites that you can see is in the ocean which carried these. But that ocean is not there now because we have new oceans all around India. Whether it was this Bay of Bengal or Arabian Sea or Indian Ocean, they're all new brand compared to the time of impact. These are all new water bodies. Therefore, it's very unlikely that you will find tektites in the sedimentary rocks surrounding India. But I showed you about the pseudotachylites and brachia. They are all around the crater. And one shatter cone which I showed you, which is just outside the inner rim of the crater.
Do you think is there any link between all these 12 of them in terms of composition of this means material of which they are made of or they are of different any study have been done on that?
I'm sorry, I will
Can you please repeat?
About this Jyotirlinga where you have raised this question means you are studying that. Is there any link between their composition, material?
Yeah, see, I have not studied the Jyotirlingas. I told you, it's a food for thought for you people. See, but at least there is a linga in Gokarna, which is not considered as a part of Jyotirlinga, and that is uh, almost at the ground level or below the ground level, and then it looks like a twisted body. If it looks like, and therefore it's called as Gokarna. That is ear of the cow. So like that, even see, Kashi Vishwanatha is more or less at the ground level. See, normally when we build a temple for Shiva, it will be have a high pedestal, and then, as I told you, there will be a pan, and then above that there is a perfectly elliptical or hemispherical linga. But in most of the Jyotirlingas, you don't see this. So that's the reason why I started thinking about it. I could be wrong.
Okay, thank you, sir.
Thank you, sir.
Anything else? Any other?
Thank you very much.
I would like. I would request.
Yeah, if there are any more questions, I think we are already late on the part of it. So, if they have any questions, in fact, we are going to give them your email address also, sir.
Please
Yeah,
do. I will be very happy to
yeah. Thank you
get
so much. Thank you,
whatever I
sir.
know.
uh, now,
Thank you.
now we have the next speaker, Dr. K.V. Krishnamurthy.
Yeah.
Hi.
Yes, sir.
Yeah,
Good
Professor
morning. Good
Bandari
morning.
is next to me. He is also there watching you.
Yes.
And
So,
uh, the before you start this talk, we have to now compensate on the timings. So please bear with us. And
sure, sure.
other thing is, we definitely would like to have more interactions. You must be seeing we have a lot of students sitting here amongst us. They are school children and also some who are interested in doing research in asteroids and meteorite studies. So, sir, a few words about Professor Krishnamurthy is the following. He is the Secretary of Geological Society of India and he is stationed in Bangalore. And his interest has been on all impact craters in all over the country. So he has been looking at not only Lonar, but Lonar is our pride in Maharashtra.
Yes, sir.
So it's my request to Professor Krishnamurthy, who has an
Yes.
illustrious distinctions, and he has been one of the prime persons in even in GSI, that is Geological Survey of India. He has been the director there, and the most important part is he wants now to interact with the younger people.
Yes, sir.
And he has told me very specifically how many young students are going to come. so,
Yeah, yeah.
so it's my request to him and on behalf of all of you to give his presentation for this talk, and you are welcome to ask him any question because
Yes.
we have to curtail in the early part of today morning because we are delayed. I'm sorry for that, but you will also give us good inputs for all our young friends. Thank you, sir. Please continue.
Thank you, sir. Very good morning to you all. In fact, I should be thankful to Professor Bharat Thadur Saab for this invitation. I'm thankful to the Nehru Science Center for uh, rather showing this show. In fact, it is possible that most of the speakers are virtually speaking. It's because of their technology, which has made me to give this talk. As Dr. Bharat said, I am based at Bangalore. In fact, I served in Geological Survey of India for over 35 years in different capacities and different terrains I've worked. Anyhow, I should be thankful to Professor Subramanya also for making my job a bit easier because he has mentioned about the Shiva crater in detail, which I was thinking also to give tidbits about Shiva crater. So come to my topic, that's about the geological characteristics of impact craters of India. Well, Professor Subramanya was trying to explain how you can call that Shiva crater as a crater, impact crater created by an asteroid or a meteorite. So there are certain geological characters through which you can certainly say that yes, this is an impact crater created by the collision of a meteorite or asteroid with the Earth. So how do we recognize those? First of all, what are these impact craters looks like? These craters are roughly hemispherical depressions formed by the impact of collision of a meteorite or asteroid on Earth. See, this is in fact a general consensus that if there is an impact, it is either the Earth is impacted by or the hit by a fast-moving object like asteroid or meteorite. That's how it creates the impact on the surface of the Earth. In fact, geologists have realized of late that collisions of extraterrestrial objects with Earth have significantly shaped Earth's surface. In the beginning, I think Professor Bandari also was talking. So there would have been many impact craters which has reshaped or shaped the Earth's surface as such. So it has disturbed its crust and it has altered its geological history because many of the craters are of different ages, the impacts. So by very nature, we may not get the entire geological features around a crater to look for certain evidences. So in that case, whatever the evidences we collect, we have to regroup it and based on our hypothesis or theoretical this thing, we should conclude that yes, because of this is evidences, yes, it has to be a crater. Because otherwise, even volcano can give you a crater where the volcanic eruption takes place, it creates a crater. So how do we differentiate or distinguish between volcanic crater and an meteorite impact crater? I will come to that in a later part of my talk. The impact structure is a resultant of a combination of several factors. Say, for example, how these factors affects the trajectory of the meteorite or asteroid, because we say that these are circular or semicircular or something like that. So how the shape is changed, how the shape is formed because of the impact. So it depends on the trajectory, on which angle it is hitting. So sometimes it may hit straight, in which case you will get a perfect circular feature depression, or it may hit the Earth at an angle. So in which case you get at one part of the crater it is steep and another part it is not so steep, and it will be a semi kind of circular feature. So and it has got the morphology of the area. It depends on that also, whether it is hitting in a valley, it is hitting on a mountain, or hitting on a plain surface, whether it is hitting on a hard rock, whether it is hitting on a soft sediment, all that, that results in the different types of impact craters. And then the composition of the crust near the collision. This is important because, for example, in Lunar crater, as you all know that, the meteorite has hit in the Deccan traps, what we call as basaltic rocks. So there the impact is different when compared to an impact created by the meteorite hitting a sandstone area or a plain surface area or a low depression area. So it all matters. So what type of morphology of the area was there at the time of collision of these meteorites or asteroids with the surface of the Earth? The impact structures range from a few kilometers or less than in diameter to large complex structures of more than 200 kilometers. As I think we have already heard about big impact craters on the Earth. And so it all depends. So what was the size, what was the speed of the asteroid or meteoroid at which it hits? A meteoritic impact with energy equivalent to 100 kiloton TNT is recorded every year. So we are not aware of. In fact, I should be thankful to our young student, I think Abhinav Vitkar, for discovering at this young age. You see, he had so much curiosity and interest where he could go around and collect samples and also create a kind of awareness. In fact, this is the International Asteroid Day, as Professor Bandari puts it. It is for creating the awareness among the general public of what is going on surrounding us. In fact, we celebrate World Earth Day, we celebrate World Environment Day. Like that, it is a World Asteroid Day. So this is where uh, children, as we were discussing in the beginning, the youngsters or the children or the general public, they should come in the forefront and feed their information, whatever they come across around them. In fact, they were talking about several meteorites in Antarctica. I had been to Antarctica. In fact, one of our mission was also that, to look for certain meteoritic samples. So unfortunately, near our base, that was uh, that station, Maitri station, we did go in search of those, but it's such a thick ice cover is there. It's very difficult to find any kind of rocks unless they are exposed. Only, as you know, that only 2% of Antarctica, particularly along the coastal regions, is exposed. Otherwise, rest is all thickly ice covered, as thick as 6 kilometer ice column is there. So anyhow, as I think Professor Bandra was telling, some Japanese scientists, so they were lucky enough to get these meteorites. So they could found several meteorite samples and studied them. So what I was talking about, the impact of meteorite, it creates every year we have got 100 kiloton TNT of impact of meteorites on Earth. And this energy is equivalent to 1 megaton. Explosive is recorded once every century. That's what they were discussing. In every century, there will be a huge meteorite impact, which can create the impact of 1 megaton TNT explosive. So, for example, just to give an analysis, note that Hiroshima atom bomb was merely a 15 kiloton TNT of energy. So imagine 1 megaton TNT, how much impact it would create on the surface of the Earth. Then terrestrial life has not escaped this cosmic bombardment. So meteorite, when it falls, it cannot discriminate. There is a population here, there is a forest here, there is an ocean here. It can fall anywhere. So in the result, with the result that several terrestrial species may get, extinguished, like in what happened during Jurassic time. That's what your Mexico, that impact, meteorite impact has created, that Cretaceous tertiary boundary. Entire population of that dinosaurs got extinct. So, similarly, even in India, for example, where we have got this Deccan basalt, huge Deccan basalt covering a major part of Maharashtra and a part of Gujarat and a part of Madhya Pradesh and northern part of Karnataka. There's a huge basaltic eruption, and people think that this has vanished the dinosaur population in India, because there are evidences to say that dinosaur lived in these places. Anyhow, that is a part. So the Cretaceous tertiary mass extinction event is attributed to 180 kilometer Chicxulub impact crater in the Yucatan Peninsula, Mexico. This impact generated a blast of air and heat, tsunamis and earthquakes. Now look at that impact. It is just not, it is falling on the surface of the earth, only that much is there. But it can create a huge blast of air, heat, then the tsunamis, earthquakes, dust, so much. And this has injected a huge amount of dust in the atmosphere, which may have inhibited photosynthesis for about 2 months. Can you imagine? So most of the living beings on Earth is depending on the oxygen, which is coming through our plants and trees. If there is no sunlight at all because of the huge dust the meteorite has created, so there would be no light. So forest fires will get triggered when the impact ejector re-enters the Earth's atmosphere. So with the result that what happens, this is not the only cause, we were thinking, so it has, what is that, meteorite has hit, fire has come, but it can, linger on for months together and inhibiting the survival of the living beings. The estimate suggests that a 15-degree decrease in the average global temperature, which when coupled with the other effects of the impact event, resulted in severe environmental consequences. That's what I was referring to. So it can create a huge impact. I think Professor Subramanya was also telling what are the simple craters and complex craters. The morphology or form of impact craters differs depending on size. Smaller impact craters up to 4 kilometers in diameter, they have a bowl shape, like what you can see in this picture, bowl-shaped form like meteor crater. We call them as simple structures. On the other hand, the meteorite impact, which is more than 4 kilometers or larger in diameter, have central uplifted features in the form of peaks or rings and slumped rims. So they are called as complex craters. So now, typical impact craters on Earth, regardless of size, share some fundamental features. This is where I want to explain on these features. It will have a central cavity and an elevated rim around the crater and an ejecta blanket surrounding the crater. These are the typical features. It is not necessary that you get all these features at one place, but you have to collect for the evidences. And larger craters may also exhibit terraces. So huge, this thing, ejecta there, it will create a terrace. Then the central peaks, and even when with multiple rings, there may not be only one rim or ring. There would be more than one ring in that complex impacts craters. These features arise from the high-speed impact and subsequent rebound of the Earth's crust. So what is the central cavity means? Initially, the impact creates a bowl-shaped depression. However, the rebound of the Earth's crust often partially fills in this cavity. So it modifies the morphology of the surrounding area also. The rebound or the ejecta which comes out, it can fill the cavity also. And what is the rim? The impact throws up material, creating a raised rim around the crater's edge. That's how we get, whenever you go to a crater, you will see the rim, which is raised above the mean sea level height. Then there is something called ejecta blanket, which is the material ejected during the impact, which is deposited around the crater, forming a blanket-like layer. So that we call as ejecta. Say when you forcefully inject something, it has to replace certain mud or soil or the rock, whatever it is there. Then only it creates a depression. That mud comes out, or soil comes out, or the rock comes out. So that becomes your crater rim. Then central peaks, that is complex craters typically larger than 4 kilometers, what I told you in the beginning, may have a central uplifted area called a central peak, formed by the rebound of the crust after the impact. And then the multiple rings in the largest impact structures called multi-ring basins. Concentric rings of uplifted material can be observed, and they are called the multiple rings. So what else? An impact crater is a depression that is formed by the high velocity impact of an extraterrestrial object, like what we referred in the beginning. And these impacts produced on Earth are highly exposed to obliteration by various geological agents. For example, if you are interesting, for example, somebody may question Professor Subramanya, say, where are the other features which is the typical geological features to look for, or what you got evidences in Kaveri crater. It's very difficult because so when the Kaveri crater is talking about Proterozoic, Neoproterozoic, that is nearly 600 million years back. And the process of weathering, erosion, or so many things have happened after that. Tectonic deformations, not once, more than 3 deformations. These areas have suffered. In that case, you cannot expect all the different features that is associated with the impact craters. So that is because that means obliteration by geological agents like weathering, like cracking, like fracturing or faulting or erosion, whatever it is. To form a true impact crater, this object needs to be traveling extremely fast, many thousands of miles per hour. Then only it creates the impact. So that means we expect that the meteorite or the asteroid, which is hitting or which has hit the Earth in the past, it must have been traveling at a very greater speed. When a solid object crashes into something at these super fast speeds, it forms a crater regardless of how hard or tough it is. Because in the later part of my talk, I will also inform you that there are impact craters which has fallen on soft sediments, like in Kutch. There are impact craters in the hard rock like basalt or granites. So that's what it means. It immediately vaporizes and creates enormous shock waves through the ground that melt and recrystallize rock. This is very important. So it sends shock waves and it evaporates because the temperature is so much. Immediately when it comes to a cool body like on the surface of the earth, everything evaporates. You won't get many material at all, which are associated with the typical impact craters. Then certain diagnostic criteria for the identification and confirmation of impact structures are crater morphology, then geophysical anomalies, whether it is magnetic or any other thing, gravity, evidences for shock metamorphism. We have to look for shock metamorphism through the petrography or the microscope studies of the minerals which you collect from there, and the presence of meteoritic material. The geological process other than impact craters such as volcanic eruptions may also lead to hemispherical depressions, what I told you a few minutes back. Owing to the intense deformation, the impact craters are highly susceptible to erosion, creating difficulty in identifying impact craters. I think I have explained enough on that point. Then the scientists have therefore identified geochemical and structural markers of a meteoritic impact, which are these. So this is the typical, if you want to identify or if you want to definitely or conclusively say this is an impact crater, you should look for these geological features, which are those geochemical and structural markers. What are those? Number one, it will have preserved meteorite fragments. Like what our young friend was telling, Abhinav, he went around, he collected the rock samples, So these fragments should be there around the area and may not be also because the processes which involve erosion, although if they are too old, if they are recent, you should be able to get in these meteorite fragments. And anomalous amounts of siderophile elements. What are these siderophile elements? Like nickel, cobalt, chromium, gold, and platinum. There is what is called as PG elements, platinum group of elements, like platinum, palladium, rhodium, ruthenium, iridium, and osmium. These would be present because any meteorite or asteroid are rich in these siderophile elements. In fact, there are some scientific investigations going on. So some big asteroid which are orbiting around Earth or in the space, if you can bring them down, it will give you 1,000 times of these deposits what we have now discovered on the Earth planet. So they are so rich in this. So economically, they are very important. So they will be having this. So when you go there to an impact crater, you collect samples, analyze for this. If you get all these, then you say, yes, certainly it's an impact crater created by an asteroid or meteorite. Then it will have shatter cones, as our Professor Subramanya has already explained. They are nothing but striated conical fractures. You will get where the impact crater rim or the margin is there. You should look for these striated conical fractures. Then high pressure mineral glasses. They are called the diaplectic glasses. Because of the high temperature and high pressure, the new glasses will be developed. So you can analyze them and you can probe them and find out what is. Then you have got high pressure minerals also. Then high temperature glasses and melts in that area. Then the planar fractures, which he was explaining in quartz. Then the PDF, which are planar deformation features. They are very, very much, evident where an impact crater is there. Till date, about 204 impact craters have been proved, and it will be adding on because daily you see that there are some meteorites falling on Earth. And these 3 impact craters are in India. Out of these 204, so far conclusively proved are these 3 impact craters. Of course, there are other also, which I will come to tell you in the later part. These are, number 1 is Lonar crater in Buldana district of Maharashtra. This has been very well studied and very well amply proved also. Then the Dhala crater in Shupri district of Madhya Pradesh. Then third one is Ramgarh crater in Baran district of Rajasthan. So apart from these 3 proved impact craters, there are a few more impact structures that are suspected of having meteoritic impact origin. They are namely Luna crater in Kutch, Gujarat, Simplipal crater in Singhbum. I do not know how many of you have heard this, because this is a kind of ring structure you can see circular in the Singhbum crater, and where you get a lot of hematite or the iron-rich ores in that Simplipal crater. Then the Kaveri crater in South India, what our Professor Subramanya has discovered along with Professor Prakash Narasimha. And the Shiva crater, which is discovered and explained by Mr. Chatterjee, which is a disputed undersea super crater west of India in Arabian Sea. So let us come. I do not know how much time. I think I will go brush through these slides, because in the beginning we are already running behind schedule. Anyhow, I will just give a gist of these important craters. That is Lonar crater. Lonar Lake, also known as Lonar crater, is a saline soda lake located at Lonar. See, look at this, saline soda lake. Can you imagine why of all the lakes, why it should be salty? That means it has to be from the meteorite or the asteroid which has hit that place. In fact, I had been to Mount Kailash. There are 2 lakes there near the Mount Kailash. One is called Raktasthal, another is a Sweetwater Lake. Both are just nearby, hardly few meters apart. This Raktasthal Lake is saline water, whereas the other one, which is adjacent to that, is fresh water. So how do you explain this? So this must have been a crater, impact, where we call as Raktasthal Lake. That's what people predict. It has been hit by or impacted by an meteorite or asteroid. So these are the evidences you should look for. Then Lonar Lake is an impact crater created by meteorite impact during the Pleistocene epoch. It is one of only 4 known hypervelocity impact craters in basaltic rock. That's what I was talking about when a meteorite hit an hard rock. This is a hard rock. The mafic rock, we call them as basaltic rock. Anywhere on Earth, you will get that impact. The other 3 basaltic impact structures are in southern Brazil. So the entire world, so there are only 3 + 1, 4 such basaltic rocks impact is there, and that is one is in our Lonar Lake. And the Lonar Lake has a mean diameter of 1.2 meters. And is about 137 meters below the crater rim. The depression is about 137 meters. And the meteor crater rim is about 1.8 kilometers in diameter, the rim. So it comes under the normal or simple crater. Although the crater's age was previously estimated to be 52,000 plus or minus 6,000 years, the newer studies suggest an age of 576,000 plus or minus 47,000 years. This is the satellite picture or the view of your beautiful Lonar crater lake. So let us look into the geological aspects of this Lonar lake. It lies within only one known extraterrestrial impact crater found within the Great Deccan Troughs, what I told you already. The lake was initially believed to be of volcanic origin. You see, for example, there are craters of volcanic origin where the lakes are also there. I have seen one in Mauritius. It is still active in the sense it is not bombarding, but crater is there and volcanic lake is there. So it is not a volcanic impact. Lunar Lake was created by the impact of either a comet or asteroid. The presence of plagioclase, this is another important geological features. I am mainly focusing on geological features. The presence of plagioclase that has been either converted into, which is called as masculinite. It is the high temperature, high pressure plagioclase feldspar, which is very, very characteristic and very, very important to identify a particular rock containing this mineral as it is created due to impact of a meteorite or asteroid. Then it is believed that only shock metamorphism caused by a hypervelocity impact can transform plagioclase into masculinite or create planar deformation features, that is PDFs. The presence of impact deformation of basalt layers comprising the rim of shocked breccia inside the crater of shatter cones and of the non-volcanic ejecta blanket. See, the ejecta blanket can be of volcanic nature also. If that is there, you can easily say, no, this is not the impact created by the meteorite. It has to be a volcanic crater. Then surrounding the crater all support the impact origin of lunar lake. So these are the evidences to call that as a impact crater created by meteorite. So this is once again another picture of same lunar lake. The crater has an oval shape. The meteorite impact came from the east. See, this is also determined, taking the angle of the hit at an angle of 35 to 40 degrees. In the beginning, I was telling the morphology depends on the trajectory of the asteroid or the meteorite when it hits the Earth. It exhibits distinct geomorphic characteristics. The 5 geological characteristics are there. They are got the outermost ejecta blanket, the crater rim, the slopes of the crater basin excluding lake, the crater lake. So these distinguishable 5 zones have been identified in the lunar lake. A series of small hills surround the basin with a circumference at top of about 8 kilometers, and the sides of the basin rise abruptly at an angle of about 75 degrees. See, look at the morphology, how it has changed. At the base of the sides, the lake has a circumference of about 4.8 kilometers. Okay, that's all about lunar crater. Now let us come to the second confirmed crater, that is Ramgarh crater. This Ramgarh crater, which is located in Baran district of Rajasthan, 110 kilometers east-northeast of Kota city. The structure resembles a meteor crater of Arizona in USA in terms of its shape and is obvious in topographic maps and satellite imagery. As I think Professor Bandari was telling, we should study, nowadays remote sensing is a very, very, important tool for geologists or any other scientists to study the Earth, not only from the point of meteor or asteroid. It can give you anything, even for geologically, for example, in order to cover a huge area, we require lot many days or the months or years. Whereas using the remote sensing data, you can sit in a lab and identify features which are economically important also. We call as obvious geological areas. So such areas can be again visited for a ground check and immediately can come out with that. So also to find out meteor crater or asteroid crater, whatever it is, you look for these important features in the satellite pictures or the maps. This circular structure covers an area of 16 square kilometers with a diameter of about 4 kilometers. Again, it is a simple crater and rising about 250 meters above the ground level. The Ramgarh structure is located in the central part of the Neo-Proterozoic Vindhyan basin of Rajasthan. In our geology, we call it Vindhyans, which are nothing but Neo-Proterozoic, about before the Precambrian, we call. On a regional scale, the area in and around Ramgarh structure comprises the rocks belonging to Bandar group of Vindhyan supergroup. They are geological terminologies. Sorry, you may not understand. So this is the Ramgarh impact crater. This is the satellite picture. This is the physical feature. So we were comparing that with the Arizona, impact crater. That is aerial view of meteor crater near Winslow, Arizona. This crater is 1.2 kilometer diameter and 170 meters deep. So this exactly resembles our Ramgarh crater. The feature which confirms its meteoritic origin are the follows. What are those? Near circular morphology, possible shatter cones, IRS-IA image analysis, shear fracturing, granulation, anomalous birefringes in quartz grains, closely spaced fractures, and multiple joint striated surfaces in quartzites, presence of nickel iron rich rounded microglassy objects, glassy spherules, severely fractured quartz grains with corroded margins and microprobe analysis of magnetic spherules. See, these are the typical, you have got so many evidences. So there should not be any iota of doubt at all, whether it is an impact crater created by a volcano or a meteorite. So these are the evidences already collected. That's why I think a few years back, this was also a doubtful impact crater. Now it has been confirmed through several studies. A detailed petrographic studies of the sandstones around the Ramgarh structure has revealed that the presence of planar fractures and planar deformation features indicating shock metamorphism. As I told you, the Lonar crater is the only one where meteorite hit a hard rock or the basaltic or the Dikentrap rock. Here it is hit on a sandstone of the Vindhyan group of rocks. Well-developed parallel set of narrow open fractures are noticed in the quartz grains, exhibiting shock features, the planar features, what we were explaining. And owing to these diagnostic observations, indicating shock metamorphism due to meteorite impact, it is informed that Ramgarh structure is of impact origin. So that is Ramgarh crater is certainly an impact crater created by meteorite. For quite some time, the Ramgarh crater was believed to have impact origin. However, convincing shock metamorphism features of geochemical indicators were missing. So recent works of Agarwal, that is Amar Agarwal from IIT Kanpur, reported the planar deformation features and also feather features to establish meteoritic impact origin. The Ramgarh impact structure formed in upper Vindhyan sediment rocks perhaps during the Middle Jurassic age. See, it's again, the same Jurassic period. Arguably, the most remarkable feature of the crater is its 200-meter high and 3.5 to 4 kilometer with wide annular collars have been identified. There's rings, annular rings, rounded circular rings have been clearly established. Within the collar, the central depressions covered by soil with an underlying sequence of shales, siltstones, and sandstones belong to the Riva and Kaimur group of. I should not enter into detailed geology. I think that is enough on the Ramgarh crater. Let us come to the third crater, that is Dhala impact crater. This impact structure is an impact structure found by an asteroid impact. It has been established. What are those evidences? I will deal with that. It is situated near Bonti village in Pichor block of Shivpuri district of Madhya Pradesh, and it is 200 kilometers east of the Ramgarh crater. So when you can, if you look, for example, in desert also, it's all sand covered. When you look for such craters, perhaps you will be finding several craters adjoining, each other. So this is hardly 200 kilometers east of Ramgarh crater. It is the largest impact structure in Asia, mind you. And the diameter of the structure is estimated at 11 kilometers. So far, we were talking about 4-kilometer diameter. Now, this is the largest impact structure. That is Dhala crater. Its diameter is 11 kilometers and covers an area of 64 square kilometers. And it is the second such structure found in India after Lonar. Unlike Lonar crater, Dhala is supposed to be a complex impact crater. So we were talking about what is simple crater, what is complex. So this Dhala crater It's a complex crater where you can find, I think, more than 1 or 2 rims. So this is the satellite picture once again. The stratigraphy of the dollar structure starts with a fractured granitoid. So see again, once again. So we had basalt or Deccan trap in Lonar crater and sandstone of Vindhyans in Ramgarh crater. Now here we are dealing with granitoid basement, which forms a basement with a 12.36 meter thick suite origin. So I will come to that. What is suite? That is a consolidated breccia, because of the shock hit. And over the fractured granitoids lies a 65-meter thick layer of impact melt breccia. That is the suite. So this is a wonderful evidence to say that yes, it is an impact crater created by the meteorite or an asteroid. It comprises quartz, feldspar, zircon, and some opaque mineral class with partially to completely melted granitoid and highly vesiculated, means a lot of vesicles are there, means a sudden chilling, sudden cooling. Melt class embedded in a very fine grained matrix of mainly quartz and feldspar. These are the two different minerals, rather major minerals present in the granite, the type of rock, which is an acidic rock, unlike a basalt, which is a mafic or basic rock. A 1.8 meter thick layer of altered suite occurs above the impact melt breccia. See, such is the impact. So this is the suite, picture of a suite. It's a type of impact breccia. Breccia means angular fragments embedded in a fine-grained matrix. That is a simple description of a breccia. It's a polymorphic breccia, where the breccias, what you have got inside this, if they are of different composition, maybe shale, sandstone, or any granite, then we call it as a variety of particulate, this thing, a polymorphic, sorry, I was referring to. It is not a simple breccia, it's a polymorphic breccia. Then these are created because of the shock metamorphism created by the colliding meteorite or granitoid. So these are things you should look for, because we should not ponder about whether it is a meteorite impact or now volcanic impact. If you find these geological features, you can definitely say, yes, this is it. So why I'm telling our young students are there, if they collect this kind of information and look for these evidences wherever they go, so they can come out with beautiful results. An integrated study by Sean Lee et al. On the petrology, geochemistry, and zircon, uranium-lead zircon geochronology, that is aging, dating, and rare earth element geochemistry from the structure, that is Dallas structure, along with and analysis of the grain morphology and textural features, has given a new insight into the nature and timing of the impact event. So it has been thoroughly studied, both from the geochronology, geochemistry, petrology, different aspects of geology. The zircon grains from the impactites show textures typical of shock deformation attributed to the impact event. They identified the presence of rhyolite based on the Raman spectroscopy and characteristic of such a persistent planar fracture, bringing backscattered electron images and a lack of zoning, which are all diagnostic features of this mineral formed during an impact event. Like malinskite, what I told, the plagioclase feldspar, that's again because of the impact, this metamorphism. This is also a mineral called rhyolite. So if you are finding that rhyolite, that means it is a shock metamorphic mineral. Zircon uranium lead data from the various rock types in the basement show magma emplacement at 2.5 to 2.47 gigaannum. That means billion years. So this is such a old crater. And the lead loss feature suggests that the impact might have occurred between 2.44 and 2.24 GA. So quite an old impact crater. Another minor group of late Paleoproterozoic zircons with concordant ages of 1826 and 1767 million annum in the brecciated quartz reefs along the margins of the impact crater from non-fractured grains represent an younger thermal event after the impact. What happens in zircon while you are dating different, different zones are there. If you keep dating each zones, each layer, it will give different. So that means it gives the age of 2.5 as well as the age of So 1826. So how do you account for this? That means there must have been a different thermal event subsequent to the impact. The rare earth element patterns of the Neo-Archean to early Paleoproterozoic zircon, that is this age, 2.5, zircon population reflects the effects of hydrothermal alteration on a peralkaline host rock, that is granite. The abnormally high concentration of K2O in the impactite, that is around 15.91, nearly 16%, is also consistent with metasomatic alteration associated with the impact event. So these are the clues, which you get by dating, by probing, by analyzing the samples. Then let us come to the doubtful so-called, these are the three important craters which have been confirmed without any doubt. Now let us come to other craters. I am not sure how much time I'm left with. I should brush through because Dr. Bharat has already told me we are running behind schedule. But anyhow, I will just brush through this, if you permit. A meteorite impact structure has been recognized near the village Luna, located in the Barni Plains of Kutch district. So here, what is the geological characteristic? It is located within hard rocks, while most of the other craters, but this is the one which is located within an extremely low-lying flat terrain. I was initially telling, the morphology, that matters. And comprising unconsolidated soft sediments. That means they are the sediment rocks where the meteorite has hit in Luna. It's a sediment rock. So what will happen? The impact will be very, very minimal in the sense that the shock metamorphism may not be so high because it is not hitting a hard rock. This is a unique site as it lacks the characteristic of a typical impact structure. That's what I was telling. In the center of the crater lies a circular lake of around 1 square kilometer, which dries up during summer. Only during monsoon time or the rainy season, that lake is filled with water. The depth of the lake is hardly 2 meters. It's not a deep depression. The rock is soft, and the rim of the crater is covered by thick vegetation, mainly of thorny trees. The rim of the crater appears to have been eroded. See, that's also because soft sediments, they get easily eroded away, as the debris is composed of unconsolidated soft sediments. The irregular to tubular shaped dark colored heavy fragments collected from that crater, which are of 1 to 10 centimeter, are reported at some places. Some of these fragments are strongly magnetic, and some are non-magnetic, and some are glassy in nature. So these are the important features which they have found. The magnetic materials are comparable to fragments of iron meteorite. You see? So there are evidences. Okay. And the glassy materials are tectites. That's the impact structures formed due to melting of soft sediments during the collision. They can easily melt away. Presence of stishovite and coesite, the high pressure polymorphs of the silica. Silica is again a quartz. So these are the high pressure minerals have been found, stishovite and coesite, in the meteoritic fragments, confirms the meteorite impact of origin for this crater. The Kaveri crater, I think I need not tell. Our Professor Subramanya has given a very elaborate talk on that, and he could find several evidences to call it as a crater. Yes, he has shown all these. So I am not getting into that. So now there is something called a Shiva crater. This I think many people may not be knowing. This is a submerged crater off the west coast of India. This is the Shiva crater. It is a crater which is in the Bombay High region of the Arabian Sea. It is estimated to be 500 kilometers in diameter. So Chatterjee of Texas University and his team has worked extensively, though people do not, some of the people do not agree that it's a crater. But then I will give whatever the Chatterjee group has found evidences. The mysterious basin off the coast of India could be the largest. So this is important. Multi-ringed impact. It's a complex crater of the world has ever seen. See, nowhere in the world a crater of this dimension. Can you imagine 500 kilometers in diameter? As per the new study, it may have been responsible for killing the dinosaurs of 65 million years ago. So we were just talking about the dinosaurs, that Jurassic period. This is also coinciding with that. You know, Pankaj Chatterjee and his team of researchers took a close look at the massive Shiva basin, a submerged depression west of India that is intensely mined for its oil and gas resources. You might have heard Bombay High. This is the high, This is a uh, created by so-called meteorite, huge meteorite hitting the Earth. Some complex craters are among the most productive hydrocarbon sites on the planet. So this is the picture, in fact, a three-dimensional picture, I should say. This is where Bombay High is located. This is a high. It is called Bombay High. The feature is that, there are different multiple rings, 1, 2, 3, like that. That's why it is called complex. That diagram which you just saw is a three-dimensional reconstruction of the submerged Shiva crater at the Mumbai offshore basin, western shelf of India. The overlying 4.3 mile thick Cenozoic strata, Cenozoic is a period, age, and water column were removed to show. So it is not just, because when you say that it is submerged, how you get all these pictures? So they have, technically rather theoretical, they have removed it and constructed that 3D diagram. Sorry. Unlike typical known extraterrestrial impact structures, Shiva is tear-shaped, means a kind of bubble shape, roughly 600 kilometer by 400 kilometer. It's a huge crater. You cannot imagine. It is also unusually rectangular in shape. And Chatterjee argues that the low angle of an impact combined with boundary fault lines and unstable rock led to this unusual formation. The age of the structure is inferred from the Deccan Troughs, which overlies a part of it. So Deccan Trough rocks are also there. That's why it is called as Jurassic period. The geological evidence is dramatic in the sense Shiva's outer rim forms a rough faulted ring, some 500 kilometers in diameter, and encircling the central peak known as the Bombay High, which would be 3 miles tall from the ocean floor. See, that high is 3 miles higher than the ocean floor, about the height of Mount McKinley. Most of the crater lies submerged on India's continental shelf. So it is not visible now unless you study geophysically. But where it does come ashore, it is marked by, wherever a part of it is exposed, it is marked by tall cliffs, active faults, and hot springs. So these are the features you get. The impact appears to have sheared or destroyed much of the 30-mile thick granite layer in the western coast of India. So there are peninsular gneissic granites. It has sheared that granite, which has, deformed it. Rocks from the bottom of the crater will tell us the telltale sign of the impact event from shattered and melted target rocks. So when you go there, you can study all these features. And we want to see if there are breccias, shocked quartz, and an iridium anomaly. So I told you there are certain PG elements associated with the impact craters. And Chatterjee opined that we want to study all those. And asteroids are rich in iridium, and such anomalies are thought of as the fingerprint of an impact. So several fingerprint of geological features I have told, which is one of that. But if the team is right, that is Chatterjee team is right, the Shiva impact vaporized the Earth crust at the point of collision. Where it collided, it has vaporized, leaving nothing but ultra hot mantle material to well up in its place. Again, he says that because of the impact also, the Deccan basalt must have flooded, got erupted. It is a kind of catalytic action it has made. That's why it is a Jurassic period. It is likely that the impact enhanced the nearby Deccan Troughs, volcanic eruptions that covered much of western India. In the beginning, I told you that Deccan basalt rock has covered a major part of Maharashtra and another southern part of Gujarat, and main part of Gujarat, I should say, a part of Madhya Pradesh and a part of Karnataka. What is more important is the impact broke the Seychelles Islands off the Indian tectonic plate and sent them drifting toward Africa. See, where these Seychelles Islands are located now, near the Africa. whereas it was part of our western coast of India. So it has broken that and shifted that. That is the kind of impact it has created. So this is the last slide. As we were telling, though they are very, very, dangerous things, meteorites, that create havoc among the living beings or the forests or the plants and trees, but they are really a source of some economic minerals. What are those? Though the impact craters are known to have played havoc with the terrestrial life and the environment, but are also known to host significant mineral deposits of economic importance. Impact structures are often associated with economically significant deposits of diamond. Can you imagine diamond? Uranium. Why diamond? If the meteorite is hitting a carbon-rich part and high temperature carbon mineral is nothing but your diamond, high temperature and high pressure. So you could look for diamond, uranium, nickel copper sulfide ore, gold bearing veins, and hydrocarbons such as petroleum and gas. All these evidences are there. So we are having this mineral potential in different areas. The Red Fort crater in South Africa is associated with the gold bearing strata of the Witwater sand. This is a very important gold deposit in South Africa. So this is associated with that big Red Fort crater. The Sudbury in Canada, which is also an important crater, is a world famous deposit known for nickel, copper, platinum, palladium, and gold. The investigations by the Geological Survey of India has revealed mineralization of PGE group of elements near Metropolium, Satyamangalam, and Sitampulli, as Professor Subramanya himself has pointed out. So Geological Survey of India has found these deposits, which in case if Shiva crater is really an impact crater, these are the evidences which goes, in favor of calling Shiva crater as a real crater. Friends, sorry, I think I have taken a bit more time. There I end this thing. Thank you for your patience. And I immensely thank Professor Bharat for giving me this opportunity to share a few of my views on this impact. Thank you. Now I am, amenable for any questions so that I can clarify the doubts. Thank you very much.
Thank you, sir, for your wonderful talk. If we have some question, definitely I would like to ask our participants to ask a short question because we are racing against the time right now. So if there are any questions, please, the floor is open. So you can ask a question to the professor and he will be able to give you some answers. Any questions?
Either I am too clear or I may not be clear at all. Thank you.
No.
Thank you, sir.
Lunch time is near, so I'm aware of it. So, can we thank Professor Krishnamurti by giving him a big hand?
Thank you, sir. Thank you all. Thank you all for your.
And can we move to the next speaker? Ankush, are you available? Dr. Ankush, sir.
Can you hear me?
Yeah, can you hear me?
Yes, I can hear it.
Yeah, Dr. Ankush has been, sir, with us for lunar eclipse, lunar expeditions.
Oh, I see.
And we have extensively used your paper during our expedition program, wherein he was able to identify tectites. So he has worked with us earlier, and at present, my dear friends, he is a young friend of mine who has already worked on lunar, but today he is a scientist at Vikram Sarabhai Center in Trivandrum, and he is now working under planetary sciences, and he is one of our youngest scientists around who interacts with us on every asteroid day program, because his association with us goes long back, and besides that he has been a brilliant scholar in his subject in solar storms. So he's going to talk to us about solar storms and the impact of solar storms on the meteorites. Yeah, the topic is his interest, and he has done some very interesting work on this. And he is not one of the persons, but I strongly recommend all of you to listen to his talk. I know you are all awaiting for a lunch break, but I think the best option is to listen to him. And Ankush, it's my earnest request because we have been so late in most of the program. So we want to cover up. So if you can give a talk, yeah, up to say 115 or 120.
Mhm.
Yeah.
Yeah,
So
yeah,
as my young friend, I request you.
yeah, sure, sure. Yeah,
Yeah.
I can understand. It's lunchtime, and I'm
Yeah.
standing between
I'm
lunch.
sorry, but yeah, today
Yeah,
we
I
have
will
to.
try to yeah give
Yeah, the
very
floor
quick
is
overview.
yours.
Yeah. Thank you very much, sir, for inviting me, and it's always my pleasure to share something which excites me to young students and kids around globe. So I will be talking. Its a title is very different. You can understand. I will be talking from cosmic collision, like solar storms, to the impact craters. But as one should understand, everything is linked in the universe. We just make different compartments. So somewhere this impacts asteroids and space weather, everything is linked, and that I will try to convey at the end of the talk. So I will be quick in
Sorry,
my talk. So
but
forgive me if I'm going slightly fast, but anytime you can stop me and ask if you have questions. Yeah. So as I'll just go, we have been observing the cosmos, specifically starry sky, since Stone Ages or whenever when human came on the Earth. And one of the well-studied subject I will say is astronomy by human, because sky was there that time also and now also it has been observed very long time. And civilization has seen comets, meteors, and definitely some fireballs witnessed in ancient times also, as we do nowadays. So I will just start with the sun first. That is the one of the closest star, and it impacts us continuously because it continuously emits light, and because whatever life on the earth is because of the sun. But there is an unseen part of the sun which we call like we need some telescopes or something or special filters, or we need spacecraft. Then only we can actually look at those. So this is the image of the sun. You can understand if you see daily mornings or sunset, you will just see flat disk. But if you closely see, sometime if some there are dark spots on the sun, and they are visible sometime with naked eye during sunset or sunrise if they are fairly big enough. And those are very interesting for us because those are reflection of sun activity, or how the sun changes over the time, and they really do connect to earth somehow. That I will just come to that point. So this is just for as I know there is a very young audience, and just to keep it low, sun is not a simple sphere, but it's made up of different layers. Like you take an onion and peel it off, and you have a different layer. Similar way, sun do also have like this layers. And at the center, you have a core which is reaching around 2 crore degrees Celsius temperature. And at the surface, if you reach from different layers, you have around 6,000 degree temperature of the solar surface. And as I said, it's not a flat disk, you have sunspots, and this whole hot plasma will be forming like flame-like structures, flare like sudden burst of energy happening. So sun is highly dynamic. That's what I wanted to tell you. And whatever happening on the sun propagate into the solar system, and it affects everybody around us, including planets, asteroids, or even comets. And that's what we understand at present about the sun. And the sun is a very interesting. How do we know sun changes? Sun could change from minute time scale to the scale time scale, and solar cycle time scale is around 11 years. So every 11 year, if you start counting the number of the dark spots, and you will see sun varies in 11-year cycle. So sometimes you have a lot of radiation coming from the sun, sometimes very low radiation coming from the sun. So that is how the sun changes, and that's radiation, electrons and protons or particles coming from the sun also do change. I'm just creating the background so we can link later. And this is how what we understand about weather around the earth. Like we know there are like winds, clouds on the earth, and there are sometimes cyclones, tornadoes coming. So similarly, interplanetary space, the space between Earth and Sun that we call interplanetary space, is filled with this plasma coming from the Sun, which is continuously getting emitted. Okay, and this controls the weather. Okay, or what conditions, plasma conditions in the interplanetary space, and they could be very harsh because Sun is not only giving UV X-ray lights, which are harsh definitely, but it is giving energetic particles, MEV energy or KV energy particles continuously coming from the sun, and those are very dangerous for spacecrafts and human. And that's why it has now new things has come in picture, which we call space weather to monitor continuously and to know how harsh conditions are there. Because we know now just recently, Indian astronaut has gone to ISS, right? So they are above the Earth's atmosphere, and they are actually witnessing this space weather conditions, and badly they get affected also if conditions are not good. So these new terms, not everybody is aware. So just thought to familiar and how it is going to be important in this space era. So like this continuous stream of particles coming from the sun, so we call that is a solar wind. It's like a wind flowing from the sun in the whole heliosphere of the solar system. And it is analogously, Earth is like a spaceship traveling through this solar wind. And similar way, like you can see here, the ship traveling from in the ocean creates this type of bow type of structure around it. So similar way, Earth is also traveling this solar wind, and it also formed the bow type structure. So here it is very clear. You can see this is a beautiful animation showing from left. You have a continuous solar wind coming, and center there is a Earth, and this is Earth's magnetic cavity, which we call magnetosphere. And you can see it's like a comet type structure, compressed at the day side and elongated the night side. So its continuous solar wind do affect the planetary environment, and there are some time instances when we have a huge solar storm coming. Okay, those are called solar storms, like cyclones on the Earth. They are huge in size. We cannot even imagine how big they are. But sometimes sun sends the solar storms to Earth, and this hot plasma or hot charged particles coming from the sun enter in the Earth's cavity, magnetic cavity, causing auroras. You might have heard about auroras, and a lot of energization within the magnetosphere. Yeah. So let's come to the asteroid now. Like as I told you, Earth is sitting in the solar or interplanetary space in a space so that is affecting Earth, Venus, Mercury, all the planets, and Mars, and even asteroid belt is sitting here. So even asteroids actually witness this continuous stream of charged particles coming from the sun, and it bombards the asteroids, and they really do affect even asteroids. So, but the asteroids, I will talk about that in later term, how it really affects. So asteroids are, just to get idea what is asteroids, a form where during the solar system formation. So there were number of multiple rings, not only just 8 planets now. When Earth formed a billion year, 4.5 billion year back, it was a gas cloud condensed at the center. You have a sun forming, and remaining material every ring forming a planet. So there are more planets of the solar system, and somewhere leftover material also. So possibly asteroids are leftover material of the early solar system that got cooled very faster, and that's why smaller in size, and they retain a lot of information of early solar system. I think later talk from Gaur, she will be talking about maybe early solar system. She will talk implications about why asteroids are important to study to understand how the solar system evolves. Now, these asteroids also do have a lot of link to the craters. So how? Let's come to the craters. Already initial talk by Dr. Subramanya, and just before also one was talk which has covered about impact craters. So what is impact crater? Already you are aware. Crater means a bowl, actually meaning crater in a Greece. So actually, first of the extraterrestrial crater seen by the Galileo, definitely when he pointed his telescope to the moon, he saw moon it has some craters, and those are like puzzle what caused them. Either those are formed due to the volcanic origin or something else. But that puzzle has come to end now. It's we now do understand what craters are formed due to the impact and what not. So now we know there are a lot of impact craters on the moon, and not only moon, other places also. And these are the sources, primary sources of these craters, like asteroids. Okay, asteroid size of tens of meters to kilometer size could cause a big craters. Then comets, rarely sometimes comets can hit, and that also can cause a crater. Sometimes it depends if it reaches the surface. And there are small meteorites also small. If meteorites survive full fall, and they can fall small size depressions also. These are the primary sources of craters, what we understand. And just to get idea how we are surviving in this cosmic world, though they are rare, big impact craters happening on Earth or any planet, but these are the trajectories of Earth intersecting different planetary bodies. And we should understand billions of years we have crossed multiple asteroids and left over material in the solar system, which impacted Earth and shaped the Earth's surface. So this is the one of the nice image I like. So you can see craters everywhere from Mercury. Even you look at the Mercury, it looks very resemblance to the lunar moon. It looks like a moon only because Mercury doesn't have atmosphere. So most of the impact craters are well preserved like the moon. And even Venus is not very much visible. It's very under thick cloud, but radar images sometimes can give information of the Venusian surface, and some craters have been seen. This looks very complex crater, multi-ring crater you can identify. And moon definitely, we do see every time with small telescope also these craters exist. And even Mars do have multiple craters. And even asteroids do have. Asteroids do create a crater, but note that there are small craters or even asteroids. So small during collision, fragments are generated, asteroid, and those could create a secondary craters. So asteroid also could have craters their own. And this is one of the beautiful image captured by our own Chandrayaan, and you can see Chandrayaan 3. So you can see complex iron crater with the multi rings and at the central peak on the moon. And lander also, where it landed, there was a small crater nearby, which we didn't go to, but yeah, we have seen a small crater nearby the lander also. So these are the simple how these craters form already have been talked. So I will quickly rush for that just to tell you there are two types generally. If, broadly, we can talk like a simple crater which forms with a small size, but this can change planet to planet. Okay, simple crater size definition depends because gravity defines the simple or complex crater, and there are complex craters like this. You have central peak coming up, so it is analogous to water. You can see water droplet at peak center, it lifts up. So similarly, when a huge impactor hits the target or any planetary body, the contact point, they are not rocks. They behave like a fluid, fully like a fluids interacting. And that's how this complex crater come in like a center peak because of that. So just to get idea of how much pressure we are experiencing at the contact point when it hits, around 10 to 100 gigapascal. That is a very huge pressure. And the temperature can reach 10 to 20,000 Kelvin. So at that temperature, definitely things will be shattered, metamorphosed, or getting ejected, evaporated, and then condensed. And that is what happened. And there is a shock wave propagating in the base target rock, which push the rock material very far away, like ejected material and even fractured material. So these are the like simple craters seen on the moon. You can see very sizes. You can see very different, and there is a morphology. I think I will not go into that. Already has been covered up. So this is a Barringer crater. I was fortunate to visit this crater, including Lonar. So when I was in USA, I do really say and it's amazing crater to see because it's in a deserted area. Arizona is a desert, and when you stand near that, and if you walk around the crater, still you see these all impactites like shuttlecomb type of structure, breccias, glasses, spherules. Those are still visible. And this is the first anomalously confirmed impact crater on the Earth. And after that, you may know how many craters, more than 200 craters have been identified and confirmed. So this is just 1.2 kilometers size, whereas Lona crater rim to rim around 1.8 kilometer already covered. So this was also like Rudra mentioned, we had a long field trip there and lot of impactites we collected and analyzed and studied, and also we were convinced, okay, it's impact origin, but we found a lot of interesting stuff that time. So this is another Ramgarh crater on Earth. And now we have like this is also big crater, and you can see it resembles like Arizona crater, similar in nature, because this is in also Rajasthan, slightly deserted area, and more also are come from Luna and all. So impact craters are becoming important, and due to remote sensing and awareness, now we are getting a number of craters getting identified. So I will just come to why, how the space weather and these craters and asteroids are linked actually. Okay, so asteroids form in the early solar system, which they fall and create craters. But these asteroids also are very important to be studied because they retain a lot of information of early solar system. So sun was young and more active than now. Now I already mentioned you. So sun varies in 11-year solar cycle, but that is a recent sun. We are talking about 4.5 billion year after the origin of the sun, right? But when sun took birth, it was young star and very aggressive star. It was sending super storms, big solar storms every day to the Earth. Now it is happening few hundreds, once in a few hundred year, one big storm coming that level, but that time every day. And when it is impacting, even it was having so a lot of asteroids around them, and this asteroid has its own magnetic field. So solar wind actually causing this impact on these asteroids, and some seed magnetic field or interplanetary magnetic field when asteroid got condensed that was frozen in. So these asteroids are maintaining, remaining, keeping some frozen in magnetic field or seed magnetic field of early solar system. So that is how it is very important studying the asteroids. And not only asteroids, so asteroids are becoming very fascinating because now we are going to the asteroid, we are taking samples from asteroid and coming back, right? So we need to know what is the condition around asteroid. So this solar wind, which I talk about, continuous stream of charged particle, actually impacts the asteroids, and it forms like a comet type structure around the asteroid. So if you go near the asteroid, the environment, harsh radiation environment will be very different. So where we land, go to the day or night side of the asteroid, it will be very important because the particles coming from the sun directly hitting the day side, whereas night side you have a wake, there is a shadow type region, but still there are a lot of particles can have energetic particle coming. So suppose in future we want to go and study asteroids, we really need to understand how the solar wind or space weather around the asteroid is, such that our missions can be protected. Otherwise, even harsh radiation environment can impact our missions. So this is one of the interesting things, space weather. These asteroids have been, which in the solar system, they are continuously getting bombarded by solar wind, and there has been called tanning of asteroids. Means what happened? The asteroid color has changed, or they have become like a reddish in color. Why? Because there is no air definitely in interplanetary space which can cause weathering, but there is a solar wind which is causing weathering. So million of time scale, no, it takes a longer time scale. It's not just 100 years or something. Solar and weathering take around million-year time scale. During that, this tanning or surface of the asteroid become reddish in color. That has been observed due to the solar wind interaction. Another is like we can see asteroids. This asteroids, why important? Another thing is that they are getting impacted by charged particles. Not only that, but they are getting impacted by solar light. like you have UV radiation and X-rays, and if sun is very active, depends what phase of the sun. Suppose you plan to go to asteroid, if it is very high activity time, it is going high radiation of UV and X-rays. And that time, this asteroids could get charged heavily, and they act like batteries. Okay, so that's why there will be electric field generated, and that will control plasma, how the plasma or radiation move around the asteroid. So future landing or sample return mission, we need to really understand how this solar activity or sun changes the charging processes on the asteroids. And even moon, this happens. So this is one of the recent missions. People may be aware already. Osiris touched the asteroid and even dig out the samples. But this is the first type kind of it, and but in future maybe there will be many missions coming to study asteroids or sample returns also. So we learn a lot about it. So another very interesting, if I may not be aware, everybody, in 2029 there will be a closest encounter of Apophis asteroid, which is not very big, few hundred meter in size, but we are safe. Luckily, it will not hit the Earth because trajectories now we know very well. This is a recent image of Phocis in 2021. Very far now it is from Earth, but it will be hitting, means it will be coming close to the Earth. And how close? It is going to come just 32,000 kilometers. Okay, our geosynchronous satellites, which are sitting 36,000 kilometers, it will be well within their orbit. Okay, so that is very amazing stuff. And definitely all over the globe, there will be missions and some science problems people would like to address, and they are in preparation for that. So another why to study, as I mentioned already, we want to go to future. Already solar system exploration started. Now as a human, we are not just going in a space to moon or something. Even we have gone to asteroid, and there are crazy missions which we want to land on the asteroid or capture the asteroid, do the mining of the asteroids. Okay, these are all futuristic stuff. And when you do that, we want to send human and space in human and spacecrafts in the space. We really need to understand what are the interplanetary conditions, what are the space weather conditions, how the solar storms are they coming towards them, so we can really protect our equipment and even astronauts. So this is one of the nice example, like a moon. It doesn't have atmosphere. Okay. And that's why we are not protected. Astronauts on the moon are not protected. Only sometime moon, when it comes under the Earth's magnetosphere, it is protected from the solar wind or harsh solar wind conditions. But most of the time, like in a whole month, only 7 days we are getting protected from Earth, but remaining time we are in the solar wind. So whatever happened on the sun, energetic particles, hundreds of ME particles directly hit astronauts, and it is becoming critical now to really understand. So impact craters, how they are linked for that. So impact craters on the moon, we have already known there are a number of craters, and for future exploration, many scientists are exploring their advantages. Like suppose these huge craters can sustain water, that is known, right? Suppose there is a permanently shadowed region, they have identified these impact craters could harbor water in a frozen in condition. So that is one advantage. Another, if you notice, this cartoon shows there are energetic particles coming from the sun and galactic cosmic rays. But these craters, if deep enough, and if you are astronaut standing in a shadowed region, it will get protected from this harsh radiation directly hitting to them. So this impact craters also could provide very amazing basements or hiding spaces for the astronauts as our planetary programs is getting accelerated. So from space weather to crater, we have a lot of linkage. You can understand now, even impact craters form a huge crater and catastrophe on Earth called extinctions. But this craters itself could provide basements and future explorations for a human. So I will just stop here, and if any questions, I will just take. So I just try to put how the linkages are there. It's not fully like impact crater talk or asteroid, but space weather, asteroid, and impact crater, how they are linked. and could be very beneficial for our future explorations. Yeah, thank you.
Thank you.
I can take if any
Ankush,
questions or people are hungry.
Dr. Ankush, there is a one thing that I have to convey to you, that your sample from Baringer crater is today in the exhibition hall for
Oh,
which you had given me after your Baringer visit back to India. It's today put up in the exhibition hall for people, young people who are here to see that. So this meteorite which you have brought, meteorite means the sample from Baringer crater, you have brought to Nehru Science Center. I am displaying it in the Science Museum Hall. So thank you for that also. I
oh,
personally, and another thing that I want to ask you and ask the participants, that I want you to maybe one or two questions. Will you be able to take up?
yeah, yeah, sure. If
Yeah. My good friends who are here and school boys are here. So I thought it will be a good idea if you can answer. Please, you can ask any question. Rajiv, any question? And any one of you who have questions, because remember one thing, Professor Bandari was here. You know what he had done? He had looked at particles coming from outside, and then it was going into the soil. Now, when it goes inside the soil, how it interacts with our soil itself was his basic research. So, Dr. Ankush is pursuing the same line. Now, what happens when the radiations come from sun and enter the Earth's atmosphere and then hits, or probably it hits the asteroids, and what happens? So the objective, what why we are asking both young older astronomers as or older scientists and younger scientists like you to look at these possibilities. It's not important that everything has to be there in your book or on your e-stories. It needs also analysis. And the objective of doing these asteroid seminars is primarily to bring in this concept, because we have been discussing, Dr. Ankush had been with us in Mumbai also. So, and he has done his astronomy. He's a Bombay boy. And he has done so much of work. Now he is at Vikram Sarabhai Center in Trivandrum. And the most interesting thing that I want to share with you, science is not done only in the laboratories. It starts from home, where you have your food, right? So I want to thank once again Dr. Ankush for your Baringer crater sample. Once again, thank you for your talk. And if possible, we will offer you a gastronomy. Thank you.
yeah, thank you very much. Actually, it's my pleasure. Like that, the sample can inspire many students. And sir, you have been one of the big inspiration. I should mention, Dur sir, when I remember when I was a 12th standard kid, when I came to Nehru's Mandarin and met him first time, but he believed on us. Like he said to me, I still remember, like any school student also can do research. And I was like, oh, is it okay? And I was so inspired, and really we could really come up with, even to us, and I was college student, we could really got very new stuff that time. So really it motivated me, and I should say thank you, sir. And thank you for organizing such event, and keep motivating young generation. Thank you.
Thank you very much, Ankush. Now we
Yeah,
have
bye
a
bye.
small photo session with Professor Bandari. And the young boys will be photographed with Dr. Bandari. Thank you so much.
Yeah, bye bye.
Okay, bye. Yeah, I have already announced Dr. Bandari is waiting for us for a photograph of all of you. So please join us for photograph, and then we move to have our food. Gastronomy will be there, so don't worry. We have asked the canteen people either to bring it here instead of going upstairs and downstairs. Let's be together, and please feel free to ask any questions. You don't have to fear any one of us. Yeah, Rajiv has some very interesting things to show you. If you finish your lunch earlier, he is ready to show you how he has taken video photographs of meteors coming down. So,
I have been capturing meteors since 2017, but there's no point in these captures from a single station. Ideally, you have one station here, you have one station 50 kilometers on this direction, one station 50 kilometers in this direction. If I am just one station here and I see a meteor come like this, I am not sure if it's coming like this, or it's like this, or it's like this. There's no directional information. With three cameras, 50 kilometers, 100 kilometers apart, there's triangulation. It's called station pairing. Now, I have been trying to motivate people for since 2017. No one is interested. The money for the camera comes from your pocket. The hours that you spend sorting through the captures is yours. It's a loss. There is no payment. On top of that, if you finally find a meteorite, because of a result of your triangulation, you can calculate the path and you know where it has landed. GSI will come and take it away, or the government laws are so unfair that everything belongs to the government. And this is a Britisher rule. And my question was,
I have got the book for you, in
there's
which
a
it has
quotation.
been announced if anything falls within your house, you have to give it to the government
So
or to the
अंग्रेज
GSI, Geological Survey of India.
अंग्रेज चले गए, लेकिन हम उनके चमचे ही रह गए कि वही
And
law
we still believe that if that property belongs, it says in 1868, anything which falls from the sky on anyone's ground, it is a property of Geological Survey of India. And once it goes there, even we cannot get a sample piece to analyze.
now this
It's not a complaint. I'm just telling you how things are.
it is a complaint. We should all complain.
Yeah.
I mean,
But
the
please
Britishers took the
understand one
Kohinoor
thing,
diamond away because of
asteroid
this.
hunting. I have kept a exhibition upstairs where you will be able to see meteorites all over the world. And as I said, Dr. Ankush has given us a sample from crater in Beringer. So we are that way international. We are celebrating International Asteroid Day. So we have kept such in the Science Museum. And our objective is very, very simple. You can do it. You don't need, because now that you are getting everything on your emails or your computers. So going to a museum is for what? And when you go to a museum or to any science place, what you should be able to pick up is very important. For me also, my going to TIFR as a student was very useful because the experts over there were open. They were able to discuss with us, talk with us. Sometimes they would ask us whether you will like to be a volunteer. And I think today is the time when in India we need volunteers. And the need of volunteers, as you said rightly, is because people have to come in. And one of the objectives of this meeting is 1 minute I'm going to take is to create a all sky camera, or rather we have made all sky camera, but as he said, rightly said, you need not one observer, you need minimum 3 observers. And we are thinking of doing it all over the country. So any meteor which comes to India, we should be able to record. And he has been nice enough to see an meteorite falling right into his village. So the reason why we are all here is to do something very concretely, not dekhega, bhagega, no, none of that. We want to discreetly do this kind of work. So we are meeting for that as an asteroid day. And in future, if you need any inputs or outputs, we are all here. And all your emails are there in the register. So we can forward you any of that and you can interact. You can interact with us always, no problem. But remember one thing, doing only your exams are not going to help you. You have to do something concretely.
So if you could show them so that
Hey,
they get inspired.
One moment. Let them go for the photograph.
Oh, photograph session.
Yeah.
Okay. When we come back.
Yeah, we are coming back, and then we coming back means here you will go straight to the place here itself. I guess. I don't know. Somebody around? The food will be here, or a photograph they want to take. I think Professor Bandari is awaiting. Yeah. So I think we stop here for lunch, and exactly at 2 o'clock we are going to start the session. Please, we are sorry for the early morning part of it, but we have to make up. So we move to the photographs.
I'm still here.
Oh, no, we are joining you, sir, for photograph.
Photograph, okay.
We need to have your photograph, sir.
Everyone, just gather here.
Gather here itself. Hey, yes. Yes, what? Sorry. Please come here. Rajiv, please come here. We are awaiting for you and we don't want to hold back.
Shiva's wife. Okay. So, Shiva got wild and Sati this dance, क्या बोलते हैं उसको तांडव. Okay, and Sati's body was broken and leaking out 12 pieces fell everywhere. Those are called
Hey, where are you running away?
No, I actually was looking for sir.
Is it coming now?
I think it is running.
Thank you. History of science. There's a paper by
One moment, the lunch tokens are here with her.
people very careful. Recently, and when I went there, they already built a temple around it. Oh, there is one in Sitamarhi also. Very difficult to say that how to study. So these Jyotirlingas are, I think, they're you can say they're all these stones. Jyotirlinga means light stones of light. Fireball. So that is, but somebody has to go and split it down. Right. And I suppose that it may not be in the temple. You know, just build the temple there, it will be like outside or some they will be created around. Yeah, no, they are like, I mean, this was like, you know, Western and like, there's a big correlation between media showers and presidential states. So you will find like this was, for example, this place here in Germany, media shower. So people saw videos and said, oh, that's why the nature there. We try to connect to Lunar with what is the Ramayana.
Yeah.
Okay, in Ramayana, they say that when there is war going on between Ramayana and stones fell from the sky. And the whole earth vibrated. ऐसा लिखा हुआ है वो मैंने भी पढ़ा था he is trying to say it is because of Lunar.
Yeah.
I don't know, but Ramayana is not so old.
Rajiv, we should slowly go for the lunch.
Oh, lunch. Yeah, but.
So the boy is planning to August for the NASA study group.
Oh, I see. कहाँ पर जा रहे हैं? हाँ? Atlanta. Very good. So actually, one thing I wanted to tell you is to find a stone, how do you know it is a meteorite? That you must practice. He will show you. He has meteorites. So he can show you.
We have put up an exhibition for all of you to see that.
So firstly, they are heavier usually. Most of them are heavy. So by density, virtually density. More than 3. Earth rocks are only less than 3. तो एक तो वो है फिर उसका शेप होता है फिर उसमें वो खड्डे बन जाते हैं बाहर फिर you can smell it the smell of sulfur so there are I have in my book it is all written how to identify a meteorite and
This book is available?
translated in Marathi. I sent the latest version updated version
Yeah, I know.
because he is done from the old version.
You are
Somebody was translating in Hindi. So I said, don't translate this, let us update. So a lot of work has been done in the last 10 years.
Okay.
So I sent that version, Hindi version. उससे बनाई है उसमें सब लिखा हुआ है I added a chapter how to identify it एक तो क्रस्ट होती है उसमें काली फिर अंदर से अलग अलग होता है फिर वो कॉन्फ्रेंस बता रहे so you must get familiar and then if you find a rock which is strange then it is very likely to be a meteorite. Then send it.
This boy is studying in Lonavala.
अच्छा,
interesting and enthusiastic students.
But there's nothing like finding your own rock from the God.
But the law needs to change before that. No, the GSI will come and take everything.
We need to file PI.
Yes, they came and took away every stone.
Yeah.
I collected.
So the law needs to change. And people are wrong.
But there is one gazette notification that anything underground or from the sky belongs to the government. So it's not a law.
Okay.
Okay. So,
So one can refuse to.
what I have proposed is, and I think there should be a museum
Right.
where if you find a meteorite, you can keep it for display and people will come and see it and you can make some money or at least maintain the museum. But what is happening is very sad, I tell you. They've taken everything to Calcutta. It is very humid there. They don't even have funds to proper boxes. And when I collected in 1976 one meteorite fell in Gujarat. So I saw in the evening 9 o'clock that something is going. I thought it's gone past, maybe in the ocean. लेकिन वो वहीं गिरा सुरेंद्रनगर और वहाँ 9 बजे प्रेयर होती है रेजिडेंशियल स्कूल है तो मिस्टर मकवान इज द प्रिंसिपल so he was standing there and he came and fell there. So he called me up कि कुछ गिरा है तो पहले उसने डायरेक्टर इसरो को फोन किया तो उसने कहा नहीं हम पत्थर वत्थर नहीं काम में देते हम तो स्पेस में जाते हैं तो 3-4 घंटे लगे उसको मेरे को ढूंढने में. But eventually he called me, so I reached there at 7 o'clock in the morning and collected. Then the principal was very kind. मैं जहाँ भी जाता हूँ ना, so I know school. Your children are very smart. तो बोलते हैं भाई meteorite गिरा है तो कहीं से ढूंढ के ले आएंगे गाँव से जाके दूर अंदर अंकल ने देखा है या किसी ने देखा है किसी खेत में गिरा है. तो 200 बच्चे 2 महीने तक वहाँ पर हमने ऐसे तो छुट्टी करी प्रिंसिपल साहब ने तो हम सब गए 18 किलोमीटर में गिरे and they all learned how to distinguish it from the local stone because वहाँ पत्थर भी बहुत है. But finally everybody got one stone of his own. Then I collected all this. भैया ये दे दो ये सब काम करेंगे. तो एक दिन वो डायरेक्टर जनरल थे कृष्णा स्वामी वो अपने 6-7 लोगों को लेके आ गए कि सब जैसे का मैंने कहा ले जाओ क्या करें. फिर मैं गया वहाँ लेने के लिए मेरे को एक चाहिए पर्टिकुलर तो उनके पास बॉक्स ही नहीं वो ऐसे ही पड़ रहे हैं वहाँ. I was actually in a committee. I told them put them in Rajasthan or Gujarat where it is dry.
Is there anything we can do to change this legislation?
Modi. Nothing more will allow Modi. What can do? I even wrote. I was in some advisory board. I sent a proposal. But अभी क्या है कि he knows that he has some meteorites, but I can't tell him because GSA will come and take it away. Makki has many.
Yeah. But he's a seller. He did it last year. He came and showed here.
अभी क्या हो गया है कि people know the value is that they don't give it, they keep it. But it has no value. A stone is a stone unless you say कि क्या है इसमें. Anyway, these are the problems. But let us all try to have it's available for work. So anyway, I am so happy to meet everybody. And believe me, you came so very good and this young man. I never met him. He always talks to me and then disappears.
Let's have
Just take your lunch box. Everyone come here. Take your lunch box.
My breakfast. I paid for it.
ऍडिशनल पे करायचे त्याचे नाही नाही
माझं नाव लिहा
Hello, is anyone there? Hello. Hello, is anyone there? Hello, is anyone there? Hello.
Sir, you are able to hear.
Yes, yes. Hello, hello. I'm fine, but no, no problem at all.
Can we start, madam?
Yes, but the host has disabled screen sharing.
Because some of them are joining us 5 minutes, say about by 2:25 we will start. And
Yeah,
I'm giving you enough time.
yeah. Please enable the
Sorry,
screen
very sorry
sharing.
for delay.
Bharaji, please.
Pardon?
I need to share the screen, so you need to
Yeah, yeah.
yeah, give me an access.
Okay. Yeah. We have young students, so they have to join us. They were at lunch.
Hello, ma'am. Hello, ma'am. Now,
Yes.
now you try to share.
Yeah.
I will provide permission. Now you try.
Yeah.
Okay, thank you.
So can you see it?
Hello.
Can you see my
Yeah.
slides?
Yes, we can see you as well as your presentation.
And it's moving?
Yeah.
Yeah.
Okay,
Now it
great.
is
Let me
visible
know when
properly.
yeah. Just let me know when I have to start.
Yeah. So we are starting, madam.
Yeah.
We are not skipping to time too long because we are
Mm.
very sorry that we had to start late. Anyway, we want to do it soon. Yeah. Can I begin, madam?
Yeah, sure.
Okay. First, let me welcome you, Kuljit Kaur Maharaj, Professor Kuljit Kaur Maharaj, who is my good friend and also who is going to talk to us on understanding solar system evolution via meteorites and mission return samples. Okay, to tell you a few things about Kuljit Kaur Maharaj, the professor, is that she has trained herself in BSc and MSc in science, and at present she is the head of planetary sciences at Physical Research Laboratory in Ahmedabad, and they have the latest equipments for analysis of meteorites. So she is going to talk to us and also tell us how one can do this work. Madam, we have students from school standard 9th onwards, and they are eager to know how they can participate in our meteor observations. So, with few words, ma'am, thank you so much for your kind patience and bearing with us for our other problems. Thank you so much. And can we start now?
Yeah, sure. So thank you, Bharatji. And it's always a pleasure to give a talk at Nehru Planetarium. And
Okay.
I hope that I can make kids at least excited about the kind of work we do. And they're welcome to visit PRL. We can arrange this for students if they come in groups.
Yeah.
So we can do that sometime.
Mm-hmm.
So I'm sure you're showing them meteoroids and they know what meteoroids is. So what we have been doing with meteoroids is to understand the evolution of solar system as we see as of today. I don't know how much everyone knows, but in general, there's a widely accepted model of formation of solar system where a solar system is formed out of a molecular cloud. The composition of the molecular cloud depends on the different stars that are surrounding this molecular cloud. A core which is highly dense in this molecular cloud collapses to form the protosun and disk around it, which finally comes up as sun and planets. So, as you know, we have one sun, eight planets, billions of millions of asteroids, and Kuiper belt objects. That's comet. Yeah. So now, if you really want to understand solar system, the easiest would be to look for samples on Earth, right? But we don't use sample on Earth because there has been so much of churning and wind erosion, volcanic thing, differentiation. So there's so many churning that it's difficult to really know what happened when the solar system was forming. So we rely on something that is more pristine to understand how the solar system must have evolved. Now, if you look at the exploration part, there's so many components here. It's a Herculean task to imagine understanding each and every object that is there in solar system, right? So you have to make a choice of what kind of analysis you want to do. So in general, we get freebies like meteoroids that come to Earth from various regions of solar system. Most of them come from this asteroid belt region, which is between Mars and Jupiter. And this is like a frozen belt. It's like a fridge, yeah. So it has there are few of the primitive meteoroids which are kept as it is since the solar system started forming. So it's 4.56 billion years old. So I've kept something from 4.56 billion years old, and when it falls on Earth in meteorite, I have this material in my hand. Yeah? So I can travel back in time when I do analysis in lab with these kind of material. So not only from asteroid belt, we also get meteorite from Moon, Mars, and probable Mercury, which I am not sure, we are not sure as yet. But we have meteorites from everywhere. So we call it as poor man's space probe. Yeah? We get it for free. But what are other ways you can really understand solar system? You could do astronomical spectroscopic telescopic observations, or observations by planetary mission, where you have remote sensing techniques. You have a flyby going there, lander, rovers. So there is remote sensing techniques which can give us data of the surface or the atmosphere, and we can check it on Earth here. More observations or more enhancement in understanding of solar system comes from the experiments. So you need to have, there are certain payloads which carry mass spectrometers or lasers to analyze the sample itself. So it's called in situ analysis of the sample. For example, on Mars rover, there are mass spectrometers which can analyze and send us the sample. So there are planetary missions which have sample analysis, also on flybys, landers, rovers, and the best would be to bring back these samples. Yeah. So there are many missions where the samples are returned from uh, the planetary objects. So we do laboratory analysis of such samples, including meteorites. Now, what is the difference between meteorites and sample return? Sample returns, we know exactly from which location you are bringing. So there is a mineralogical context when you are analyzing such kind of samples. So you can relate very well whether it's from the pole region, whether it is from equator region, whether it's a drilled inside or on the just the surface. So you know the context, so it's easier to understand the system. Whereas meteorites, we don't know where exactly it comes from. Yeah, so it's, you have to relate it via different techniques. So, so far, people have been using certain samples. For example, there has been a comet sample return called Stardust mission. There has been asteroid sample return like Hayabusa 1, Hayabusa 2, and Osiris Rex. So, these are the asteroid name: Itokawa, Rigu, Binu. So Japanese mission and NASA missions to bring back the samples, and they have been analyzed. They are freebies like meteorites that fall on Earth and we collect and analyze on Earth. They are interplanetary dust particles that you catch in the space, in the stratospheric region, by balloon flights or high altitude aircrafts, and that you analyze in lab. These are part of, in general, comet or asteroids. They are very small samples. Yeah, and there are also micrometeorites that are collected from sea sediments or from or polar sediments. Yeah, so these are the samples that have been analyzed so far to understand solar system formation. um, Here, since we just have half an hour, what I want to make you feel when you when I finish the talk is, what were the important things that we have understood till date from meteorites as well as sample returns. So I would try to answer, give you some glimpse what was so new and exciting. Yeah. For example, there was a statement that moon is bone dry. There is no water, but with missions, different missions, we know that moon is not bone dry. There's water on moon, polar poles of moon. And there are rovers that say that there's water on Mars. Even with remote sensing, they have seen gullies which carry water, or which used to carry water, and see a slope there. Yeah. From meteorites, we have been able to say that the sun, which was forming 4.56 billion years ago, was very active. There were flares which are called super flares, million times brighter than flares that we see as of today. So from meteorite, we derived this. Yeah. Similarly, that the solar system is not simply forming of planets at certain places. There has been lot of churning going on in solar system, and the planets were migrating and coming back to the regions where we are coming. So these are some of the most important, most exciting results that have been that I feel are one of some of the important ones. Yeah. So we know that meteorites are classified into various forms. The easiest one to say is stony iron or iron. Yeah. So, for example, a primitive meteoroid is something that has not differentiated. When I say differentiated, means the silicate material and the metal material segregate. They like Earth. Earth has a core, metal core, and there is a silicate on the surface. It has been differentiated. So, not all material go through this differentiation. So, there is another classification between primitive meteoroid and differentiated meteoroid. So some of them are differentiated. So they'll have a core which is like iron rich and a mantle and a crust. So if these kind of asteroid break up, they give us iron meteoroids or mixed stony iron kind of a meteoroid. Whereas primitive meteoroid are only stony kind of. In fact, the crust of differentiated also is pretty primitive, but a little altered primitive. So there are various classification which I can't go into, but uh, if you read about meteorites, you will read different kinds of CV, CM, HL kind of meteorite. Yeah. So as I said, meteorite are called as poor man's space probe, and they can come from Mars, Moon, asteroid, and they can come. We have seen 1 gram to greater than 1,000 kilograms falling down on Earth and making craters. You have heard about craters this morning. So how do we analyze this? Yeah, meteorites. Actually, I have shown here two big instruments that PRL hosts. So I was trying to boast of PRL instruments basically. So these are mass spectrometers and very high-end mass spectrometers, which are in the whole of India. Only PRL hosts this. One is NanoSIMS, nanosecondary ion mass spectrometer. Other is novel gas mass spectrometer. So only PRL hosts this. And what is so special about these are they can analyze very small grains, and like we have fingerprints. Each human has fingerprints, and it differentiate one person to other. Meteoroids also can be differentiated by their fingerprints, which is isotopes. So I understand that all students understand what is isotope. For example, like we are breathing oxygen, yeah. So oxygen has three isotopes like 16, 17, 18. So there are three isotopes. So from chemistry, I can separate out the elements. Yeah, if I want to separate carbon, nitrogen, oxygen, magnesium, aluminum, by chemistry you can do it. But if I want to separate isotopes, you need a mass spectrometer, which has electric or magnetic field to separate out mass by charge. Yeah, so that's why we need this kind of a mass spectrometer where we can separate the isotopes, and the ratio of isotope is the fingerprint of these samples which I'm talking about, even the sample returns or this. This is not the only way mass spectrometer. There are also spectroscopic and microscopic observations that are necessary, and a multi-technique measurements give a more healthier or more enhanced way of understanding the samples. So, okay, I will quickly tell about this. Don't get very frightened by this plot. I just want to say that the whole solar system in isotopes, in heavy isotopes, for example, let's take titanium and chromium. These are isotopes of titanium and chromium. These are heavy titanium and chromium isotopes. You see two blocks, yeah, one is orange and one is blue. So the in some of the heavy elements, they are segregated. One is carbonaceous kind of, and one is non-carbonaceous. The orange one is non-carbonaceous. The blue one is carbonaceous. Yeah. So Earth, Moon, Mars all come in non-carbonaceous kind of material, whereas some of the primitive meteorites come in carbonaceous. All These are carbonaceous meteorites, very primitive meteorites. Yeah. So you can see the dichotomy of solar system. If you divide the solar system, it looks as if it is divided into two parts, which one is carbonaceous and non-carbonaceous. So this was found out by doing isotopic study in lab by Warren in 2011. Yeah. So how do you understand this? By migrate, somebody tried to make this easier to understand by migration theory. What do you mean by migration theory? This is long time back, 4.5 billion years back, when the solar system was forming. So it is said that when there is a disk, the proto Jupiter is first to form, followed by Saturn. Now this Jupiter is forming somewhere around 5 AU and then moving inside towards the sun, because sun's gravitational pull is so high, so it tries to move inside. And this proto Jupiter is big makes is big enough to separate the non-carbonaceous, the orange part, with the carbonaceous part, which is the blue part. So you can see there is a dichotomy. And when this Jupiter is moving, it came around near to the sun, around where Earth is right now, yeah, around 1.5 solar mass. And then the Saturn resonance pulled it back to the region where Jupiter is as of today. So this is called migration theory of Jupiter, which tries to explain a dichotomy, as well as there is a mixing in the asteroid belt, which gives both carbonaceous and non-carbonaceous kind of asteroids in the asteroidal belt. So it explains that when Jupiter was going back, there is a jump of material from the outer region to inner region, and this asteroid belt is a mixture of both, whereas the earth mass is still non-chondritic part. Yeah. So now, if with these two things, dichotomy and migration theory, let's go ahead and understand some of the results from the sample returns. So first I would like to tell you about a comet sample return. So there was a comet sample return from Will 2. This is a Will 2 comet, from which it didn't touch it. It just went very close to the comet and brought back the sample in a aerogel kind of a piece. Aerogel is something like this blue bricks you see here. So this is like a tennis racket with blue aerogel stuff, which is basically silica and air, and there's an aluminum grid around it. So this tennis racket opened when it went very near to the comet, and there were particles from the tail which basically impacted this aerogel and the aluminum foil. So you can see it is being opened when it came back in 2006, and I was in the PE team of for analyzing this. So we had aluminum foils on this. You can see that impact, yeah, like impact crater, but the size you see is around less than 1 micron, yeah. So there is an impact crater, but it's less than a micron, yeah, or micron. And in the silica, you see it makes a track, and at the end of the track, you will see a terminal particle, and at the end, the grains are shown. So what we did was to remove these particles from that, analyze it in nanosims, and look at these for what? For what I was talking about, for the carbonaceous material. Because as we know of solar system, we know that comets are from the Kuiper belt object. It's very, very far off. So it is very carbonaceous kind of a material. So it should have very carbonaceous kind of a material, nothing from the interior material. With that thought, we started analyzing, and surprisingly, for first few months, we really didn't find any very primitive kind of, we were thinking about stellar grains, that we should say, which is called pre-solar grain, which we found was very small, one particle we found, and that too we couldn't analyze for a long time because it was very small. So the idea that all pristine things should be seen in this comet was not true. And uh, and the and in fact, the material that we saw was more like material that we see in not non-carbonaceous but primitive meteorite, more like which is forming near to the sun. It's called calcium aluminum inclusion. So the particle was more like calcium aluminum inclusions that you see in meteorites, and not the outer region material. So what does this say? So what did you understand from this sample return was there is a huge mixing between interior part and the exterior part of solar system. So it says that the material very near to the sun is being thrown away. So there is a model called X-wind model, and which says that there is a X-wind which is very forms very near to the sun, and then it throws the material outside. Anything that is not anything, but few percentage of the material forming very close to the sun are also thrown away to the parts as far as 40 AU. So it is throwing 40 AU, 50 AU, it is throwing that far. So it says the dynamics of the forming solar system. So another one which I want to take up is sample return mission Hayabusa 1, which we worked at PRL. So this mission came back in 2010, and we had a few grains from this. You see spots here, oxygen spots. Nanosim spots are very small than this. I mean, 1/10 of this. Yeah, what we analyze the spot you see. So we analyze this for something. So you see here, the green spot on the grain is what we made from nanosecondary ion mass spectrometer. And what does the analysis say? Don't get confused by the plot. I will just say what it states. Yeah, it states that it doesn't have 26 aluminum. So look at what I have written down here. It says that it is 16O poor environment. It seems to be a reducing environment. 26 aluminum is low, and neutron isotopes are very depleted. So which means that it is from the non-carbonaceous region. So what we are stating is that the this asteroid, Itokawa asteroid, belongs to a non-carbonaceous material of the asteroid group. Yeah, so very near to Martian region. I mean, towards the Martian part is where the Itokawa belongs to. So you can analyze samples such as such. Another one which we are analyzing is Hayabusa 2 grains. These Hayabusa 2 grains are different from Itokawa because this is a carbonaceous contract. We already know that Hayabusa 2 mission went to a carbonaceous kind of very primitive asteroid, yeah, and brought back the samples. So what we are doing here is looking for basically pre-solar grains and organics. So how does the organic look like? Not really like this, but these globules are a part of organics. It's called nanoglobules. Yeah. So they look like a lipid kind of a structure, and people have always wondered whether these are a part of biogenic material that has created life on Earth. Maybe the asteroid with such kind of material hit the Earth and the life originated. So this has been a big question. So we also started doing organics on meteoroid body as well as sample returns. So there are many questions whether this is terrestrial or where does it come from. So there are many questions which probably I won't be able to explain you here. But what I can do is I can tell you that when you do analysis in nanosims, you can see hotspots like this. Can you see the red region in all blue part? Yeah, this says that this is highly enriched in nitrogen, 15 nitrogen. Now you have to explain how 15 nitrogen enriched particle can be material can be there, or it is heavily enriched in deuterium somewhere. Yeah, here it's D by H ratio is not given. It's just nitrogen, 15 nitrogen. So globules like this are very enriched in 15 nitrogen. So there are lots of examples that we have done on nanosims in PRL also, and there is a debate that why in 13 carbon there is very less anomaly, but in 15 nitrogen you'll see it's a great anomaly. Yeah, from 0 to 1000 per mil. Per mil is 1 upon 1000, like percentage is 1 upon 100, per mil is 1 upon 1000. Yeah, so there is heavy enrichment in 15 nitrogen. How do you explain this? Yeah, so to explain this, well, Well, I'll just explain in words. To explain this, people say that there is ion molecule exchange reactions that are going on in the outer region of solar system. So 15 can be enriched when there is ion molecule exchange. So which means that the asteroid belt which we are talking about, like Rigu or meteoroid which we are talking about, which has these kind of globules, have material from outer regions of solar system. So when first time I was saying that inner material goes out with the X-wind, now I am saying the outer region material which is enriched in water, volatiles, organics is coming from the outer region to the asteroidal belt region. So certain meteoroids are enriched in these kind of material also. So when you design a problem, you basically decide which kind of material you want to analyze. Now here I show that a big meteoroid parent body can be broken down into small bodies by an impactor, and which can again coagulate into a pile kind of a situation. And then once this is impacted, you will see that cloned object you will see on the earth. So what we have done is we have also talked about this kind of formation of parent body for the meteorites that we have found, and we have tried to talk about Rigu sample. So this is one of the good work that has been accepted in one of the papers recently. And with this, I would like to take some questions, and thank you. So, Bharatji, I'm ready to take questions. Yeah. Hello.
Thank you, ma'am. Can we put up your topic for questions?
Yeah, sure.
Yeah, we have. Yeah, there is one gentleman here, Mr. Chavan. He has a question for you.
Mm-hmm.
Yes, Chavan, carry on.
Uh, Thank you, ma'am, for great presentation. My question is, what about the solar nebula in your hello?
So, what do you want to know about the solar nebula?
It means how do we know that? How do chemical history we understand about the solar nebula related to that?
Okay, so let me tell you again what we mean by solar nebula. Yeah. So now, basically, the protoplanetary disk and sun is the solar nebula that you talk about. So if you want to know what exactly is the composition, that is what you're asking, the composition of the solar nebula, or the chemistry and physical changes that are taking place with time. What do you want to know?
Physical change related to the
So what happens is, if you look at chronological times, yeah, for example, yeah. So let's start from very basic, that there's a core which collapses with the protosun at the center and disk around this. So this disk is basically solar nebula, which is surrounding the sun. At time t is equal to 0, this is dust to gas ratio. Yeah. Now the dust which is there, the composition of the dust or the gas is decided by the composition of the core, which is decided by the stellar sources that are surrounding it. For example, sun is not creating iron or calcium or anything, but in your body you see iron or calcium or phosphorus. Sun is only having sun is basically hydrogen and helium ball. So how iron and calcium are coming into the system is from the outside source. It is basically a stardust. Yeah. So we are, if you say, we really are stardust. Yeah. So this material is stardust material, the iron, calcium that you have in your body. So what happens is this dust start coagulating with time. Sticking parameter hota hai. So they stick to each other. Once they start sticking, the it's called protoplanets. Yeah. So with time, around you go to 30,000 or some years, it will start creating ball kind of a structure. Now this ball will attain mass such that Now gravitationally it will start pulling things. ठीक है, तो इनिशियली इट्स ऑल प्रिमिटिव, कुछ चेंज नहीं हो रहा है, जिससे स्टार्ट हुआ था वैसे ही रहेगा, बट इवेंचुअली इफ देयर इज हीटिंग, व्हेन यू हैव अ इम्पैक्ट, हीटिंग हो गया, if there is water it starts melting, so thermally and hydrous, aqueous, there is alteration taking place. So it takes place in the body itself. It's called hydrothermal event. So hydrothermal event starts happening in the body itself. Then the mineral and chemical changes start. So now what is happening? The material which is refractory, refractory का मतलब क्या है कि melting point बहुत या condensing point बहुत high है, तो that material will form first. For example मैंने बोला calcium और aluminum सबसे पहले बन जाता है, तो कैल्शियम एल्यूमिनियम सॉलिड बन गया, तो सॉलिड में कैल्शियम एल्यूमिनियम चला गया, तो गैस में कैल्शियम एल्यूमिनियम कम हो गया। नेक्स्ट मटेरियल जो भी बनेगा उसमें वोलेटाइल ज्यादा होगा, क्योंकि वोलेटाइल कंडेंस नहीं होता है, कैल्शियम एल्यूमिनियम आयन ये सब कंडेंस या मटेरियल बन गया, तो नेक्स्ट मटेरियल जो भी बनेगा वो मोर मतलब सेकेंडरी मटेरियल ज्यादा बनेगा, लाइक आई डोंट नो इफ यू आर फ्रॉम जियोलॉजिकल बैकग्राउंड, अनिल चौहान ना, या सो द इट विल बी मोर लाइक सेकेंडरी मटेरियल, जैसे सोडालाइट वेडालाइट या ऐसा कुछ मटेरियल बनना चाहिए इवेंचुअली, तो सेकेंडरी मिनरल्स बनेंगे, पहले प्राइमरी मिनरल्स का ऑब्जेक्ट बनेगा, एंड दैट विल कीप चेंजिंग विद टाइम। Did I answer your question, Anil?
Yes, yes, ma'am.
Yeah.
Yeah.
Anil, I can't hear you. Huh.
Yes, thank you, ma'am.
Uh, is there any questions by the young boys here? No? Yeah, ma'am, it was a wonderful talk. Yes, we would like to have you more on this topic in near future. This year we missed you for our program here. Hopefully next year we
I
look
promise
forward
you.
we look forward for you to be our guest, to
Yeah,
meet
sure.
our students who are keen and who are here with us to see the exhibition which we have put for meteorites. And then they are there since morning. They are here for the lectures too. And they have not even left the table for anything. They are just listening to your talks. So
Yeah.
once again, I would like to thank you on behalf of Nehru Science Center and Akash Ganga for giving us this opportunity to have your talk for this afternoon. Thank you,
Yes.
ma'am, and
Thank you,
thank you so
Bharatji.
much.
Yeah, thanks. Bye.
Uh, we have a next speaker here is Professor Shajin Kumar. Hello, sir.
Hi, sir.
Uh, it's nice to see you back.
Yeah.
And here we have a fairly informal crowd. We have school children here, and we have also participants who are interested in asteroids. And as I going to introduce you to this program, I would like to say a few words about you. I have known Professor Sajin Kumar for a simple reason. We belong to the same class of people who have been to Luna. We visited Luna in 2015 and 16 to look for samples there. Unfortunately, most of the samples were stolen away. Hence, we had another program in 2016 and we again went to Luna. In the first place, when we went to Luna, we had a very nice opportunity of watching Venus transit over the sun. So that was the occasion we had along with our Luna observations. And let me tell you why Luna. In fact, I have to introduce you to the professor first because he is the person who is going to talk to us, and why my association with Professor Sajin Kumar is primarily because both of our topics are the same. Luna is our topic also, and we are studying Luna under what we call it as neutron activation analysis. We have done some of it, But again, we had not been very clear on the topics of iridium radiation, iridium and the platinum group elements, wherein he has been able to get the elements and he has published his papers in scientific journals, and he is one of the leading uh, persons who has been visiting all the craters around the country. Am I right, sir?
Yeah, yeah.
He has been to Lonar, he has been to Ramgarh, if I am not mistaken. Yeah, he has visited most craters. So I have a great regard for him. And he has been trained not only in India, he has been trained in Michigan. And his contribution to this subject is truly, really enchanting. He has been training students how to do asteroid hunt. In fact, we were going to have this program in Trivandrum. Fortunately, Nehru Science Center said, no, you have to have it here. So probably we are looking forward to having an International Asteroid Day from your center, sir. And another thing that I would like to add, please understand this part of it. He loves to have students with him. So any field work, I would request all the young people here who are sitting with me, sir, they are from schools. The boy next to me who is sitting, he has already seen a meteorite fall in his hometown. That is in Maharashtra, Bid. There was one meteor which fell. He talked about this morning, and uh, we are using schoolboys to come into this field. So our objective is not just to do this, you should give them some tips how to observe. Another thing that I would like to share with you is we had been to a place called Matanumad, which is on way to Luna. Not really on way, but yeah, there is a place called Matanumad. There you find Minamites. And Minamites are very common in that region, in Matanumad. And they are supposed to be from Mars. So our objective was to look for Minamites and also to look for Luna samples. So with these few words, I welcome Professor Sajin Kumar to open his session. Thank you, Sajan Kumar. Thank you very much.
Yeah, thank you very much, sir, for giving an elaborate description. But in fact, after hearing Kuljit ma'am's talk, immediately I shuffled all my slides. My initial slides were mostly concentrating on Luna crater. Now I have shuffled everything else because after seeing the school students, I thought rather than giving an in-depth talk about Luna structure, it will be better to talk in a holistic way about the meteoritic impact craters. But even though I didn't change the title, but I have kept a few slides for Lunar Crater also. Yeah, with a happy note, I can say that Barringer Award, Family Fund for Meteoritic Impact Craters, is an important or a prestigious award which is given to a few students worldwide. Probably they may receive some 500 application, 2 to 5 awards will be given. And with a proud and with a little bit arrogance, I can say that only 3 students from India received this Barringer Award for 3 years. And all the 3 are from my department, and all the 3 are from my own students. So the thing is that the planetary science in my department is a new one. We have ventured to the planetary science after ISR launched the Mars Orbiter mission, where I was invited to study the landslides on Mars because my specialization is on the landslides. That is how, when ventured into the landslides on Mars, I could see that it is a virgin area. You can send the students to this topic or take students for this topic because it has immense potentiality. That's what advice I can give to the school students there. Planetary science is a virgin science. There is a lot many things to be unraveled. And more than that, it gives immense curiosity, immense adventurous nature, because there is nothing else to check. All the things what you are finding are new things, all the things. So always a novelty and adventure nature is there. So with this introduction, I invite all the students to the world of planetary science. Yeah. So you all know asteroid collisions. Asteroid collisions finally results in a depression or a crater. We call it as impact crater. This is one of the well-studied impact crater on Earth called the Barringer crater. I have visited this crater, and actually based with the Barringer is a person who have studied much of this one. That's why the award is also called Barringer Family Fund for Meteoritic Impact Research. But the interesting thing is that it is a request as well as a notice to all of you. If you want to go to this Barringer, you can go as a tourist. Even if you're a geologist or astrologist, astronomist, whatever it may be, you will not be permitted to enter into the crater because you need special permission. But there is another crater in India which is well studied, at Lunar crater. But unfortunately, it is in a very pathetic situation. Actually, the forest department have taken care of that crater, and they have made it into a reserve forest, and they have put some tigers. They call it as wildlife sanctuary. Now you cannot enter freely into that crater, and the crater has become densely vegetated, and all the impact features has been obliterated by the high vegetation. You see, you can create a forest anywhere in the world, but you cannot create an impact crater anywhere in the world. It is purely a natural beauty. But unfortunately, the Lunar crater has gone all it's this one. I do not know how to counter these things, go against the forest department and make the Lunar crater a virgin crater. It is out of my hands, but I'm planning to write a popular article on how to preserve this Lunar. We have so many geological organizations, planetary organizations, but I do not know why they have neglected this Lunar and given all the things to the forest department. It is very difficult. Last month, I have fly a unmanned aerial vehicle. There is a drone. I have run from nook and corner to get permission. Now I want to take a bathymetry of that lake. I do not know. For 6 months, I am running behind. I didn't get the permission to do a bathymetry of that lake because no one has done the bathymetry of that Lunar crater. Yeah, fine. Coming back to this one. So the ultimate thing about an asteroid collision is a crater, and this cratering event was more prolific when the Earth was in a baby time. This is how the Earth looked like when it was born, something else about 4.56 billion years ago. The surface temperature of the Earth during that time is estimated, or model temperature is something else about 2,700 degrees Celsius. So during that time, in 2,700 degrees Celsius, only two processes were operating. Two processes in the sense, two geological processes. One is volcanism, and the second is meteoritic impact. The Earth was continuously bombarded by meteorite. But there was a particular specific time when the meteoritic impact on the Earth was more. That area, the time is called the heavy bombardment. It is spanned between 4.1 to 3.8 billion years. So continuously the Earth was bombarded. So the Earth, or not only Earth, all the planetary bodies, all the rocky planetary bodies. So the output was a planet like this. You know, this is Moon. Moon, all the impact craters are most pristinely preserved. So this was the case with Earth also, but the geological active nature of the Earth has modified the Earth into such a beautiful planet. Otherwise, there are a few other planets like Earth was like this one, because this is Io, a satellite of Jupiter. You can see the red spots. These are volcanism. So this is an active planet or active satellite. So you are not getting any what's in the circular feature which you are seeing on Moon. So this also has obliterated or vanished or eradicated all the craters. Otherwise, Earth also should have been looked like this one. And this impact crater looks, when it immediately hit the surface, you can see that it looks like a red one. In fact, all the materials inside the Earth has been spanned for a longer distance depending upon the diameter of the meteorite, diameter of the crater formation, the spallation increases. You can see the fresh colored, the things, the blue colored, etc., because that is the innermost thing from the Earth came out. You can demonstrate in your home itself. Put 3 or 4 layers of different flour, rice flour, wheat flour, maida, or ragi, something else, different flour in it. This one, and take a bouncing ball. You can just throw it. You can see that up to what depth it penetrated. So imagine the ragi is the third one and rice is the first one. You can see that the ragi material coming out and the spallation you can see beautifully. So how much deep it goes, how much deeper the rocks inside will come out. And you see this meteoritic impact crater not only fascinated the scientists, but there are so many Hollywood hits that also fascinated the entire population. This is a movie called Armageddon and Deep Impact and Meteor Apocalypse. So meteoritic impact is fantastic. You can attract anyone. So it is an interesting field of research. Okay, so what are the type of meteoritic impact craters? There are 4 types of meteoritic impact craters. One is simple. Simple is then only bowl-shaped depression will be there. No other manifestation you can see inside the crater. And next is complex. That is bigger in diameter. It has a central, in the center, there will be hill-like thing, which is called a central elevated area, central uplift. And these are the 2 types of craters you see on the Earth. The other 2 types we seldom see on there. Sometimes people say that the 3rd type of crater called a peak ring crater is that is instead of a central uplift, there are rings around concentric rings. A Chicxulub crater, which has resulted in the extinction of dinosaurs, could be a peak ring crater. And finally, multi-ring, thousands of kilometers diameter. All the things should have been there on Earth, but the active erosional process, plate tectonism, all the steps have removed these things. So the only simple, younger craters are well preserved on the Earth. Okay. And this is the biggest meteoritic impact crater on the Earth, the Breda Fort in South Africa. It is much bigger, something else about 200 kilometers in diameter. Much bigger. You can see only the relict features, not the real rim, etc. You cannot see because it's formed much older in the Precambrian time. And this is the biggest one in the solar system, the south pole of Moon, called Aitken Basin. And this is another interesting thing for the school students. Others may be knowing this one. This is the asteroid Vesta. The asteroid, 90% of the surface of the Vesta is an impact crater. And because of that impact, the central uplift have came. And this central uplift is the tallest or the highest peak in the solar system. So meteoritic impact crater can create a big, gigantic morphological feature that is the tallest or the biggest in the solar system. This peak is called Rhea Silvia. We are working on this Rhea Silvia now, how to beautifully map this Rhea Silvia and bring out what are the famous important geomorphic features in this Rhea Silvia. That is one of my ongoing projects. Yeah, if I am saying about this biggest, what would be the smallest? I think Kuljit ma'am have talked about the cosmic test or meteoritic test. You see 60 tons, that is almost 6 trucks of materials will come to Earth every day because, you see asteroids moving on the Earth or meteorites moving on the atmosphere that will get burned and the ashes will come down. So the best place to see this cosmic dust is you can take a glaciated region, you can take a bucket of snow or ice, get it melted in the lab, filter it, the residue what you obtain is cosmic dust. And the virgin area is Antarctica because there is no transcontinental smoke transport so that the soot and the ash particles from any burning from any continents will reach there. Arctic, it will be a problem because Arctic already, the fire, the Canadian fire, the ash has been already reported in Arctic region. So Antarctic is a virgin area. Even Himalaya also, you can try some glacier. And this is the Rhea Silvia. This is the biggest meteoritic impact crater on the Earth. The Rhea Silvia. This is the biggest meteoritic impact crater on the Earth. The Rhea Silvia is 90% of the surface of the Vesta is an impact crater. And this central uplift, that is the tallest or the highest peak in the solar system. So meteoritic impact crater can create a big, gigantic morphological feature that is one of my ongoing projects. Yeah, if I am saying about this biggest, what would be the smallest? I think Kuljit ma'am have talked about So otherwise, as a crater, it is a 15-meter crater is there, but there are rain print type or rain drop type craters are there, which are secondary craters. Secondary craters are formed when small particles from an impact then falls down on this one. Yeah, this is the one. And why we are studying meteorite impact craters? You might have been hearing this one in the morning itself, but a broad brush I can give you. You see, planets, all the planets, including Earth, is a collage of asteroids. Several asteroids combined together from planets. So it will help you to identify how the formation of planets or how the early asteroid has converted or changed into the present day planets. And if you get a piece of meteorite, you will getting the primitive composition of the solar system. So origin of moon itself is formed by a huge meteoritic impact. Moon was not formed when Earth was formed. It came a little bit later when a big asteroid called Theia hit on our Earth and took a part of the Earth and that meteorite to form Moon. Satellite of Mars, Deimos and Phobos are not really the moon of this one. Those are the captured asteroids from the asteroid belt. Initiation of plate tectonics. This is not purely confirmed, but how the Earth initiated plate tectonics, because the rigid, the top crust should get tessellated. Then only the tessellated blocks can move. How that it got tessellated? A few studies says that it is the impact which it drives the force for the upper crust to get tessellated and start moving. And opposite revolution of Venus. Venus has an opposite revolution. These are hypotheses put forward, but we have to check it. And scientists say that at one point of time, the Venus becomes stagnant, still for 1 second. Then it started revolving. And origin of hydrosphere, because in our school, always the wrong thing which is taught to us is water cycle is a closed cycle. No, water cycle is an open cycle. Water cycle is not at all a closed cycle, because we gain water from several processes. Even several comets supply water. This one, our water in the outer atmosphere diffuses through the outer space. Even plate tectonics takes a huge amount of water. That is what you see on Mars. The Mars plate tectonics have taken the Martian ocean deep inside the Mars. So hydrosphere, the first water was brought to the Earth by comets. That is one theory says. Then mineral deposits, a plentiful of mineral deposits. I can say that the Siberian crater, it's in my mind. The impact happened in a marshy terrain, and that marshy, it is cold. It is converted into micro diamonds. And there are several craters which host, Sudbury crater. Sudbury is one of the biggest copper deposit in the world, and there are so many. Even Chicxulub have oil deposits. So it is a potential trap, a structure to get mineral deposits. And you can date the planetary bodies' terrains because Martian terrain, moon terrain are dated on the basis of meteoritic impact craters. There is no other dating techniques to date Mars and moon. And other is origin of life. There is a theory called a theory of panspermia, where they think that scientists believe that life on Earth is not originated on Earth, but that is instead border seeds from outer space. And that is not proved so far, and it cannot be also proved, but there is a theory. And the second is mass extinction. So it has two n numbers, and that's why I have given in red. One, origin of life, and other mass extinction. You know about the mass extinction because even the dinosaurs undergone mass extinction because of an meteoritic impact. So saying about the terrestrial meteoritic impact craters, there were 210 meteoritic impact craters confirmed on Earth. And the last one to be confirmed, I'm not saying that Luna is a confirmed crater, though I often says that it's a confirmed crater, but it's not a confirmed crater. With Luna, the number stands at 211. And you can see how much number of craters there are on North America, Europe, and Australia. There is sparsely in Africa, sparse in South America and Asia. What could be the reason? Any students can answer? I'll be happy to hear your answer. Why impact craters are more in North America, Europe, and Australia? Yeah, I am not waiting for your answer because you see, those are developed countries, they invest a huge amount of money for research. We even say that India is a proud country, we have, no, India is a very poor country. We spend a little amount for research. You don't have that much money spent for research. If you want to get a research project, you have to fight with your nail and teeth, then only you'll get a project. So we are poor countries. We never spend money on research. And that's why the country which have invested much of their amount has discovered so many impact craters. So in India, so far, 4 confirmed impact craters and 3 unconfirmed impact craters are there. And I can say that Luna, till now, it is not a confirmed crater. We have to come up with more evidence. Now I'll be coming to Luna now with this brief introduction about, I call it as Luna structure because it is not confirmed as a crater. Structure which is confirmed can be called as a crater. Structure can be anything else. A physical appearance of anything else can be a structure. So I call it as a Luna structure. Okay. So it is rumored as an impact crater for about decades. I think 2006 is the first year in which the first paper appeared in Current Science. That is what prompted me to go to that crater. And all the impact craters in India has been visited by me. And Lunar was my last target because I'm not interested in Lunar because it is already studied. I first ventured into Dala, second to Ramgarh, and third is Luna. And Luna, I got the sample in 2015 itself, a few samples. But I am not convinced with this one because I have checked only the trace elements where nickel is not there. So that could be one of the reasons that several scientists neglected the samples. Because in 2006 paper itself, I have heard that the melt rock samples are with the IIT Bombay where they are doing detailed study. I think they might have checked only the trace elements and they could see that nickel is not there. So there is a misconception we always have. All the meteorites have high nickel. Yes, of course, most of the meteorites have high nickel, but it's not compulsory. There are a few sect of meteorites, especially iron meteorites, which do not have nickel. That could be one of the lucky part for me. I didn't wait for the trace elements. Because during that time, I got a collaborative project with the University of New Brunswick. They are one of the famous impact crater specialists. John Graham Spray visited along with me. I have given him option of 4 impact craters to visit. He also told that you see that the other 3 are already worked. The Luna is the only area where no work has been done so far. So I have took him to there, and after seeing all the things, he was also convinced, and that is how the Luna came. But I was very much damn sure that all the craters, the other 3, Luna, Ramgarh, Dala, all were identified or confirmed or discovered by foreigners. So I intentionally kept that Luna structure. A lunar crater should be indigenously, or only the Indian should confirm or prove it. That's why my first paper on lunar structure came with only the Indian people, no foreigners. So we can also be proud only if it is confirmed through more studies, like Bharat sir have told that he is doing a few studies on the samples. And this is something that's about 1.2, 1.8 kilometer, this one. And you can see a lot of melt rocks strewn across this one. Not every area, a particular area, we are trying to model it, but we stopped modeling because a few other studies in which Curtin University, etc., they analyzed a few of the samples and they told that they are not getting that much good features. So we stopped it. We have given it for an isotopic study, ruthenium isotope study with Max Planck Institute, Germany. We are waiting for the result. If we are getting a positive result, that will be the final conclusion that we can say that it is an impact crater. Till that time, I will call Luna as an unconfirmed impact crater. So what are the features which help you to identify a meteorite impact crater? You should have a circular morphology. It should have an inverted topography. I have told about rice floor, wheat floor, and ragi floor. When you put a bouncing ball, the ragi will come outside. That means the oldest one. in geology, the oldest one lies inside. The oldest one, rocky, comes outside, means the oldest now lay over the youngest, which is impossible in normal terms. If you get it, that itself is an indication that it is an inverted topography. So you'll get an inverted topography. You will get ejecta material strewn around it. You will have shatter cones. You can have shock metamorphism. Shock metamorphism, the host rock where the meteor hit is subjected to high pressure and temperature. So the minerals can get changed to its polymorphs, or a few structures, a few textures can develop in this rock. So those are called the shock metamorphism. You can have the entire rock melted. So those are called melt rocks. You can have anomaly. Anomaly in the sense means you can put some geophysical instrument. It gives the pictures inside there. The outside earth will be very normal condition, but the inside earth, it gives you a circular pattern. It can be any type of geophysical survey. And finally, if you are getting a meteoritic remedy, yeah, fine, you are reached the target. So these are the things. Let me see what are the things I have identified in Luna. Yeah, circular morphology, I got it. Very good circular morphology, you can see. And there is a deep depression. Even you can see that there is another rim here. Actually, we have done a drone survey. This is the crater diameter, what we are mentioning, but our drone survey and the more geomorphological things are restricting me. The crater should be this one, the small one, 0.8 kilometer, 0.8. So it should be a much smaller crater. If 0.8, that will match with the age pattern, because it is generally believed that bigger craters are older age and the younger craters are smaller in size. So if it is 0.8, that would be a good one. So there is also, you can see the circularity here. And next is, you can see this is a drone image. You can see the circularity of the water in the inner part. And the second is the inverted topography. I'm not sure whether it is someone have transported it. It is a sandstone. It is a Jurassic sandstone, which lies beneath the Bandari sediments of Luna. We got it not only. So if you say that it is bought here for construction something else, but we got this one in association with the melt rocks. That's why we got it confused. It is not proved. It is proved that it is Jurassic sandstone, but until and unless a drill hole is done on the lunar crater, reaching up to, I have made some 25 trenches using JCB, but this is something else, 200-meter thick silt deposit, so you cannot. And about the third thing is that shock metamorphism, I could see minute or feeble planar fractures in a few quartz grains. Quartz grains are common in the host sediment, that is the Bandari sediments. So I could see a few planar fractures, not a well-developed planar fracture or planar deformation features, no. The third one is melt rock. Voluminous, I got voluminous melt rock. I know which is the place where we get the melt rock. So we got the melt rock. And other than these things, we didn't got. But other important things is that apart from the this one, we got a few minerals, woostite and crystallinite. Unfortunately, these woostite and crystallinite are present in meteorite as well as in flags. So this is contradictory, but we got woostite and crystallinite. And the biggest thing is that the high PG concentration that we got from this. We did two analyses, one at NGRI, that is the one which we have used to publish it. But later on, when we got negative results, other not the PG, some other results negative, we redone it at NSS National Center for Science Studies, where there also we are getting what is a high concentration PG. So this is the only robust evidence which prompted us to say Luna as a meteoritic impact crater. And this one, the dating exactly coincides with 4,000 years. That is just 2000 BC. That is the time where there is a migration of Indus Valley civilization. This is how the woostite and crystallinite. Woostite is an oxide phase, and crystalline is an olivine, which is a silicate phase, which is quite common, a mixture you see in both slags as well as meteorite. That is the other thing. And these are the two important features which we require. These, if anyone, both of these are present, we can surely confirm that Luna is an impact. But you all know that Luna there is only a small window available for you to go to Luna, May 15th to June 7th or something else. So this year I couldn't go there because I was having so many other field work. So otherwise every year I used to go there. And if anyone get it, then it would be good. You can confirm it. And this is how our articles have came, origins of an ending. And there are so many newspaper articles came on this one. Yeah, you know, meteoritic impact craters created fascination among all sect of people. You know how many Jurassic Park movies have came, and you see if Jurassic Park, if impact crater or chick slip, or if dinosaur didn't undergone extinction, then we all should have looked like this one. Small and big dinosaurs. There should not have been a human, but we all should have been a dinosaur. I be a dinosaur, you all be a dinosaur. So yeah, that's one small step for man, one giant leap for mankind. Thank you very much. Any doubt, I'm happy to address you. Yeah, actually, if you see the worldwide, if it is 2 kilometer diameter crater, its size will be something else about 100 meter diameter meteorite. So if it is less, the smaller crater size which I have mentioned, then it should have much smaller crater. So you know that waves get attenuates after 5 kilometers. So anything else within 5 kilometers or more, anything else within 2 kilometers of circumferences, the humans might have affected. But it is not the sole reason for the industrialization. It should have affected a local population there, or the people should have migrated to a different place.
Because there is one feeling in one of the text, mythological text or Mahabharata, there is a mention of Balarama doing his parikrama, going around Luna. That mention is there. So, are you aware of these facts?
I am aware of not this fact. This is not a fact. This is just
okay.
a saying.
No, it is said that this crater must have been formed much before the Mahabharata war. Is it true?
No, sir, I never correlated with this mythological or this thing. Science is science, that is different.
Okay. Yeah. No, because somewhere I have seen this, and many of the references which I have seen about Luna mentions about this particular crater. Luna, not as a Luna crater, but reference to crater in this particular Hajipir region. So this is where I thought we did our initial work on Luna, and this was one of the mentions about how that crater has happened there. And the other reason is that earlier that Luna crater was much deeper. So on that also we would like to have your input, sir.
Yeah, obviously, a Luna crater is now for almost, I do not know whether anyone has seen you, one of my paper which is published in 2022 in geomorphology, where we have created that are used drainages as proxy for identifying the denudation of craters. In that one, Luna being an youngest crater, it is highly denuded than what you see in Lunar. The reason is that this is an active depositional area. the Indus silt and soil all get deposited in this one. So the depression has been considerably reduced. You can see just a thin rim. You cannot see any depression as such. Whatever the small depression you have, it is filled with water. Damn sure after 20 or 30 years, that also get filled. So what the best thing you can do is that now itself start a drill, get a good core, and then you will be able to get more evidences, convincing evidences about this.
Yeah, I would like to ask our young friends who are here with me. My young student friends are there, and who have whether they have any questions on this particular crater and the sir's talk. So if you have any questions, yeah.
Sir, you gave us three craters, which were the largest craters. You gave us images of three craters, which were the largest craters. So
Yeah.
I wanted to ask, means how large were they? Means could you please tell us the diameter of them?
Three. I have mentioned about on the Earth, on Moon. On Earth, it is something else about 220. Rudderford is something else about 220 kilometer diameter.
Yeah.
That is the biggest. And Aitken Basin, actually, that is the south pole of this one. That is nearby about 1,000 kilometers. Yeah.
Okay. Thanks.
Yeah. I'm not able to hear.
Hello. Yeah,
Yes.
I have one question
Yes.
here. Like you said that you have been often visiting the Luna site, and probably this year you not visited. But do you publish, or do you let everybody know, or the people who are interested maybe joining you for such kind of expedition in near future?
It is glad if someone is interested, they can shoot a mail to me. I will be happy to this one, because actually we are planning to start a center exclusively for training purpose with the funding from DSD. So what we are planning is that we are planning to invite a +2 students, not the lower school students, to visit this one and take them to their summer vacation after the +2 to some meteoritic impact craters. That is what my ultimate aim, actually. For that one, Indian Institute of Space Science Technology, as well as National Center for Earth Science Studies, has expressed their interest. That is my ultimate aim.
Sir, I have one question for you, sir.
Yeah.
Have we also got any remote sensing images of Luna? The images which you have published, are there any images from the Indian satellites about Luna?
Sir, you have opened a Pandora box, actually. We always proud to say that ISRO, etc. But the thing is, that important thing is that you don't have, you all people use remotely sensed data. Which one you use it? If you ask, everyone will say, I take SRM, I took Aster digital elevation model, or Landsat, or Sentinel. I seldom saw people saying that I use this one, ISRO satellite data, less, because you see, it is an freely you will get it. The website is handy to use it. You can download n number of times. There will not be any problem, server problem. If the server problem is there, they will inform you in advance. This time is the maintenance time. So Indian satellite has less this one, and more to that, I have the picture. What I have shown is of Tandem X. Tandem X is 12.5 meter resolution. And I have given them a proposal. They were very happy to give me all the Tandem X data of the entire craters on what is there. So I got. And apart from that, I flew a drone, and all the pictures and all the stuffs are ready with me. We have a RGB image. We have a LiDAR data. And since the manuscript is ready, but unfortunately, I didn't venture into a publication because it is against the ethics, because as a few results from outside university, our university said that it is not a crater. Then I thought that it is not good to publish it. So we are waiting for ruthenium isotope. If that comes in a positive way, we'll be publishing this drone footage, and the drone footage will be made available free to you all through a link. Yeah.
Any questions? If no questions, let us thank Professor Sajin Kumar for his wonderful talk. And I'm very happy and I will continue to seek your advice further on Luna. Thank you very much.
Yes.
So we now move to the next lecture, which is by Dr. Rudra Swami. Hi, Rudra Swami.
Yeah.
How are you?
Fine, good afternoon. Can you hear me?
Yeah. So
Can you
it's
hear-
very nice to see you.
Yeah.
Yeah. And let me tell you about Dr. Rudra Swami. He is working with National Institute of Oceanography in Goa. Another thing is he has visited Antarctica at least more than once. Is that right, sir?
Only once.
Okay. And he was there to find meteorites in Antarctica. So today's program, sir, we have young students from schools.
Can you see my screen?
Yeah, our screen.
Yeah.
We can see you, sir. The other reason is what kind of the meteorites that he has seen over there is micrometeorites. That means they are very small meteorites which has fallen in Antarctica, and he is a lucky one to have picked it up. So one of my personal interest with Professor Dr. Rudra Swami is that we are at Nehru Science Center, sir.
Yeah.
And we have an exhibition today on meteorites from all over the globe, including Kaveri. And then we have also one from Barringer crater. And we now look forward for your micrometeorites from Antarctica. With these few words, I would also like to say something very good about him. He is the best professor in isotope analysis. And the other thing which I have to tell you is he has been the senior scientist at NIO, and one of his best interest is looking for meteorites. So with these few words, sir, I look forward for your excellent talk.
First of all, let me thank Dr. Bharat for introducing me and inviting me also. After such a long time, I could join you online. So the title of the topic is extraterrestrial material on the Earth's surface. Can you see my slide, Dr. Bharat? Can you see my slide?
Yeah, we can see your slide, sir.
Okay. The extraterrestrial material, and when I say extraterrestrial material, it encompasses meteorites and also micrometeorites. So people are since morning are discussing about the meteorites and less about the micrometeorite. Meteorites, as it's very popular and it falls everywhere. It is largely found nowadays. A large collection was collected in Rajasthan. Also, recently falls in Maharashtra. And there are some reports of falling in Gujarat also. But micrometeorites falls daily. Every time it falls. On an average, on per square meter, there is one micrometeorite fall every day. That is the calculation. So micrometeorites are the small, tiny particles. Why they are called micrometeorites? Because they are in the size range of tens of microns to few hundred microns, which is invisible to the naked eye. You cannot see by the naked eyes. So you have to filter it and then undergo a microscopic observation. That is why it comes the terms called micrometeorite. They are smaller than the size of your hair size. Okay. And every year, tens of thousands to 50,000 tons of these micrometeorite falls, which is much larger compared to the meteorite falls. But I will try to briefly show you. Start with the why the study is important of both the nature, be it meteorite or micrometeorite. Both are extraterrestrial, means they are coming from the outside the Earth's surface. So our solar system was initially started with a huge cloud of gas and dust. That is what we define as a solar nebula. That's already many previous speakers also have discussed this. It was a cloud of wind and some gravitational collapse of this huge cloud of mass forms into a small sun, which is called as a protosun. surrounded by the cloud of gas and dust. This is the gas and cloud which is surrounding the protosun. That is called as solar nebula. In this solar nebula, there there rises some of the early solar system object. The first solar system object to form was the calcium aluminum inclusion, which earlier speakers have introduced. That is how we dated that sample and came to know what is the age of the solar system. When we say about 4.6 billion year our solar system is, that is because of the dating of the first solar system form, followed by the second object. So you see, over a period of less than tens of million years, our planets also started forming, but still there were some like Mercury, Venus, and all these planets formed, but there were some objects left over which did not go into the formation of planet. These are called as asteroidal material or Kuiper belt object. These did not go into the formation of the planet formation, and they survived the alteration process, which usually once it goes into the formation of big planet, they undergo alteration. But some of these have preserved their nature and characteristics so that one can study them to understand how our solar system evolved. Because this is the nearest nearest star which we can study to us. And knowing this, we can also explore how other stars are evolved. So if you see, the astronomers knew about all these earlier, starting from Jupiter, Saturn, comet, and now we know that there are 166 moons. One star is there, which is called as the sun, and there are 8 planets. Also, Pluto has been downgraded to some not exactly as a planet, and then asteroid, millions of asteroids are there, and then comets and dark planets and Kuiper belt object. This is how our solar system looks like nowadays. So if you see, there's solar asteroidal belt. When you say asteroidal belt, I would say millions of are roaming around this asteroidal belt, and there are millions roaming around the Kuiper belt, but they are not roaming in the very correct orbit as done by the planets like Earth, Mars object, but they undergo sometime bombardment. They collide with each other due to the change in the orbital path. During this collision, they generate huge amount of material. Some are bigger size and some are many are smaller size. There is a huge proportion of small particles which are dust size particles. They get released in this asteroidal belt and some enters the Earth atmosphere. Usually the smaller boulder size also enters the Earth atmosphere and ends up as a meteorite. This is how the meteorites and micrometeorites lands up in the Earth atmosphere. So if you look at the definition, how the rock falling from the sky looks like, these whatever the chunks of those collision takes place, the debris, they are termed as meteorite as long as they're in the outer space. And meteor, the visible path that enters into the atmosphere. Once they enter the atmosphere, there is an you can see the visible path due to the frictional heating. They undergo, and then there is a bright light that you can see, that they are called as meteor shower. Sometimes you can see meteor shower in the night. So a meteorite is also a meteorite that reaches the ground. Once it reaches the ground, this meteorite is defined as meteorite, and they survive the impact. So many times I think some have seen the meteor shower where a number of meteors are observed, and particularly that arise from the sky. So there are various methods you can choose how to identify the meteorite. Once you identify the stone, one such is high metal content, then terrestrial rock, and there are various other methods which I would not go into the details because already many speakers have already discussed these things. So you see that this is how the asteroidal belt looks like. There are millions roaming around, and many times they overlap each other, they collide each other, and the dust enters the Earth's surface, and these dust are collected by us people who want to study the extraterrestrial material, and you don't have to do some high-end missions for it. These are, you have to wait and they come to you. So many people who study on the early solar system evolution, they have some standard questions like what causes the collapse of the protosolar cloud, and where are there pre-solar grain hydrogenated from the protosolar cloud, and the time scale of this collapse happened, and the formation of the solar system objects, and the processes of the planet formation. These are some of the standard questions people are still working on and refining them till now. So if you look at a meteorite that survives the passage, it will have a meteoritic crust. It undergoes the heating. Due to heating, there is a fusion crust surrounding the primitive meteorite, and this looks like a black structure. That is how the meteorite forms. These are some of the examples of the meteor, how they look like. These are the outer black portion is the crust. This gives an indication that it is an extraterrestrial object, not a terrestrial one. So sometimes it is shining like this. There is a very rare examples of Martian meteorite and the moon sample. A primitive one looks like this. If you cut open the primitive one, it will look like this. It will have the first solar system object, which I told it formed in the solar nebula. The second solar system object is called as a Condus. Both have been dated. The dates are equivalent to the solar system formation of the solar system, that is 4.6 billion years. So some of these asteroids are contributing to these meteorites and the micrometeorites, and now we are living in a extraterrestrial dust infected environment. Means every time dust is falling on the Earth's surface. Some are very rarely you see the bigger size particles which can hold in the hand, but there are smaller sizes like a micrometeorites where even if it falls on your head, it will go unnoticed. So this is one of the several ton boulders, which is called as Hoba meteorite. It was discovered, they could not move it, so they made it to a museum in the very same place. So this is how the fireball looks. There is a video, I could not play it, but somehow the fireball moves, and that's you can see the how the meteorite moves and if it is night or in the day also it is visible. Like it took in Russia recently, many years back. So one of is called as Piskel meteorite. It this is a famous fireball. It was fell on one of the car. This is the rarest when somebody it has hit, and it has damaged this vehicle. So the lady who sold this car, the old car, for $10,000, and meteorite also gave her $75,000. This is how valuable the meteorite becomes once it damages the car. So the famous Tongsuka meteorite in Siberia has known for its widespread devastation because it was recorded in 1908, and the cause was known to be a meteorite. And of course, there were not many dead because Siberia is a slightly unpopulated area. Only 3 reported that was there during that time. So there are random finds. People go and finds them in deserts, and also pretty random finds of small chunks in the random and desert meteorites are nowadays becoming very famous. If you look at the collection wise from various areas, earlier people were only collecting in the land, so like Africa and desert Africa and other desert areas, but nowadays Antarctica collection has already gone up to 62%, and this is from the statistics of about 67,000 collection of micrometeorite. So there is a large group of Japanese and American and European groups which are working on Antarctica meteorite collection, not micrometeorite, meteorite collections, where they have reported around all this close to 67,000 of meteorite. Meteorite with Mukumbadapura, which is a famous because it was of carbonaceous in nature, CM chondrite, and Dr. Professor Bandari himself has given the sample to me when he picked up this sample, and this fell in 2017, and in initial investigation revealed that it was CM chondrite. So this was a very interesting meteorite which we studied. And if you look at the meteorite, it should they are differentiated. If it has differentiated, then it undergoes formation of iron meteorite if the contribution is from the core. And if it is a primitive meteorite which doesn't have undergone differentiated, then it's supposed to form a primitive meteorite such as carbonaceous chondrite, which has a composition similar to the protozoan. Like here, this small structure, if you get a sample from this, it is going to form definitely like a primitive meteorite. But if it gets from a core, we get a metallic iron meteorite or other chondrite type of meteorites. So how meteorites are formed? Sometimes they are found randomly. Sometimes people follow the trails once they look a fireball in the sky. Sometimes they put cameras all around to detect. But micro dust, if you say about the micrometeorites, there are high-flying aeroplanes. People, especially NASA, uses the high-flying aeroplane to collect the extraterrestrial dust in the space. We Antarctica and paleosols. Paleosols are the oldest soils found on the Earth's surface. So how frequent, how worldwide, if you look at the worldwide frequency of the meteorite, if it is a pea size, peanut size, it will be 10 per hour. If it is of the walnut size, it will be 1 per hour. And as the size goes on increases, so is the time gap between the falls goes on increases. So once in a century will be the 50 meter, and it will be slightly more devastating if the size goes on increases. So they are already the many speakers have discussed about the classification scheme like undifferentiated meteorites and differentiated meteorites. I will not go into the detail, just to emphasize that there are 3 types of undifferentiated meteorite: carbonaceous, ordinary, and asteroid. And of them, carbonaceous is the very rare fall. Many a time, or most of the common falls are belongs to this ordinary chondrite groups. So this is the first solar system object formed. When I say some of the age of the solar system, 4.6 billion years ago, this is based on the dating of the calcium aluminum refractory inclusions. And then there comes the condos. This is the second oldest object formed, which is slightly 2 million years younger than compared to this thing. And both these objects are the first solar system object formed. Based on this, the people have estimated what is the energy of the solar system, what goes into the formation of the sun, and how the planet has evolved, or the solar system has evolved over the time. So if you cut section of the condole, this is how the CI looks. And these are spherical objects which are called as condos. These are the first solar system object, and condos are considered to be the product of the solar nebula only. And they have recorded these timings and conditions of the formation during the early solar system evolution. So and most of these early solar system objects have short-lived radionuclides in them, because the sun was very active during that time. And based on that short-lived radionuclides, many people have dated them, and this is how the first solar system object formed after the protosun formation, 0.1 million years. The second solar system object formed within few million years, and then our planets formed within less than tens of million years. This is how our solar system has evolved over a period of time. So if you look at the foundation of the meteorites are the free samples, you don't have to do any major space mission for that. The composition gradient also is equal to the solar nebula, and that will tell a lot about the solar nebula. And these are found in asteroidal belt and Kuiper belt. So many primitive meteorites have a composition similar to the protosun and similar to the outer solar composition, but not exactly, because some are depleted in volatiles. As I say, the first solar system age of the solar system is defined by the first solar system object, which in short is called as calcium aluminum inclusion. So this is how, we don't have to know X and Y, but this is the solar composition, and this is the chondritic composition primitive body, and it matches 1:1. Means they have similar composition of the CI body versus the protosun, except for some volatile element, indicating that the CI chondrites or the primitive chondrites have a composition similar to the sun, and that is how they went in the formation of this evolution of the solar system. So what are micrometeorites? These are cosmic dust. These are cosmic dust because when the two asteroidal bodies also collide, they also generate huge amount of dust, and those dust also enters the Earth atmosphere. And they are in the sun. They are found everywhere. They traverse a complex path because they have to travel from the asteroidal belt to the Earth's surface, and it is estimated an average 40,000 tons of extraterrestrial material falls on the Earth. That is the estimate, and most of them are in the size less than few hundred microns, and according to half a kilogram are in the size 0.3 to reach the Earth's surface. So the extraterrestrial material can reach from the outer place to our Earth, and they can tell about the condition, how they are formed, and it provides the opportunity to study diverse sample in this case. Like in the meteorite samples, you have a very limited object. Here, tens and thousands of particles are tens and thousands of tons of particles are falling every year. So you have a diversified samples compared to the limited what we see in the meteorite. So why we are interested in the study of extraterrestrial? Because they are samples also contributed by comets. Comets, when they enter close to the sun, they release large amount of dust. And that is why they are important, and they help us in understanding how the solar planetism started. They are also tells about the condition, how the particles were formed, far away. And the challenge also is to link the type of the particles to the precursors and from which body these particles have come. The least altered cosmic spheres are important in understanding this process. So the facts I would like to highlight that cosmic dust, they are the building blocks of planets falling into the sky. They are samples of comets and asteroids. And throughout its history, Earth has accreted large amount of microscopic cells, 40,000 tons compared to the meteorite, few hundreds of tons. And they also problem only with that 90% of these cosmic dust get ablated in the upper atmosphere, where less than 10% reaches the Earth. And it also provides the opportunity to study diverse samples in the laboratory. So he was the first person, Fred Whipple, who used the term called micrometeorite, and that is the stamp released in his honor. So again, I would say that when the bombardment took place, it releases large amount of dust, not only big boulders, large amount of dust, huge amount of dust. So comets also releases a large amount of dust and gas when they enter into the solar towards the sun. So this is how the cometary tail and dust particles looks like, and this was photographed long back. And you see that dust is getting released when they approach towards the sun. And this is how the micrometeorite looks like. Once you collect the micrometeorite, the small dust particle, the size range of these particles are 200-250 microns, invisible to the naked eyes, but one can see under the microscopic, pick them, and then absorb them under the microscope and other various instruments for the further studies. So this is how the different types of micrometeorites undergo different types of ablation in the upper atmosphere due to the frictional heating with the gas molecules. And then based on that heating, they undergo from relic bearing to scoriaceous and right up to I-type particles. I will not go into the details, but just say that more than about 90% get ablated, while 10% get survive as a particle as they reach the Earth surface. And they range from various unmelted to partially melted, depending on the way they undergo heating, because they enter at a very high velocity. The velocity range from 11 km per second right up to 72 km per second. We have collected thousands from the deep sea and Antarctica also. So I will not go into the details of the classification. I will just highlight that based on the heating phenomena, the classifications are made. That's how I would say of these micrometeorites. So these are some of the primitive micrometeorites which have preserved its property and not undergone large-scale heating. So this is one of the sample graph we use in the deep sea to collect the sediment. And we lower this sample dam in the ocean from the sea surface to the depth, which is about 5,000 meters, which is the deep sea. And then it is brought back to the deck, and then it is unloaded, and then we look for a big border, and then we start sieving them. We start sieving using a sieve of about 100 microns to 200 microns because the micrometeorites are very small in size, so that they get trapped in this sieve. So once they are trapped in this sieve, this is how the micrometeorites we handpick by observing under the microscope. And then these are cut and polished as we see in the previous slides. So these are the areas where we have collected the samples for the micrometeorites, and there are 100 such locations we have targeted in the deep sea. So we have also dated those samples based on the Australian tectile micrometeorites, which gives about 50,000 years for the samples which we have collected. So collecting cosmic dust is slightly tricky because for a 2 kg of sediment we get only 1 to 3 particles of 200 micron size. And so we require a area which is cleanest environment where human intervention is low. So deep sea is one such area, and Antarctica is such area. So I will not go into the this thing, but I can say that total sediment sieved is 2 and we have 22,000 of micrometeorites right now in our collections. So we also went to Antarctica, and we also did the same thing. We melted this ice and sieved. We melted these ice blocks and eventually, and then filtered it using a sieve. And this is how we collected this primitive micrometeorite. And this is a micrometeorites from Antarctica. So we also did we also explored other options of collecting from the melted ice and all those things in the Antarctica, and there is a huge chance, huge success in the micrometeorite from that perspective. So we totally received about 50 tons of ice, and we are estimating that about 10,000 of micrometeorites to be collected during this time. So we brought back a lot of micrometeorites. So apart from this Antarctica micrometeorites and deep sea micrometeorite, there is a Norwegian, there is a person here in the center which is a Norwegian hot band in 1917. And this band, a person who name is John Larson, he was successful in collecting the urban micrometeorite. He got interested in the micrometeorites, and he's a layman, he's a general citizen, but he got interested in the micrometeorite, and he's a guitarist, but he started picking micrometeorite, and he popularized the urban micrometeorites, and that's how micrometeorites also become that it can be collected from the rooftop of the any buildings and structures. So this is how he has started. He dusted all those dust particles on the rooftop, and then he started sieving, and that's how he figured out we can do something cosmic dust from the rooftop. Don't have to go to the deep sea or Antarctica for the collection. And what experts could not do, that's what this person has done, and he has popularized this thing that speaks about his dedication of this cosmic spheres micrometer. And this is how he has photographed them. It's a beautiful photograph. He himself has done it, and he has developed how he can photograph. We also could not do it. So that's how he has reached the level where we can look at the micrometer, how microscopically it looks very beautiful. So we also has the collection from the deep South Pole water well, which is the American basin, which is 100-meter depth from the surface of this. And this is also dome extracted from the snow. And this is NASA uses this collection high flying aeroplanes to collect the interplanetary dust particles so that micrometeorite can be studied in a very different fashion. So if you look at the chemical composition, I would just like to tell you that they fall in the very small region. That is how we identify the micrometeorites chemically. Let's not go into very depth detail because it's very confusing. But what I would say is that it falls in the very narrow depth if you plot the three-dimensional graph. And if you plot this, they plot very close to the chondritic values like this. So this is how our picture looks like, X-ray images of this thing. And we did the oxygen isotopic study on it. Without going into, I would say that the oxygen isotope of the micrometeorites, condules, and other cometary particles fall with very small narrow range, indicating that micrometeorites have a similar composition as that we see in the meteorite and other primitive meteorites done by the other research. So I would like to conclude the talk by telling that there are challenges to link these particles to the specific meteorite, but then we need to do this thing, but without going into the expensive space mission. And various indicate that most cosmic different types of objects then do meteorites. They provide the information about the composition of this comet and asteroids. This is the best way to study the cometary bodies apart from asteroidal samples. The study of some important because they are the best preserved samples. Of course, many of them get melted, but there is a chance to get unmelted, and we regularly encounter some of the unmelted micrometeorites in this study. This is the background of our institute where we are still. I thank you for inviting me. Yeah, thank you, Dr.
Thank you, Dr. Rudra Swami. You gave a very interesting topic and very interesting talk. One of the reasons that I would like to ask you, was there any observations of looking for larger meteorites in the region which you have taken? Maitri, am I right?
Yeah, Maitri station, yeah.
Yeah, but there is another field station also at Antarctica.
Yeah.
And over there also, I understand there was a program for looking for meteorites which was carbonaceous. Is it so?
No, actually, GSI has a team actually which looks for the meteorite examples. But we exactly did not look at the big particles. We were only focused on this project of micrometeorite collection when we went for Antarctica. Even in the deep sea, also we do the similar things. Only when the meteorite falls on the in India, like in Rajasthan or for example in Maharashtra, somewhere we got the samples where Professor Bandari got also involved and he sends us the sample. Then I get involved in the meteorites nowadays.
In micrometeorites, have you been able to see for any carbonaceous materials?
Yeah. You get definitely some of the carbonaceous material if they are unmelted. You can, but they are very rare actually.
And can you say something about that Allen Hill meteorite?
Oh, those are collected by some of the Japanese and American teams, and I don't know. Indians actually GSI team was hunting, but somehow I think they are collaborating with the Russians. I believe rather they should have collaborated with this Japanese. The spot they are choosing, the Japanese, the way they do the survey is much better actually. These Allen Hills and all those areas. This is a defined area in the Antarctica.
Any other questions by participants here? Yeah.
So I have one question here. Like when you talk about the micrometeorites, as you said that they are very smaller than the hair also. Okay, so finding or looking for them visibly is not possible, and you normally use it microscope or those kind of equipment to see. So how does a normal amateur person, like you talked about one of the person, a guitarist, John
Yeah.
Larson, who actually popularized finding the meteorites and all these things. So, like for example, he said that he swept the terrace and he found the dust, and from there he might have found it. So, what was the method to do that things?
No, John Larson has devised a very beautiful method. He waits for a certain period of time for the dust to get accumulated on the terrace, and then he sweeps the floor. And all those dust he sieves using a 200 micron size sieve. And then he uses a magnet actually, because most of the extraterrestrial material are magnetic in nature, and they get stuck to it. And once he stuck, he has a small pocket microscope which he identifies, and then he collaborates with some Sweden university or something like that for a further analysis. That's how he does it, and he has popularized by selling them actually and writing books on it, and then he collaborates with various researchers who work on micrometeorites.
Okay, thank you.
Hello,
Sir.
so there is one student here with me. He has some questions.
Sir, you give statistics of how in every continent how much amount of micrometeorites were found. So why that huge amount of micrometeorites were found in Antarctica?
That is because, see, everywhere, even the place where you are sitting or the building has a huge amount of, but it is very difficult because it is terrestrial dust has also overtaken that. Okay, there is an estimate that in 1 square meter, one particle falls every day. That's the estimate per day. In practical, you should find 365 particles in per square meter. But in Antarctica, what happens is that once the particle fall on the ice, it gets stuck to it, and there is no human activity there, large scale. So when there is no human activity, it gets trapped in the snow and it gets stuck to it. So over a period of time, many micrometeorites get stuck, and that's why we melt the ice and get released the dust particles. And the chances are more to find the particles there.
Yes. Thank you, sir.
Well, if there are no more questions, we should thank Dr. Rudra Swami for his wonderful talk. And especially, I will like to thank you, sir. We look forward to seeing you sometime in Mumbai.
Sure, sir.
And can we give him a big hand?
Thank
Thank you, sir.
Thank you.
The next topic that we are going to have is going to be by Anand Chavan. Yeah. Yogesh Chavan, sorry. Okay. Yogesh Chavan, who is actually studying a lot of asteroids and space science. That is his topic. And the interest of this topic is he is now interested in asteroids. The very interest in asteroids means now we have seen the range of asteroids ranging from micrometeorites to mega meteorites. Mega meteorites means we have seen the largest meteorite called Hoba,
Yes.
which is in somewhere in Africa. I don't really recall, but such meteorites are there, and he is one of the researchers who is doing and who is here with you. Please corner him after this talk and ask him lot of questions. So I leave the floor to him. He's going to talk. So our talks now are going to be offline talks. People who are sitting here will have to answer you. So if you have any questions, I think Rajiv has something to say, but definitely I will take your topic also. So Yogeshji, continue.
Thank you, sir. First of all, thank you, Neuroscience Center, to give chance and my inspiration, Bharat sir. I'm very appreciate.
Carry on.
Yes, sir. So I'm a Yogesh Chavan. I'm a research scholar, and my specially topic I'm doing study on photometric state of variable stars. And actually, asteroid interest come from my inspiration, Bharat sir. When we first meet on the asteroid day in the science center, 11 science center. On that time, I will sir show some samples in actually I will on that time I will touch that asteroid. I will very fascinated about that, so lots of things. So uh, on that time I create my interest. So my topic is asteroid and space science, unlock the secret of solar system. So we know that introduction to asteroid remain, it is a solar system formation near around 4.6 billion years ago. So there are some caps. Hello.
Hey, on karo.
Hello, hello.
Yeah.
Yes.
Closer. जवळ ठेवा, जवळ.
Yes, yes, yes. Audible? I'm audible? Okay. So it is a key to understand the planetary formation, how to our origin of our life. It means so in this picture we can discuss, we can show. Okay. So there are some capsule. It means all of the preservation in the when they come from here. So we know. I am very little bit confused. Okay. So what is asteroid? Asteroid is a small rocky object orbiting around the sun. They're mostly in the asteroid belt between Mars and Jupiter. So there are a size from the meters to hundred of kilometers, just to mention, and some are called minor planets due to their size and shape. We have a three example of Ida. There are large size. Yes. What happened to?
Yeah.
Some technical issue occurs. Hello. Asteroid. Sorry for it. Asteroid location. So in this picture, you can see there are asteroid belts. So main is between the Mars and Jupiter. There are millions of asteroids on that region. Uh, so on that time we can there are three types main asteroid composition: C type, S type, and M type. So we discuss on that time. Trojans share orbit with planet mainly from Jupiter's. It means they are near to the Jupiter, so that is near to that Jupiter. Another one is near NESA, near Earth asteroid, orbiting bring to the close to the some crossing Earth path. How- It is a main asteroid type and is compositions. So C type it is from carbon. So there are 75% of asteroid to belong that our asteroid Kuiper belts. So that is a most common rich in clay, silicate, and they are very dark. Our Hayabusa mission, they are kept taking from some samples from this asteroid. S type is a stony, silicate, and nickel ion compositions. So they have a 70%, 17% of asteroid. Uh, Another is M type, is a metallic. They are mainly from nickel and iron. So in this picture, we can see the crust, methane, and core asteroid fields. So composites reveal the solar system formations. So next, how study asteroid? Why we study asteroid? First one, the inside of solar system. How to planet evolves. We know that it means there are some how to form. Another impossibility due to water. So we don't know. Still, it is a very mysterious question. To how to we know water come from our Earth. So it is so that is a very mysterious question. So they are like travel from the asteroid to maybe possibility. Planet defensory. It is understanding input risk. The main is space resources. So mineral element and future explosion. So we understand that. Recent mission like discoveries Hayabusa 2 from Japan. They are sample from the Ryugu. There is asteroid on that Mars and Jupiter in between. So they are space weathering. Mangesh sir also explained that. Mahesh sir. Sorry. They are space weathering early magnetism. Another spacecraft is ORSS from the NASA. Sample from the Bennu, study from the composition and structures. So direct sampling from the material from the analysis. So this is a Hayabusa. How to the picture. So scientific insight from the sample. So asteroid preserve the fossil record and to early the solar system conditions. Mainly gain from isotopes, temperature, pressure, and chemical histories. So in picture we can see that all of the elements they are come from the asteroids. So comparing Ryugu and Bennu, there is sample enhance understand of the solar diversities. Space weathering and surface process. So sample space weathering, they are alternate asteroids for surface via solar wind and micrometeorites. Sampling helps to understand those effects better than meteorites. Crucial for planning mining and spacecraft protection. It is complicated to the to how to observe the telescope because of they are very tiny in size and they are very rapidly moving from one place to another. So that is very critical. Understanding this process to help reconstruct asteroid history and the evolution of the solar systems. Planetary defense. So continue to monitoring near Earth asteroids. identify the impact and threats. Radar and telescopes observing track of orbit size and composition. There are two missions, NASA DART mission, so asteroid defense via kinetic impact. So asteroid as a resource. How do we take asteroid as a resource? So rich in water, iron, nickel, and the other valuable materials. A potential target to mining the support of space explorations and earth industry to develop we can take. So we have iron, cobalt, nickel. So that type of element we can get. Lower energy requirement than lunar mission. Okay. What is our future direction? So advanced detection and tracking, planetary defense strategy, robotic and human exploration, asteroid mining and resource utilization, science and science education and public engagement, in, international collaboration, expanding some sample return to the mission. Conclusion is so asteroid are key the unlocking the solar system history and the future space exploration. This study inform planetary science, defense, and resource utilization. Ongoing, the future mission will continue. Like Hayabusa 2 is from taking some sample from out of the or Mars or the near to the asteroid belts. Inside to opportunity to science and industry. Thank you.
Thank you. But before saying thank you to you once again, are there any questions that you would like to ask him? Please feel free because now it is an offline lecture. So you have a freedom to ask any question to the speaker and he should be able to answer your questions.
So I have one question to Mr. Chavan
Yes,
regarding the asteroids. So when we talk about asteroid belt, such a large belt, and because of the sun's gravity, a lot of asteroids are pulled towards the sun, and in the transition, some asteroid do land on the Earth. Okay, so as you talked about the near Earth observations, what has been done, is there any possibility of monitoring the near Earth object from India perspective?
Uh, Actually, we can use the all skies camera, so we can find out the trajectory, which means how to the asteroid move and what is our next position. Like sir mentioned that if you are using all skies camera, on that time we can find out the trajectory of that asteroid. So what is our next position? So on that time we find what
not this
which place are there land.
Yeah, so with respect to that, I think Ravi is already doing a splendid work on it, and then even Bharat sir has set up the all sky camera, and I was talking to Bharat sir a couple of times back, and we said that this all sky camera project we should explore and bring it to the students so that more and more such stations can be set up, and then we can have a collaborative approach towards the observation of these near Earth objects and
sir.
track down to where the actual meteor falls on the Earth, especially in the India location.
Yeah. One of the things which I would like to share with you, most of the asteroid observations are now available internationally. So today, as we are having a meeting here on International Asteroid Day, I would like to inform you there is a group in Delhi which are called as asteroid watchers, and they have or My good friend over there is Sovanacharya, and you can approach him. If you don't want to observe, let me tell you, in India, we want everything ready-made. So what we do is, as ready-made item, some observatories in England and America, they observe and they keep the data. Then our people here, we say that, okay, you take that data and then you look for that asteroid. So that today it has become a tabletop astronomy, which is not really astronomy. Please understand that. Real astronomy is different, and tabletop astronomy or laptop astronomy is different. Please understand this. So the data which you get, only advantage that you get is that if that asteroid has not been discovered, you get your name attached to that asteroid. So you have that option. It's not that we are not aware of it. We are aware of that situation. But our emphasis is to do these observations ourselves. Am I right or wrong?
Right, sir.
So think about this. And the objective in telling you this, Anandji, Yogeshji, is one simple thing. You can, yeah, you can probably do this kind of work from India.
Definitely, sir.
Because now we are rolling into space age.
Yes.
Our Shukla is already in space.
Oh, yes.
And he is observing so many things from space. So the objective here is, has he been able to see asteroid? These are, see, let me tell you, meeting in this place is for introspector. It's not just looking at somebody's lecture, somebody's topics. We have to evolve these topics ourselves. And in doing it, let me tell you one thing, science, you can do it if you want to do it. It doesn't happen that the asteroids fall on your head and then you start doing asteroids. Remember this. And identifying the asteroid is very good. I can tell you what software to use. Should I tell you that also?
Yes, sir.
Or later? I am just asking you this question. So why not you look for asteroids which are undiscovered, so that you will have your name to that asteroid? Not, you need not even tell me. You have to write to the asteroid naming place, and they will give you the certificate that you have observed this, and this is now certified. It takes about 2 years after you have given them undiscovered asteroid. So that is possible. But one thing which you have to also plan, that going to asteroid is one part of it, Hayabusa. We are expecting one part of it that is called Bennu. It's not yet reached in India. If it reaches in India, we will try to grab it. But then grabbing for what is very important. If you get a meteorite in hand, yeah, you can weigh it. But to know the chemistry of it, you have to do some work. So please also think about what new techniques that you can do. We have very interesting people here, you see. Rajiv is around. He will tell you with what 3 cameras he can do and all. So please also follow that. And now since our lectures are not only online, but they are offline, but for online people also they can see this. So my question to you is, why not you look for new asteroids? It's not difficult. So you have any answer for that? You have thought about something?
Yes, sir. I will make some observatory also camera in my area. On that time, I will planning for that.
Okay.
Yes, sir.
Yeah, I'm
So
sorry.
basically, you can take a help from Ravi also on
Yes.
making it, and then even Bharat
Bharat
sir
sir,
has also
Bharat sir,
made it.
yes.
And it is not only about you making it, but making more such stations,
Yo.
which will help us to propagate and have more observation done by the people, and then we can really coordinate and correlate where actually the meteor falls. Okay, today only we come to know from, like, as
From
Abhinav has
yeah.
done the session today morning where he talked about the meteor fall and the local villagers who found, and they basically updated to the people and they just found. But they're like that there are so many meteors which unknowingly people cannot see them, or not seen them, observe them, and go, nobody knows about them. So if something like that, automated cameras have been set up, we can have more number of observation captured, and then maybe later on, based on the analysis what done, we can just figure it out and pinpoint like what the effort has been started now. Probably if this goes many folds, will give us the more inputs and we can collect more number of samples for study purposes also. Yeah.
So we'll thank the speaker with an applause for his good comment. Our next speaker is Mangesh Ji Sutar, who is here. Mangesh Ji has been a postgraduate in science, and he is now a research scholar. He is studying for his PhD, one more feather in the cap, and he is also going to give a talk now. And his talk is primarily on space, impact craters. Just don't get carried away by impact craters. Everything falls.
Correct.
Since we are in a gravity, we are not Shuklas yet. So everything keeps falling. So we are in impact crater. But remember, you can do science with using impact craters. Have you been, any one of you, to Lona? Only two, three. Oh, there are people here. Very good. So now I expect you children also to see this. Once you go there, there is one tourism department there,
MTDC.
hostel there.
MTDC.
You just go to the opening of that means the terrace of that, and you will see the crater.
Correct.
Beautiful. In front of you, you see the whole lunar crater like that. And you don't know what has happened there. Such is the beauty of lunar. So that is an impact crater. So thankfully, Mangesh will talk about this and you will ask him questions. I am not going to ask you.
No. Thank you, Bharat sir, and I would like to thank Nehru Science Center, Bharat sir, and the team for giving me this opportunity to talk about on this. In fact, my lecture was little bit different earlier what I planned, but last moment I have changed the topic. Basically, this topic was I had planned multiple topics on talking on asteroid. Last year, I have given a topic on missions to asteroids, where I have talked on different missions carried out by the organization across the globe and how they have been retrieving the samples and all. Continuation to that, I thought I will talk more about asteroid belt. Then our friend already has a topic on asteroid belts and the topics on this. So I said, let me change my topic and put up a new topic. And this is again a third series of topic where I actually prepared in last 2 days about the topic where I'm going to talk about the impact craters. As we said that we have a privilege, like all the people in Maharashtra are privileged that we have one of the greatest I would say or the best impact crater available here to actually see. We don't need to go anywhere. And then we had a lot of speakers talking about Kaveri crater as well as the Luna crater and everything. But when you look at the lunar, it's just fantastic. But apart from that, I would like to talk about you about the lot of other top 10 impact craters across the globe, and how they are identified, how they are old, and how they have made impact on the evolution of life on the earth as well. Okay, along with the destruction as well as the evolution of the life on the earth. I think agenda slide is not visible, but it will start with the next. What are the impact craters? Impact craters are nothing but circular depressions formed when a meteoroid, asteroid, or comet collide with the planetary surface at high speed. This collision releases an immense amount of energy, often equivalent to several nuclear bombs, causing explosive equations of the surface. The key features of the impact craters are: first is circular in shape. Most of them are round, regardless of angle of impact due to explosive nature of the collision. Then you will lot of time you will see raised rim formed from the displaced and uplead materials. Then central peak in a large crater caused by the surface rebounding after the impact. Then you can see the ejecta blanket debris spread outward from the impact site. So you would have seen these pictures. Lot of pictures would be there. Even the earlier speakers have shared you a lot of images related to it. This is nothing but just a collection and understanding what are the impact craters. There would be a second series of this lecture also, where I'm going to talk probably in some time in our regular talks about the best visible impact craters. The stages of the crater formation is the contact and compression. The object hits the surface and energy is transferred. Then we have a excavation where material is ejected outward and upward. The modification, the crater settles, rims may slump, and central peak may form. So let's see what are the why the study of the impact craters are important, because it reveals the information about the Earth history and solar system formation. Crater often offers a stunning and nature beauty, geological interest, and scientific value. Linked of a mass extinction example like dinosaur or Chicxulub, many are accessible for field study, ecotourism, or satellite imaging. It serves as an analog for crater on another planets and moons. So like we have seen, there are a lot of craters on moon, also on Mars and other asteroid objects, even on the Io planet, moon of the planet Jupiter. So they contains the rare minerals and the valuable geological records. They remind us that the earth is vulnerability and resilience through the time. Okay, let's see what are the top 10 impact craters now. The first one is the Red Fort crater in South Africa, which is approximately 120 kilometers southwest of Johannesburg. It is a representative part of a large meteorite impact structures. The diameter of this crater is almost 300 kilometers. It ages 2 billion years. This is also known as the UNESCO World Heritage Site. This is the biggest known impact crater to us on the earth. Okay, whatever the next 10 we are going to see, they are all present on the earth and for us to see. Some of them are being buried under the ground. Like next one is Chicago crater, which is in Mexico. This crater is also an impact crater buried underneath the Yucatan Peninsula in Mexico. It is the center is offshore. If you can see here, the center is offshore. Okay, here you can see. That's why it's not visible, but that crater is named after the onshore community of Chicago. The diameter is 180 kilometers, 30 kilometers in depth. The age of this crater is almost 66 million years. And this is the crater, or I would say the impact what has been happened to creation of this crater has caused the dinosaur extinction. In fact, the most of the life on the earth was destroyed because of this particular meteor which fell and formed this crater over here. Then we have Salisbury Basin in Canada. This is also known as Sudbury structure or Sudbury nickel eruptive, is a major geological structure in Ontario, Canada. The roughly diameter of this crater is almost 130 kilometer. Again, this is age of 1.85 billion years. The geochemical evidence suggests that impact was likely a chondrite asteroid or a comet with chondrite components. This location is basically rich in nickel, copper, and platinum, and that's why you will see a lot of mining activities happening at this location. where the rich minerals like nickel, copper, and platinum are being extracted. Then we have a Poppygai crater in Russia. This Poppygai impact structure is the eroded remnant of the impact crater in northern Siberia, Russia. The diameter of this crater is also 100 kilometers. This is almost 35 million years old, associated with diamond-rich rock. This is designated as UNESCO as a geopark, a site of a special geological. If you see, this is a diamond-rich crater where you can actually go and collect a lot of diamonds over. But since this location is very, very remote and very difficult to reach and have the expeditions being carried out this location, this is more or less is untouched. Okay, only hardly some people would have visited this site and have collected the samples from this location. The next one is the Manigaon crater in Canada. Again, this crater is one of the oldest known impact crater. It is caused by the impact of almost 5 kilometers diameter of asteroid. You can see the diameter of the 5-kilometer asteroid. The crater which is formed is almost 70 kilometer. It age almost 215 million years. The crater is a multiple ring structure, ring-like lake visible from the space. This Manigan Reservoir resounds in the inner island of Plateau. This is also one of the beautiful sites. This is also visible from the space, and this is mostly visited space location in Canada for observation. Then we have Akraman crater in Australia. This is also impact structure, deeply eroded impact crater in Gwalar range of South Australia. Its location is marked by the lake Akraman in the circular ephemeral play of a lake almost of 20 kilometers in diameter. The diameter of this crater is 90 kilometers. Its age is 580 million years. The study of the current land surface and debris ejected by the collision suggests that the impact produced an uplift lift spanning roughly 40 kilometers in the crater center. The rims surrounding the inner ring may have spanned almost 85 to 90 kilometers, and the total area disturbed rock might have been widened almost by 150 kilometers, that is roughly 95 miles. If you see, this is a red rich, very rare minerals are available over this location. However, again, this is not been explored much. Only couple of research fellows have reached these locations and they have done their researches and presented about this topic. So there are a lot of such locations, such craters are available, which requires a lot of research people to visit these places and explore and find new findings about the minerals and the minerals available over their locations. Next is the Kara crater again in Russia, Arctic Circle. This is again a very remote place, meteorite in Yugorskaya Peninsula in Russia. Diameter of this crater is almost 65 kilometers. Again, this age is 70 million years. Heavily eroded but significant in geological records. Not much research has been done on this crater also. There is again lot of local research institutes are been trying to reach out these places and try to explore more about these locations. Okay, then Moroccan crater, again this is in South Africa. Its impact structure is an impact structure buried beneath the Kalahari Desert. This is similar to our Luna crater what we are talking and we are exploring near the town of Moroccan in South Africa, northwest province, close to the border of Botswana. The diameter of this crater is almost 70 kilometers. Age is 145 million years. The asteroid fragments found below the surface, there is a lot of excavation has been done and samples has been collected since it is nearer to the South African location. A lot of people from Europe as well as Britain have visited this place and collected samples and they are studying, and we are awaiting further inputs or updates on the research what they have done it here. Then Woodlick crater in Australia. Again, this one is the largest meteorite impact structure in Western Australia, estimated of 120 kilometers. Again, this age is 364 million years. This crater is also buried beneath the younger sedimentary rocks, observing the surface expression. The presence of the reddit indicates the crater size and therefore the measure of the resulting environmental catastrophe. The rare presence of reddit enables the investigation of the properties and evaluation of its potential as a new material for future technologies. So there are very rare future technology material which is like based on the reddit what is being available at this location is where people are looking for future technology or future mineral types would be available over here. And the last, the most important, what I would say, is the Lonar crater in India. As I said earlier, we have a privilege to visit this, and more people should visit and study. Last year, I had an opportunity to visit this location. I was just amazed by looking the size and the way it has been in a current condition. I think the government of India, or especially the Maharashtra government, should put some efforts, some body to maintain this particular structure over there. Basically, it's a soda lake located in Lonar, 79 kilometers from Buldana city in Buldana. It's roughly 1.8 kilometers or 2 kilometers. Age is 52,000 years. So it is not that very old, or I would say, but it's the only basaltic crater formed in a volcanic rock. The unique ecosystem, microbial and ecological study, lot of geologists, ecologists, archaeologists, naturalists, and astronomers from professional level as well as astronomers from amateur has published studies on various aspects of ecosystems of this crater lake. It is also notified as a national geoheritage monument over here. Okay, so I wish everybody and make sure that everybody visit this location and see themselves this opportunity over here. Okay, so this is the actual view, what you can see. I have collected a lot of pictures, samples. I also have got a privilege to collect some samples from this location, a small tiny meteor type set, but not got time to actually get them really observed or confirm that whether they are really samples of meteorites or not. But when you go there, you will find a lot of samples even today. Okay, so what are the impacts events of the Earth history? Like as we saw, Chicxulub impact, triggered the mass extinction of the dinosaurs, which released energy equivalent to billions of nuclear bombs. Global consequences like wildfires, impact winters, acid rain, and climate collapse. Geological evidence like iridium reached boundary layer, shock cords, tectite spread globally. Then linked mass extinction possibly tied to other extinction event, example like late Devonian or end of Permian. Planetary records like craters like Sudbury or Verdifort preserve impacts for 2 billion years old. So these are the history of what we see from some of these top 10 impact meteors craters. So, what are the future risk and the planetary defense? Like as earlier speakers have talked about the near Earth objects, over almost 32,000 near objects are being tracked, and many of 140 meters in size and capable of regional devastation. We need to set up a lot of global monitoring system. Like already NASA has the Planetary Defense Coordination Office. ESA has its own. Similarly, like I urge, like India should also look after this, setting up the monitoring system. And then NASA has done the first ever test DART mission. Like I have talked in my earlier lectures also on this topic. NASA has successfully changed the orbit of asteroid moonlet Dimorphos and providing the kinetic impactor technology. Then there are upcoming missions like ESA's Hera, which is launched already in 2026 to study the post impact effects. Like again, there is a spacecraft which is going to visit this particular asteroid for checking the post impact whether they are able to alter the orbit of the smaller asteroid Dimorphos. Okay, then mitigation strategies like what we would like to have is like kinetic impactor, what we have seen in a DART mission. Then nuclear deflection is also one of the option available, but that would be the last option what we would be using. Then the gravity tractor, which will the long term nudge, and then the civil excavation for smaller threats. Why does this it matters? The impact events are rare but inevitable over longer time scales. The planetary defense is the global insurance against the cosmic disasters. Okay. With that, I would like to open a question and answer sessions with the saying that the craters are nothing but the window into the Earth and space history. So, if anybody has any particular questions, we can talk about it.
All these precious metals in craters all over the world, but when Lonar, nothing?
Sorry?
There are all these precious metals and craters all over the world, like iridium and I don't know what, platinum, nickel. Nickel is also considered precious, yeah?
Yes.
Lonar, nothing?
Lonar is there, no?
No, but any special metals?
So I have not specifically made it about the metal which has been found over here, but there are a lot of possibility. But still, lot of study is required to be there. Lot of samples has been collected, but there is no specially mentioned about any particular precious metal which is available in the
we got the
Luna
raw
crater.
deal. India got the raw deal and all this. Yeah.
My question is very simple. We did some studies of meteor, a lunar meteor sample. Okay, I'm not talking about lunar meteorite. I'm specifically talking of lunar soil sample.
Soil samples.
And interestingly, it happened in 2005. We had taken an expedition of 11 people, 11 participants, and we removed nearly about 211 samples from along the lake. And interestingly, I have also some samples put up in the exhibition. Interestingly is it has iridium. It has platinum. And I was asked not to talk about one element, and that was gold. Now, the moment I say gold, there will be a gold rush. So I was specifically told by BRC, please avoid to say gold. But lunar sample does have that. And what we do is, I'm sorry, I'm telling you the facts, which is not my alone. It is the BARC's who has worked with me. We are working with BRC and we are doing chemistry for isotopic analysis. And in isotopic analysis, they told me don't talk about this. See, already that lunar crater is punctured.
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 Impact.
The reason is the samples go to US, the samples go to Germany, and samples go to, and they write the papers. As if we don't have anybody to write a paper on lunar.
So one more question for Mangesh. You picked up a sample. So I haven't been there yet. Can you share where you picked it up from? The periphery? How far from the water line?
So a couple of samples, I have not caught more, but 5 to 6 samples, small samples, which I thought could be a meteorite. So looking at the way they looked and the way I found them a strange part of it. Maybe they might be really a meteorite or may not be. Okay, so this out of curiosity after looking out the lot of locations. So most on the rim part, but the little bit downside, not exactly on the top, but so it was little bit dangerous since three of us has visited that place for just for exploration, and we thought that let's look up some samples if we can find out. So we collected some samples what we could thought could be the part of it, but we really don't know how to really analyze them or what is the way of doing. So I'm already talking to Bharat sir and then a couple of geologists who are known to me, and trying to see whether we can do some around that.
Even if you share pictures of them, somebody might be able to help you.
Yeah.
So that's about 1/3 the way up the crater wall.
Yeah.
That's
Down,
where you
down.
or lower than 1/3.
Lower it, yeah.
1/4.
Yeah. So this is basically on the north side of the crater, what we see, because that is the place. Because other side it is too steepy to go down.
Okay.
So this is through. I think there is a way entrance to go inside, and you can actually go down and see very well. So that is the only place where you can actually walk down. So that is really the.
Another question. It is scientifically assumed that meteorites have sown the seeds of life on our planet and probably other planets that we don't know about. What is the possibility that there are life forms in the Lonar Lake underwater that we don't know about?
Can I
has
say
anybody
something, sir?
put a submarine and gone and seen what's in there under the water?
Let me tell you, the water in that lake, actually there is a rivulet, not rivulet, a falls, a short fall there, waterfall is there. Now that waterfall is right before you enter the crater, and it is some say it is a Gayamukh or something. Stream. And that water gets into.
Yeah.
And nearby there is another kind of a bund where they have stopped water. So they say that may be one of the reasons why that lake level keeps increasing.
Increasing.
So, yeah. And the most interesting thing is what I realized when we went as an expedition. There are certain places which people say that you should only visit Lonar during summer, and that to deep summer when the temperatures are around 40-45 degrees.
Or else?
I'm telling you the reason, facts. That time the lake reduces considerably, and hence you can actually go very close to the water. And that is the point when you can really see the samples.
Ah.
Another thing that I want to tell you, the area which he is talking of is known as Kamalja. There is a temple called as Kamalja Mandir. Just outside Kamalja Mandir, there is a well, and that well is known as some Sai Suni something. Huh? That what is it? You know the name?
Sasusun.
Sasusun. That means mother-in-law and daughter-in-law. That lake is, and that well is known as that, and that's a freshwater lake.
Where is the water inside
The water one can use it as potable,
drinking water?
and lake is not too far. So these are the points which one has to see. Another thing inside Kamalja, I will come to that little further. At Kamalja, the problem is if you go inside the sanctuary and look, try to use your compass. I have brought the compass here. It is everything is here, which I am going to later on demonstrate. That wheel doesn't work.
It's highly magnetic area.
No, it doesn't. I mean, it doesn't show you any kind of orientation. Similarly, there is at another point there is an impact crater. Impact crater of what? Of the same impact which fell in Lonar, and there is one is Chota Lonar, mini Lonar. Like that, we have found nearly around 12 to 15 such spell off or spellations of that impact, which moves all the way to Kalapani of Lonar Lake. Similarly, there are smaller craters which have formed along that. Now, those are more or less, used by human beings for whatever reasons, and they are not there. And that we have done 2 expeditions in that place. One reason is this objection by BRC that I should not talk about one element. And the second thing is the ejecta is so spread out, and I congratulate Professor Bandari. His paper gives you a very clear picture of how the ejecta has moved. You get glass beads. When I said in the morning about tektites done by Ankush, is mainly because he was a part of our expedition. And these tektites are essentially molten glass. Now, how they come there? Why they come there?
Sand and impact.
No, there one thing which we forget to mention, these elements with this type of glass which is there, it needs huge temperature.
Temperature and pressure.
Yeah.
And another thing, it needs pressure. And the pressures have to be gigapascal, not just Pascal level pressures. It needs gigapascal pressures to form these elements. Those books. I have later on I will show you, because I am just trying to help Mangesh in yeah, not this, the other one. And let me tell you, these books are very interesting. And for the topic that I am talking about, this is the book where we have talked about samples. How to analyze a sample. These are classic examples. You can come and see them later. But this is how an observation must be done. Not by taking agarbatti and flowers, which is happening right inside Kamal Lonar Lake.
Yeah.
I'm sorry to say this, not that I am against any. There is another place which I said is a mini Lonar. There is Zoplela Maruti. Zoplela means sleeping Maruti. There again you have this problem that you can use the magnet, it attracts. Essentially, it appears to be a lodestone. Huh?
It's a crater.
No, outside the crater.
Okay.
And that crater is smaller. But again, there farming is happening.
Is there a crater site in Tibet?
Huh?
Is there a crater site in Tibet?
Sorry, crater?
Crater impact site in Tibet.
Tibet? No.
Because the Chinese have colonized Tibet because of its rich resources of lithium. And that is another element that comes from space.
Not that I know of. Not that I know of. But these are the facts. Now, these facts, actually, you can study there. The reason being, for a study over there, everything speaks to you. Even in that water, the algae water, it turns from blue to pink. Now, why it happens? If you ask me, I cannot answer you that way.
That's scientifically proven to be. It's scientifically proven to be due to algae.
I'm not with. I don't. Oh, put somewhere. No, I don't have it here. Oh, you need that. Okay. Okay. So these are few things I thought I will help Mangesh in mentioning these things. And it is one of the finest. In fact, I hope the government takes complete charge of that region.
Correct.
And then it is protected. As I said, punctured is most of the samples go abroad.
Yeah. Right
They
now,
don't.
They have put the fence. They have put the fence now, but that fence is of no use. Like you can
Yeah.
literally, we also jumped in the jumped into inside the fence because it was closed. The gate was closed. Nobody was there, so we can't go inside. So actually, we jumped over the fence as well. So that fence is not so big also, and there is nobody actually person also to monitor and look at. So they should actually take this site very seriously, and I mean,
And whatever is written on the publication part of it, there are no input details.
Correct.
They are all outside flamery. There is no content, how much chemicals, because all these are in parts per billion. When you put any of these elements, they are all in parts per billion. But higher parts means we call it in percentage. Otherwise, it's all in parts per billions. So one needs to look at these chemistry very clearly, and then the age determination. Age determination was done by Professor Bandari many years back in early 70s and 80s. Have we verified that? Whether it is 60,000 years or earlier? And if I tell you something which is, do you want to listen to all this?
Yeah.
When the meteor hit the place, you know what was the, what we call it as seismic velocity? When it made an impact over there,
Aftershock.
right up to Delhi, there was an earthquake.
Tremors.
The same thing, Bombay was not Bombay then. There were several islands. The shock, what we call it as Richter scale, was 6.7. And another thing, the amount of the dust that it had thrown was more than 3.5 kilometers high. And the area which had covered was over 300 kilometers. The dust had settled. So this is the scenario for Lonar. And it needs to be really looked at very carefully.
Train.
5 बज गया. I think it's tea time now. हाँ? क्या? से आ रहे हैं. हाँ हाँ. इसीलिए ट्रेन का टाइम जाएगा इसलिए. Okay. ये निकालना है हमको.
They are leaving. They are leaving because they have a train.
Okay.
They have traveled all the way from Dhanu. Yeah. Chalo, thank you.
चलो. Should we break here or what is it? Should we break here for tea? I don't know. The tea. So should I continue with?
PPT is ready. Can I start? PPT.
Just hold on. I have not even thanked Mangeshji for his talk. Mangeshji, where are you? अरे तुम्हाला थँक केलं नाही. How do I conclude?
They are leaving. That's why I said.
So, firstly, let me thank Mangeshji for his nice talk. And if you still have any questions for him, you can ask. Then I think I am asked whether I should start my talk because by 6
So in
they
fact, if you
want to
can
wind
show
up.
the second last slide over there, I had myself put some questions so that can be a second last slide of mine.
Sir, I had a small question.
Yeah.
Are there any meteorite impact craters? Means impact craters which are made from any comet impacts?
See, if you see these craters also what has been formed, these are not really, nobody knows what kind of object has been there. Okay, that's why if you see my first slide itself, you go to first slide, it talks about, I have the control. Okay, so what it says very clearly that these are impact craters, circular depression formed by meteorite, asteroid or comet. So whatever this top 10 I have selected, we do not know what kind of object would have, whether it was the form of a comet or whether it was a really object from asteroid. Okay, so these are some of this what I have put up, but there are some locations, some objects which are also probably the water which is available on the earth is also people thought that it could be basically impact of a comet, and the water on the earth has come because of some comet or the icy body actually hitting here. That is a possibility also. Okay. See this, even these locations. Okay.
Yeah.
Diameter
Yeah,
of
you
a
have a
star.
question? Carry on.
Hello. Hello.
Yeah.
If something fell from space of a metallic nature, so can we differentiate it to a asteroid core or space debris?
Yes, you can do it. You can do it anywhere, this experiment.
Yes.
If you have a soil in your, now you don't need a water over it. When you need a wet sand, you take a season ball and drop it, say from a height of, say not more than 10 feet. You will see a small crater. But as you go up and then drop the same ball, season ball, it creates a crater. Now you try doing that with different angles, not 90 degrees. You will find that crater formation is now turning from circle to ellipsoid. So this is a phenomena of an object which is going to hit what angle it is hitting. As somebody in the morning said that the lunar angle is 75 degrees. And the impact where it has made is around Kamalja Mandir. At Kamalja Mandir, you have not you get a very steep hill-like structure, so you can't even climb that. And we do not know what is the composition of these hill-like structures. But it is surely if you go there with a magnet and put it inside the water and pull out, you will find the magnetic material on your magnets. And not one, it will be covered with lot of that. Now what do you do with lunar is this kind of experiment is possible. And the happiness of that experiment will tell you where the source of our meteorite is. We are expecting around that. I cannot guarantee you that the meteorite is still there. It must have gone deeper over so many years. But this is the best bet that you can do at lunar.
Metals. So it depends upon whatever the composition of that particular impact asteroid would be there. Like for example, if you see this earlier, I talked about one of the craters here in Canada. Okay, so this is basically not this one. Before this, this one. If you see this, this is very rich in nickel. Okay, and that's why you see rich in nickel, copper, and mining, platinum. All these mines are being located in this location. So wherever you have such kind of impact craters, based on the study and analysis done by the people, you can extract those kind of material over there. Simultaneously, if you see, there is one more crater, this one, okay, Poppycock crater in Russia. This is a very diamond rich. You can find tiny diamonds, 1 mm, 2 mm diamonds also in these locations. But this location is very, very remote. No option to reach that particular location. It's not that easy. There is no nearby town. There is no settlement, human settlement at this location. So it's very difficult. That's why people do not mine these locations at point in time. It's only been visited by a couple of research people and the government of Russia who had actually done some expedition to explore this. Okay, so these all the images what you see, these are normally at a very high remote sensing images only. They are not like visited people or all this.
If you see a meteor in the sky, and if it is going very fast, like 3 seconds it went from there to there, then it's cometary. It's a part of a comet, because comets are going around the sun at like 60 kilometers per second typically, or maybe 100 kilometers per second. That's their speed. If it takes 7 seconds to go from there to there, then it's asteroidal origin, because asteroids move slower than comets. If it takes 15 seconds to go from there to there, then it's man-made. It's a rocket part. It's a satellite launch. It's space debris re-entering Earth's
spacecraft.
atmosphere. So space debris travels at 7.6 kilometers per second compared to a comet which is 60.
Okay.
Okay.
I should thank firstly Mangesh Azutar for his nice talk.
Thank you.
And secondly, I want to tell you, if we start now, we will have to wind up by 6 o'clock.
Yeah.
Because the office closes here by 6. So should I now continue my talk?
Yes, yes.
Yeah, I am
we,
not
we are
going.
eagerly waiting for Bharat sir's talk.
The reason is why I'm going to talk is I'm not going to talk about lunar. Neither I am going to talk about other craters. I'm just going to talk about your subject, if you allow me to. My topic is on meteors, meteor physics, and radio meteors. I've changed my topic to radio meteors today because I see my young friends here who want to do something in astronomy or meteors. So this topic I have chosen primarily from the point of radio meteors. The reason over here is the following. And the chemistry of meteors, why I'm talking about. You have seen meteors coming down, right? Have you seen the colors of the meteors? What color are they? Bluish. Okay, any other color? Yeah. Now these colors actually tell you about what elements may be burning. If there is an iron, you will never see it blue. If it is calcium, you will never see it yellow, bluey white. Or for that matter, when you see some meteors coming down, they will be yellow in color. That means it has sodium. So the basic of a meteor fall depends on its colors. That gives you a rough idea what is burning, but really you don't know what is burning inside. Nothing is burning inside a meteor. The burning is only the outer part. And that gives the shape of an oblate. Oblate, like egg. But the egg is stretched out at the hood end. So hood end only gets stretched because the burning part of it, there is a bow shock. You know what is a bow shock? The bow shock pushes all that thing to behind. So anything which is coming down through the atmosphere burns in this parameter. Another thing that I want to share with you, these colors can be recorded. Today you have cameras, all DSLR cameras. Am I right? Or even your mobile cameras. But you need a stand. A sturdy stand to see these objects coming down. Earlier, you know what we used to do? We used to tie our shoelace because we didn't have a manual cameras. So we had to tie it to the shutter to keep it open. And hence, the light from the stars as well as meteors, you could see it in that. Yeah. Now, I think you have manual DSLRs in which you can keep the shutter open for 5 minutes or 300 seconds. Here we talk about seconds. So it happens that much you can actually record a meteor which is coming. And another thing which you should remember, that when it comes down, it is coming at what speed? Because the minimum speed is 3 seconds and the maximum speed is around 17 to 18 seconds. So actual fall of a meteor, and again it depends on which part of the month you are going to see it. If you are going to see it in say June or July, there will be one particular meteor shower. Because of that shower, you are seeing the meteor. So it is depending, it's round the year, not just uh, Leonids means only November, Geminids means only Geminids in December. That is not the case. You see it round the year, but the names change. Aquarids, if it comes from Aquarius, like that, it comes from several constellations. So, on an average, there is a meteor fall every day. Unfortunately, we are not able to see it, record it, or otherwise. So, this is one thing that I thought I will share with you. So, I'm not going to go much in these details because I think it is churning the same too long. What are meteorites and what are they? I don't want to go into that. Introduction to meteorites is basically what elements are there. Mostly sulfur is there. Then nickel is there, calcium is there, iron is there. So these are basic in all meteorites. Now, what are meteors versus asteroids? As I told you, you have a DSLR camera with a good mount stand. Okay. Now that stand, you can actually point it to that particular constellation. And you can get only one thing that you should remember is you need a wide angle lens. What should be the wide angle? Do you know what is a wide angle lens? If I keep my finger like this is narrow angle, but wide angle is like that. So in a wide angle camera, what you get is a larger area of the sky. And then you can record all these meteors falling. We used to do it with film cameras. So at that point, we had to develop the film and see. Today, you have DSLRs. And the basic question in a DSLR camera, which I have to answer at every meteor shower is, how much exposure I have to give. It is normally, all these cameras have only maximum is 5 minutes, that is 300 seconds. You cannot go beyond 300 seconds. So you can take 500 seconds or 300 seconds, you can't get 500. So you confine yourself to 300 seconds and you take the exposure. Again, you can see it on your LED, right? So in that, sometimes you find the star trails. And amongst the star tails, if you find a meteor coming down, you have a bonus. So like that, you can do this kind of work with simple cameras, DSLR cameras, because they are all LEDs are there and all that. But again, you have to be careful. What is the care that you have to take is there is a filter, you should remove the filter out. The filter cuts the ultraviolet and the infrared. So remember this, these two filters, if they are not there in a camera, you can use that. Another thing that you have to know about, I have said what is a bright stick and all that, it's okay, fine. You can get streaks, you can, but can you find out from the photograph what is the speed? Which means you need a time. And for time, people have to either take Indian Standard Times, which we don't take, we take UT time. Because UT time is matched with an atomic, this thing, what they call it, atomic time, which is a cesium based, your, what you can call is not a pendulum, I would say, but a clock. And that is accurate to about 1 millionth of a second or little less. I'm not too sure about that, but it is very accurate. So we take UT time as that. Okay. Another thing that we don't do is we don't record the timing. One of the greatest folly with all amateur astronomers is they don't want to record. There is no log table. That is not the case with British amateur astronomers. For every observation that you do, you have a logbook. You have to write your name also. You can make it nickname or whatever and make your observation based on time, your how many exposures you want to take, what is the speed that what you have taken, all that is recorded. So in any meteor observation, log table is essential. Now all that is going into dustbins because now in the softwares that you get, all that is already there. Only now you have to fill in the seconds that you have to give. That also it takes from the image. So again, you don't have to do any extra, but you got to log it. Another important thing that you have to remember here, I'm sorry, the fonts are small, but okay, it's not that important. It tells you about the atmosphere and all. How much do we observe at the horizon? Do we anytime observe at the horizon? Now, one thing you must remember, we are seeing a star or any object through an atmosphere. And in atmosphere, it refracts the light. So you need that object to rise at a certain height. And then you can do it. Okay. So what is that height? After 18 degrees, if the object has risen above the, for Bombay, it is above 18 degrees. You have to take any object above 18 degrees and that's a good measure. Because the refraction is less, we call it as air mass. And this is the air mass that the light has to move. But we don't even care about the air mass. So we don't know what is happening in air mass. So these are basics which one need to have, and that is what is recorded in British astronomical associations. They follow it. Whether you like it or not, you have to record all that. Now this is, I don't want to go into any of those old events. I have talked about this many times. Here, what you see on the top is it's not just one meteor which hit. The top one is the one which pierced the ground, and you will see the grass around that is burnt. And nowhere it has been recorded. This we have recorded and put it in even a paper, and we called it as Balbhadra because it was a part of Jagannath meteor. So the reason why I am showing you that, and the meteorite which has fallen, it had entered nearly 30 feet down. And how we could find out? We had to take a bamboo and put it down and measure the bamboos in that meteor hole which it had created. A bamboo could go completely down of 30 feet. That's how we were able to measure. But it happened in a field. And then the data which I have put across is nothing great. It is the chemistry of that meteorite. And this, I think many of you have seen this in Parnala, and the lower one is known as a shatter cone. You can still find shatter cones in Lonar. Over here. Light कुठला आहे? हा मागे गेला. हा खालचा खालचा
आहे ना तो रेड लाईट. हा प्रेस आहे पण तो तुम्हाला खाली धरावा लागेल. खाली करा. खाली
हे कर बाबा खालचा दाखवायचं.
शॅटर कोन.
Ha. You have seen that shatter cone. It has striations all over the space and it looks like a cone like this. And that we had seen what they next to Lonar is called as Ambartale. So this is the place where you can get shatter cones. Now, how do we pick up meteorites? If you are in a desert, we form a queue, a column. That means not one observer. We have nearly 15 to 20 observers across a line. We use a string of 60 feet or 70 feet or like that, and we stretch ourselves at every 15 feet. And then we look for the soil around. Now, how do we know that we have a meteorite? I will show you here. For showing this, you need a magnet. Normally, you have seen magnets, no? There's linear inside. Here we look for a magnet which is round. And they are very heavy. I have not carried it. But you can use the magnet and look for the soil there. And wherever you get the soil, you stop, mark a point, and take a GPS. And then you use that soil, put it in your plastic bag, sealed plastic bag, and seal it up. No moisture should go. And then you can go all the way to that 60 feet, 70 feet like that, and find out how much magnet is there along that line. Very simple. You don't need extra space technology here. No, meteorites.
Meteorites.
Not micro. I am not talking about micro meteorites. I am talking about meteorites and meteorite samples. This is how we do it. And in ice, which my good friend is also listening to our talk, Rudrappa is looking at this, our talk also. So these magnets, I will tell you a very interesting part about Our soils in India, we don't have a standard. You know what is a standard? No. Every soil, if they are analyzed properly, then it is called as a standard soil. Analyzed means what is the content in that. If it is regularly that, then it is called as standard. We don't have that. They say they have done everything. Yes, I do expect that. But then we don't have, because once you pick up meteorite, from where you pick it up, you need a soil around, na? You don't have that. So then what we do? We pick up USGS, that means United States Geo sample, and then compare it. That is not authentic, because that soil is different, this soil is different. Remember that. So whenever you pick a sample, also pick the soil around that. This is important. Even if you have to do that, I'll tell you, now you have all the metal detectors, right? What do you do the metal detectors for? Not just scanning humans. You can use it for scanning meteorites. How many use it? People first and foremost, you know what we used to use? We used to use loudspeaker, old loudspeaker for magnets. And then that had a larger area, so we could do that. Now the technique has improved further. Now what they do is you make a rectangle. Again, you have to make a rectangle magnet. And if you put it on your shoulder and walk, and you have a signal in your hand, you will get a signal. See, detecting meteorites is not, it is simple, but you have to evoke newer and newer techniques. You can even detect if there is a metal pipe going down your soil. But these detectors, they don't use. The contractor says, हमारा पास नहीं है, खोदना है. So he wants his money for digging, but he will not tell you at what feet is your water pipeline. So you got to have such detectors, metal detectors, to detect even that. So even in ice, we have done this experiment for river sand. We have done it for Chowpatty sand and kept a meteorite below that to check what depth you can see. See, these are simple experiments. You don't need space technology. Huh? Depth is you can detect up to 12 to 15 inch. Yeah. 12 to 15 inch you can go below. And then another thing is we are trying it at different depths. But again, one needs to do these as experiments. At ice level, we were able to detect a meteorite to only 8 inches. So now we are looking for stronger magnets, and magnets, you know which magnets are stronger? Neodymium. They are very strong magnets. And if you ask anyone what is the strength of your magnet, he will say 60, chota bar magnet. And if you use those horseshoe magnets, then you ask them what is this, they will say 800. Beyond 800, and the measurement is in Gauss. So you must know what is the strength of your magnet. If you buy these neodymium or ceramic magnets, they have 6,000 Gauss. So if you use it up from this size, also it detects. So for magnetic study of a meteorite, you need to have a powerful magnet. How powerful? It is your choice. So this is the second. Sorry, I think I'm taking too much of your time. This is how the Westerners have found Allen Hill meteorite. Now, Hill meteorite had algae inside the meteorite. Where did it come? Inside a meteorite? Algae inside the meteorite. Yeah. Ah. I'm not. And then I just shown to the Lonar. And these are the samples that we have analyzed. The one, not the Dharamsal, but the other ones. All these stones are available. But what do you go there and collect? Nothing but Lonar Darshan. So this is what needs to be looked at in Lonar. These are the samples which you can get it. Nobody is going to charge you for that. If the foreigners can take it in tons, you can always take it in grams. And this is the number of meteorites that you can get it over a period of time. I don't want to go much. I have to come to radio meteorites fast. Only this is one what meteorites can do. You can get a frequency and in kilometer size, how many years and all that. I think earlier speakers have spoken about that. I am not going to get into that. How to recognize a meteorite? How many of you have seen scratch paper? I have got one. Pardon? And this is the kind of stuff that we use for looking for meteors. And this is, everybody knows, compass. Here I have a meteorite. And later on I will show you how it comes and sticks to the magnet. So I am keeping it here. This is for looking at meteorite. An eyepiece and light. This is for the light. This is my kit. Like that, we don't have anywhere in India you get such kits. If there are traders, I can tell them also. No? You can make a good business out of this. Chasma wala or your what watch repairer.
Watch repairers.
This is the thing. How much does it cost? This costs hardly 20 rupees. And this is the kind of containers we keep for keeping. Once you verify that it is a meteorite, we use this. Yeah, these are my magnets, and they are very, very powerful. You still see a coin getting stuck to that. Yeah, I'll have my tea now. These are our weighing pans. Digital weighing pans for measuring the weight of the meteorite. And these are different kinds of lenses which we use for looking at those features, whether they are meteorite or not. We have these features. We don't take 2 days to analyze it. These are done on daily basis. So these are our what we call it as meteorites kit. This is the paper that I have been telling you about. Scratch paper. And on that, if you move any of the magnetic material, in magnetic, the moment you say it's a meteorite, we test it here. If it gives you a gray scale, gray means when you scratch it, it will show you a line. And that line, if it is gray, then it is not a meteorite. It is a hematite. So these are few things that I thought I will share with you, that how to look for a meteorite. Is it very difficult to follow? So this is what I thought you should know about it. Just going to meteorite and then holding it in hand, yes, you can hold it in hand. Another reason which people fear is radioactivity. Is there radioactivity with meteorites? Normally not. When I say normally not, means not. But there are people who say that if it is a meteorite, it is radioactive. Where does it's not made inside an atomic reactor. It is coming from some far off place. So this is one thing that you got to remember. So can I keep this away? Okay. So then I will have a sip of tea. I have to now finalize myself in 5 minutes. I'm not going to talk anything about this. These are meteorite. Yeah, these are iron meteorites. This is the slug iron meteorite. This is called as a slug iron meteorite because it is a molten kind of iron meteorite. Can I change? This is Wittgenstein lines inside the and this is some different this stony iron meteorites. And you know, in the photograph that I've shown older coins. Now you don't get older coins. Now rupee coins are there. Or even that is not there, I guess. See, this is how the chondrites are there. They come down as balls, small balls, but they have some striations on them on the surface. So you cannot mistake that for something else. This is chondrites under microscope. I have a microscope also to look for all this. And these are tectites. Tectites are nothing different, but they are fused glass. And this is what our Ankush, who was talking in the afternoon, he was responsible in identifying tectites at Lonar. So this is general classification. Now I come to my subject. 5 minutes I am going to take. I am not going to talk about the literature, but I am going to talk about how to do a radio meteor study. And now you see an antenna here. Did you see an antenna here? On this, te dakho re. It is known as an older Yagi. You know, you used to use TVs earlier. They had antenna put up on the terrace. So such antennas, these are called as antennas. Now these antennas you can use for looking at radio meteors. And what you need next? You don't need any FM receivers. No. FM means your normal radio camera, a radio set which has an FM band where you play your FM this and FM that channels. They come between 95 megahertz to 108 megahertz. That is the wavelength for these Yagi antennas. We fix it for 93 or 95 megahertz. And then these antennas are focused toward the sky from where the radio meteors are coming. So this is the study of meteorites. How do you know? The tops is the signal that you see. And the bottom you will see as a line, that is the meteor. And this is how today you have softwares to take care of this. So you can even see at what time and at what occasion the event happened. You can find the altitude and azimuth of it. And I think, yeah, this is the softwares which are there, which you can use it for understanding the how you got the signal, you know, and it is now become more simpler because you get those dongles as SDR dongles. Now these are SDRs, Rajivji, is really you are taking the signal and directly connecting it to your computers, to the sound card. And in the sound card you get the signal. You don't have to do any extra ordinary monitoring. It comes directly inside your computer and you can get the signals as I've shown you there. And this is the way we are studying radio meteors. I think, yeah. And this is how we have planned our observation for radio meteors and for also what you can do with meteor observations. So many sections are there. You can choose your choice whether you want to observe visually, naked eye, all sky, photography, whatever you want. So I think I will stop here. Thank you and namaskar. इनका है ना वीडियो कुछ देखने का है ना हाँ दिखा दे ना हे ठेवायचं आहे आत म्हणून तुमच्याकडे दिलंय सांभाळून ठेवा ते पण त्याच्यात बॅटरी आहे हम्म? हा? कोणाचं टाटा त्याच्यावर कॅलिग्राफी
Rashideo.
हा आस्क मी
Sir. Hello. Sir,
Ah.
if a asteroid or any space or debris or object falls in our backyard of our area, and if that space debris has really expensive value, means in lakhs or maybe in crores, and we submit it to government, will we get any percentage of it worth like rupees?
No, I didn't get your question. Mangesh, can you answer this? Please come
So
again.
his question is that if such kind of asteroid or meteor, whatever falls in his backyard, he gets it. Okay, it could be worth of some like crores of rupees, and he submits to the government. Will government give some?
No. Government doesn't pay. Government only takes money. No, his question is very relevant. He says, suppose some meteorite comes and falls in your compound, and you take it and you submit it to the government. Does the government pay you for that? ते काय आहे ते कंपास हां हां हे ठेवायलाच पाहिजे ह्याच्यात ठेव ते प्लास्टिकमध्ये ठेव ते खराब होईल त्याने
ये YouTube चैट पे कोई क्वेश्चंस आए हैं क्या?
Any more question?
कोई नहीं है ना? नहीं है ना?
Okay. I must thank all of you in our vote of thanks. Dr. Anandita is here. She has been such a help to all of us for organizing this kind of a program. Hats off to you, ma'am. Thank you so much.
So last 4 years we have been doing these sessions over here. For me, it is the second year associated with Bharat sir. So now next year it will be the fifth year, and we look forward that next year we might do it in a much bigger scale. Not only the lecture and thing, but also the kind of exhibitions, some and yeah, no, but at a bigger scale and more people to come and visit and see this. Yeah. In fact, this year also we wanted to do, but due to some logistic challenges, we could not do it. But that is what we have. Yeah.
Yeah. we initially we had a thought of doing as meteor painting and meteor quiz competition for school children only. But due to these logistic problems, we have postponed that. Yeah,
Yeah,
sure, definitely. And any of you want to suggest anything to ma'am? Please, you are welcome.
Next year, please ensure that the directions of the asteroid made to the National Asteroid website. This year, the directions are pointing to and it says get direction, make sure the Number two, on that website, on the mobile Nehru Science Center, you have to upload the URL. Both have not been done.
See, basically on that link, they didn't allow to edit later on. I saw yesterday when you pointed out, the location is changed. They didn't. Correct. But then once see there is a little bit challenge from the group itself. Okay, they don't allow us to edit. Neither we do not know when we upload the data what we put how it is going to appear. We only come to the later stage. After I wrote to them back also they don't respond immediately. So there is no option to correct it. So next time whatever this feedback what we got now, we'll try to share them and see that if there is an option available next time to edit it. Because a lot of time the data when we upload it and what data appears on the website is different. Okay, so yeah, that's it's not our fault. It's basically the site which captures all this information during uploading the events details, and later on they don't allow us to update or edit it up. So it's like fixed. So that is what he's saying, that probably add Google links, YouTube links, and all that thing. Because these YouTube links have been created only one day prior. Okay, whereas that event has been listed almost 2 weeks back, almost 10 days back. Yeah.
Thank you.
Thank you.